Hello and welcome. My name is Raf Lopez, and I work with AWS Training and Certification as a Principal Cloud Technologist. We are excited to have you here. In this video, me and my friend Morgan will talk more about this course, Architecting Solutions on AWS, which we're about to take.
And I'm Morgan Willis. I also work with AWS Training and Certification as a Principal Cloud Technologist. Raf and I are on the same team, and we designed this course to help you learn more about how to think through customer requirements and then select the best AWS services to meet those requirements.
Each week, we'll start with a customer call between a solutions architect and the customer. In this initial call, the solutions architect will learn more about the current architecture state, the customer need, and the implementation requirements. From there, we will start thinking about a solution while teaching you which AWS service to choose for a specific scenario.
During the first week, Raf will play the role of the customer. This customer works at a company that sells cleaning products online. That company currently has a service that processes online orders and is experiencing some issues, and they would like to find a solution for bringing better resiliency as well as migrate the service to AWS. You can expect to learn about services such as AWS Lambda, Amazon SQS, Amazon SNS, API Gateway, and more.
On the second week, Morgan will play a customer working at a software company who provides a solution that uses QR codes for loading restaurant menus. This customer wants to enhance their product by adding data analysis for better business intelligence solutions. During that week, I will be talking about AWS data analytics services, and you can expect to learn more about data ingestion, processing, and visualization with the usage of managed services like Amazon Athena, Amazon Kinesis, Amazon QuickSight, and more.
During the third week, Raf will be playing a full-stack developer from an insurance company. That company has some workloads running on premises that they need to find a way to migrate to a hybrid environment between what they have currently running on premises and the new AWS environment. During that week, I will be teaching you about services like AWS Direct Connect, AWS Database Migration Service, NAT Gateways, and more.
On the fourth and last week of the course, Morgan will be playing a customer in need of a multi-account environment. The customer is a marketing agency that has everything running in the same account while providing workloads for its own clients. During this week, expect learning more about centralized logging, multi-account strategies, and account vending machine, all powered by AWS managed services for governance and security, like AWS Organizations, IAM Identity Center, AWS Service Catalog, AWS CloudTrail, and more.
AWS has a lot of different services, and figuring out which ones to use when and assemble them into a solution that meets a set of requirements is something that takes practice. This course was designed to help you understand the differences between the AWS services, so you can more easily figure out which service to use to meet specific use cases. That being said, we are not diving deep into each individual service. Instead, we are approaching which service to use according to a customer need, and we'll teach you about some of the different features and details about the services along the way. We will also have readings between the videos where you can find deeper information about the services. We hope you enjoy, and welcome to Architecting Solutions on AWS. Hi there, my name is Morgan Willis, and I'm a Principal Cloud Technologist here at AWS. As you're working your way through the course, you may want to get in touch with the AWS community or reach out to the team who created this course. This video is to help you understand where to direct your questions. You may have questions about the AWS services you are learning about, or you might find that you have a specific question about something you are working on related to AWS. For these types of questions, I would highly recommend that you check out Repost. Repost can be found at the URL repost.aws. And this website gives you access to a vibrant community where you can ask AWS-related questions and get answers from others in the community. Something to keep in mind about our courses is that AWS innovates at an extremely fast rate. This means that some of our course content can get slightly out of date when new features are released or if the AWS console changes. If you see any out-of-date, incorrect, or broken content, please enter a ticket at support.aws.amazon.com/pound/contacts/AWS-training. An example of something you would enter a ticket for is, a hands-on tutorial, or exercise that has instructions that are out of date or are no longer correct. If you have something going wrong within your AWS console while working through an exercise or lab, that is not something you would enter a ticket for, as we will not have access to your specific AWS account. The ticket system is meant as a place to report issues with our courses. Finally, if you have a question about a course completion certificate or anything related to the learning platform you are taking this course on, please reach out to the learning platform support to resolve these issues. I hope this helps you find what you need. Have fun, and see you later. Welcome to week 1 of the course. This week, you will hear from our first customer looking to get guidance on architecting solutions on AWS to meet their specific business need. The way this course is outlined, each week will follow the same pattern. This course involves a little bit of role-playing for us instructors, as we will both play the solutions architect or the customer at different points in the course. We will simulate a simplified version of what it's like for a solutions architect to get a request from a customer and then design a solution. We will have the solutions architect call the customer a few times throughout each week to get further clarification on requirements. This first week, I will be the solutions architect and Raf will be the customer. The way it's going to work is that we first hear from a customer about their business need and requirements. We will have a conversation as we gather their list of requirements, and then one of us instructors playing the solutions architect will lead you through the various components that could make up a solution and outline an architecture that could work to best fit the use case. We will compare and contrast different AWS services that could potentially be a piece of the solution you will recommend to the customer. Remember, with AWS, there is oftentimes no one singular right answer. It can depend on what the use case is, what the requirements are, and what the customer is optimizing for when it comes to how you build your architecture. Once we've had much discussion around different AWS services and we have chosen the services that are the best fit for the use case presented, we will put it all together in one solution. With AWS, it's important to understand the different features and use cases of the services, so we will do our best to help you understand our thought process behind why we chose each part of the solution that we present. When building on AWS, each service that you use is like a building block that is a piece of the overall solution. So, in the spirit of thinking that each service is a building block, we will be building our architecture out using literal blocks. Each video, we will add blocks to the architecture by adding the physical block to the desk in front of us, and we'll have a top-down camera to get an overhead view of the architecture at every phase. And at the end, we will have the entire solution built out block by block. From there, we will present the architecture to our customer, and then us instructors will both be putting our solutions architects' hats on, and we will talk about how to optimize the architecture and discuss ways we could have done it differently and ways to take it to the next level. I want to call out here that in this course, we are not building solutions on AWS. We are designing one of the potential solutions, and there are likely other correct solutions as well. It's also good to note that we will at times overlook or oversimplify things on purpose to make space for learning. In the real world, you would also likely need to build a proof of concept for your customer after building a design. In this course, we are trying to show you the why and less of the how on architecting solutions on AWS. Remember to check out the text-based readings between the videos where you can find more information about the services we cover, as well as links to things like blogs and tutorials where you can dive deeper into the content that you find the most relevant to your own learning. This course is mostly about how to put solutions together and some common patterns for solving common problems. If you want deeper information on these services, we will link out to resources where you can continue your learning. All right, I hope you're ready to dive in and begin architecting solutions on AWS. Let's call our first customer and have a conversation about their workload.
Hi there, I am a technical architect here at Any Company e-commerce. Happy to meet you.
Hello there, nice to meet you too, because we've clearly never met before. My name is Morgan, and I'm a solutions architect here at AWS, and I hear you're trying to move a specific workload to AWS and are looking for some help on how to get there.
Yeah, that's true. We've been working on moving our systems to AWS over the last few years, and we already have a decent amount of things on AWS, but we have mostly just moved those workloads to AWS without much, refactoring. Now we have an opportunity to completely rewrite our next workload as part of a migration we are doing here.
Oh, that's awesome. I can definitely help you with that. So it sounds like before you were using a lift and shift model for migration, whereas now you're looking to use more cloud native technologies so that you can better take advantage of the cloud and its benefits. Can you tell me more about your business and the project that you want help with?
Yeah, absolutely. So we sell cleaning products all over the world, and we have a website and an app open to the public where customers shop and place orders. We also have a website for buyers to purchase our products wholesale for resale in their own shops. All of the orders from across these various front ends come into our orders service hosted on premises that validates, authenticates, accepts orders and processes and stores the order in a database. And then also makes calls downstream to other services like the inventory fulfillment and accounting service to reflect the confirmed order. The inventory fulfillment and accounting services are already hosted in the AWS cloud, and the orders service is the last major piece that needs to be moved over.
Okay, all right, I understand. So, what about payment processing? Is payment processing in scope for this project?
No, we use a payment gateway service. So by the time this request hits the backend, the payment will already be taken care of. We just need to accept the order into our backend services, perform some business logic, and then send it to the downstream services for further processing.
Okay, great. Thanks for that context. And how are you accepting requests for the services? Do you have a web server running somewhere, or are you hosting an API that's the entry point for this? What do you have going on?
Yeah, that's a good question. Right now, we are using a web server that is also hosted on the same server with the application to route requests to the backend service.
Okay, cool. So, what about storing orders that come in? What type of database are you using for those orders?
Oh, the database, right. We are currently using a MySQL database on-prem for this service to store the order data. The other downstream services will work with their own data store. So we are open to changing databases, but it's very important that to be highly available and durable. We only store the orders in one table, so maintaining a whole MySQL instance for this has been a bit of a time-consuming task for the minimal data we store in the database. I think ideally we would have a database in AWS that is simpler to manage and it's a little bit of more hands-off, so we don't spend that much time maintaining it.
Yeah, that makes sense. It sounds like we can probably find a simpler solution for you. So, I'm hearing that you want to host a web backend on AWS, as well as a database for the order service. And I'm thinking we will try to go serverless for this as much as possible, given it sounds like you want to reduce any operational overhead. Can you tell me some more about the problems you're trying to solve with this migration? What types of pain points are driving your desire to completely rewrite this service instead of just lifting and shifting it like you did with the other services?
Yeah, so most of the issues we run into for this app come from the application layer because of the way all of this business logic is all tied together in one orders service. When that service gets overloaded, it can slow down or even crash. This means that orders are slow to get accepted and sometimes fail when the application becomes overwhelmed. We have a hard time scaling on premises to meet our demand, and we are looking for a solution with automatic scaling that doesn't require time to set up or operate. There is also an issue where if the application crashes and a process is finishing up making the calls to downstream APIs, so let's say the first call to the inventory service encounters is successful, but then the application crashes. Right? This means that the application doesn't get the chance to send the information for successfully processed orders to the downstream services like fulfillment and accounting. So in a nutshell, most of our problems come from not being able to scale quickly enough to meet demand, and then secondarily our components are too tightly coupled, so if one API call fails, then the next few ones don't get completed. This causes inconsistency with our orders data and causes headaches for our customers.
Yeah, okay, I got it. I can definitely see how that would cause some frustration and why you would want to fix that. So I'm hearing that you want managed scaling in place and that you want this application to be decoupled to increase resilience. I also have as a requirement that we need to come up with a solution for sending the downstream calls to those other services independent of each other so that they don't impact the orders processing. Now, what about demand for this application? Is it a steady demand with low volume or high volume? Is it cyclical or do you have a spiky demand?
Yeah, our app has pretty spiky demand. When we launch online sales or send out coupon codes, we see like huge traffic. But then at other times, we have essentially zero demand. And as you know, it can be hard to operate on demand like that because we have to over provision hardware in the data centers, right? We have to buy more servers and put it there.
Cool. All right, so no problem. We can try to come up with a solution here that will scale up when you need it, and then more importantly, scale back down when demand goes down, which, like you're saying, is harder to do on premises where you have to over provision things all the time.
So we are ready to begin planning to move this orders service to AWS. And as part of this process, we are open to rewrite the code to go cloud native whenever possible. I think that going cloud native would let us take advantage of the benefits offered by the cloud. We are also hoping that as part of this migration and refactoring, we will be able to fix some of the issues we have been encountering in the code.
Yep, I think I understand what you're looking for. Now, beyond all of that, do you have any other requirements for this that you have laid out already?
Yes, I do. This is something we have been spending a lot of time talking about internally here in meetings. I think that at this point we have covered most things, but something specific is that we want monitoring and logging to be easy to put in place. And ideally, we want everything to use the same logging system.
Okay, great. So, are there any other aspects of this that you're trying to optimize?
Yeah, one more thing I can think of right now is that we want to try to optimize this solution for cost and performance as much as possible.
Wow. All right, so you are super prepared.
Thank you.
That is awesome. I have all of my notes up here, and I'm going to take those and go digest this information. And I'll likely be calling you for more information as needed as I have questions as I'm designing this. I hope that's all right.
Absolutely, yeah. So thank you for helping us designing something that meets our needs. Looking forward to see what you come with. Call me anytime if you have any questions, okay?
All right, thanks.
All right, bye-bye.
Okay. So we've just heard from our customer, and there are a few key points I want to discuss before we begin designing this architecture. The customer stated that they are moving from an application hosted on premises to a service-oriented application hosted on AWS. Some services have already been migrated to AWS, and they're looking for advice on their order service, which currently includes a couple of different functions and is acting as one monolithic codebase. Based on my notes, this is what their on-premises solution looks like right now. It's good to keep this architecture in mind as we go along so that we don't forget anything. Now, a big takeaway I heard from the customer is that they want this service to be more reliable and resilient so that if one part of the application fails, it doesn't impact the other processes running downstream. The current problem is that the order's acceptance and downstream calls are all handled by one code package as a monolith. And we need to break that into multiple components and have them loosely coupled to avoid having a single point of failure like they have now. Now for the requirements that we gathered. First off, managed scaling for compute and database components when possible is going to be important. This one makes me immediately think that we will be using serverless services as much as possible. Serverless services scale in and out with demand on their own without the customer needing to step in. For some services, you can set parameters around how scaling happens or set limits to scaling, but it's totally managed behind the scenes. So I'm going to keep serverless top of mind as we go through the different potential components, which, spoiler alert, means I probably won't be looking at EC2 a lot for this solution. Now, for the next requirement, we have decoupling components to maximize resilience. This one is really about eliminating single points of failure for the app. I'm thinking of breaking the order service down into multiple components and following an event-driven architecture so we can more loosely couple each piece. What I mean by that is that the order acceptance, order processing, and then the downstream calls should all be independent of each other so that if one has a hiccup or fails, it won't take down everything else. We'll keep talking about this throughout the week. Another requirement from the customer is that they wanted centralized monitoring and logging. They want to be able to see the state of their application all in one place and have a centralized point to come to for debugging or troubleshooting. This won't be a problem, especially with the serverless services, which all tend to be integrated with Amazon CloudWatch and Amazon CloudWatch logs. Then finally, there's our last requirement, which is all about optimizing for cost, performance efficiency, and operational overhead. Cost is going to be one of the main drivers for what services I choose, and then secondarily, performance efficiency and operational overhead. It can be difficult to balance these things, but again, serverless really tends to optimize in the direction of these three things anyways, so I'm not too concerned here. We will build out the architecture first piece by piece, put it all together, and then circle back and talk about the different choices that we can make to optimize for cost and performance. Let's take a closer look at the orders service that is currently running on premises and think about it from the perspective of compute. If we pull up the architecture diagram for the existing solution, we need to host this code somewhere using a compute service, so we will tackle that first. This orders service is currently running as a single code package and is running across multiple virtual machines in the customer's data center. We want to break this up into smaller pieces so we can decouple each component in the application. And we also want to pick a compute service that will optimize for automated scaling, high performance, and reduced operational overhead. So right away, I'm thinking, let's go ahead and bring up the AWS webpage for compute and take a look at the different compute services that we have available to us. AWS is always changing, so it's a good idea to take a look and see what is out there so that we are aware of all of our options. So we've navigated to aws.amazon.com/products/compute, and I'm going to go ahead and scroll down here to this handy table that lays out the different compute services from a high level and tells us what the use cases are. So we can see here we have some different categories. We have the first category, which is instances. And under this one, you can see we have EC2 listed, and we also have services like Lightsail and services like Batch. Now, with these services, these are going to have instances, which meaning that they are not serverless services. So things like EC2, that's our virtual machines on the cloud. We have Lightsail, which is basically an easier way to use EC2 for specific use cases. And then we have AWS Batch, which is for batch processes. So we can see already that each individual compute service is meant for a specific purpose. So now if we keep scrolling down this page, you can see that the next category that we have is for containers. And under containers, we have a couple of different AWS services here as well. You can see we have Amazon Elastic Container Service, which is a container orchestration tool. We have Amazon Elastic Kubernetes Service, and then we also have the compute platform AWS Fargate. So these container services are pretty interesting. I think that these could potentially be good for our customer, but let's go ahead and keep scrolling down here. Then you can see we also have under the serverless category, which this category is particularly interesting for our customer, knowing that we want to use serverless, we have AWS Lambda listed here. So it's just a good idea to know where to go to look for information about AWS. So we're going to be pulling up these web pages throughout the course, so that way you understand where you can go to find more information. Now, before we discuss some of these serverless options, I want to talk about why I am not considering EC2. A lot of the time, people look to EC2 as the default option. You can spin up virtual machines on demand, and you can choose your OS and take full control over what happens on your instance. And this is all great. And when I think about the customer's application, we could, of course, lift and shift the entire order service directly onto EC2. A solution could use EC2 and work just fine. Now, here's the important part. Just because a solution could work doesn't mean that you should stop there and call it a day. There can be many potential solutions to a problem, and we should evaluate them all and see which one is the best fit, not which one is a fit. That being said, and knowing we want to make this a serverless solution because of the requirements our customer gave to us, let's first take a look at the AWS container services. For this category, we have Amazon ECS and Amazon EKS, both of which can be run on Amazon EC2 or on AWS Fargate, which is a serverless compute platform for containers. Running the orders application in containers on a serverless compute platform like AWS Fargate could be a good pick here. The scaling is totally managed, logs and metrics go to CloudWatch, performance efficiency is high, operational overhead is low, cost can be kept low as well using things like AWS Fargate Spot. Everything looks good. The only thing is, I don't know if our customer is interested in using container technology, which could be a blocker for this option. Now, the next compute option I want to consider is AWS Lambda. Lambda is cloud native, meaning that it was built specifically for the cloud and therefore is built to take advantage of all of the benefits that the cloud has to offer. AWS Lambda is totally serverless and scales up and down automatically without a lot of operational overhead. You may have to tweak some configurations over time depending on your workload, and there are things you can do to make scaling happen faster and make your code run faster. But overall, the operational overhead with Lambda is significantly lower when you compare it with options like EC2. When using AWS Lambda, each request or event that comes in spins up its own instance of a Lambda function. The Lambda function runs in a micro VM powered by something called Firecracker, and this micro VM will shut down on its own after a period of time. So if you have no demand, you won't be dealing with idling instances of your application code running. It only runs when it needs to run. Just like AWS Fargate, scaling is managed, operational overhead is low, performance efficiency is high. Let's go ahead and call our customer and ask them what they think about using containers or AWS Lambda.
Hello, how are you doing, Morgan?
Hello there, I'm doing great. I'm looking at what compute services to use for your order service, and I ran into a question that I need you to answer.
Sure, yeah. What's up?
Well, I am choosing between using AWS Lambda or AWS Fargate for hosting your order service application code. The thing is, AWS Fargate requires that you use containers and a container orchestration tool like Amazon ECS or Amazon EKS. So my questions are you familiar with these services? And are you open to using container services to host this workload?
So yeah, I am familiar actually from a high level at least. I do know we don't currently use containers at our company. We don't really have the skill set to manage containers in-house right now. Our developers and DevOps are already beginning to learn the basics for cloud native stuff like Lambda and DynamoDB, since we have already started some migrations. I think we might be using Lambda in different parts of the business now that you said.
Well, all right. I think that's all I needed to know. Thank you.
Yeah, sure. Thanks, anytime.
Okay, so that is really good information to gather from our customer. Now I know that Amazon ECS and AWS Fargate are not really going to be the best choice for this, even though from a technical perspective, it would work fine. That being said, let's go ahead and add our first block to this architecture. AWS Lambda. Lambda will host the application code for the order service. This will require a rewrite of the code so that Lambda can invoke it on request, but I don't think that's going to be an issue. When you use Lambda, you create what is called a function, and then you upload your code, you select a trigger for the function to run. A trigger can be some sort of event, perhaps coming from another AWS service, or an external event like an HTTP request through an application load balancer, or coming through something like Amazon API Gateway. API Gateway is a natural choice to front the Lambda function for our customer's use case. This means that they will no longer need to maintain a web server to accept the requests from the clients. Instead, you can define an API and API Gateway and set up the HTTP methods and resources to forward the incoming requests to the backend. API Gateway can do a lot more for us as well. For example, according to my notes from the customer call, the orders processing service is currently doing authentication on the request and basic validation that the data is in the right format. API Gateway can handle these sorts of things for you. So that means less code has to be written to do those tasks. And I can actually picture our customer reacting to writing less code for this migration. I think that they are going to love that. Logs and metrics from both Lambda and API Gateway can be easily sent to Amazon CloudWatch and Amazon CloudWatch logs, which can then be analyzed in one central place across the instances of your function. Both API Gateway and AWS Lambda have managed scaling as well, which are good choices for cost effectiveness and have high performance efficiency. This seems to meet all of our requirements and doesn't involve introducing a new technology into our customer's stack, like containerizing their applications. So, that being said, time to add the second block to our architecture here. API Gateway is going to front our compute choice AWS Lambda. We are going to add more blocks to this setup as we go throughout the week to complete this architecture. We're just getting started with this solution, so let's keep going. In this video, we are going to explore the service AWS Lambda. You can see that I am already in the AWS console, and I'm going to navigate to the AWS Lambda service here. And then from this page, this would display any existing Lambda functions that you already have. What we're going to do is we're going to create a new Lambda function and then simply explore the different configurations that we have available to us. So I'm going to go ahead and click on Create Function. And then from here, I have this Create Function page where I can then give the function a name, which I will go ahead and just name my function. And then I can select the runtime. So Lambda supports a variety of languages to write your code in, and these are our supported runtimes. So with Lambda, this is a serverless service. So that means that whenever these functions run in an environment, this language runtime would already be there. So we have some runtimes like .NET 6, .NET Core, Go, Java, Node, Python, Ruby, and if you scroll down, you can see some of the other versions of these languages that are supported. And you can also support a custom runtime if you wanted to bring that on your own. You could bring a custom runtime if one of the languages listed here is not the language that you're using. For this example, I'm going to go ahead and select Python 3.9. And then I'm going to scroll down and we can take a look at some of these other configurations we have here. We are going to expand this change default execution role. And this execution role is going to be the permissions that the Lambda function has available. So for example, let's say you have in your Lambda function, you have some code that makes a call to the AWS SDK like SNS, for example, or simple notification service, or even like putting an object in S3. You would need to create an IAM role for that contains those permissions, and then the Lambda will assume that role whenever it is run. So for now, we're going to create a new role with the basic Lambda permissions. And if we also expand this advanced setting here, you can see there are some additional configurations you can make. All of these are not going to be things we're using right now, but one I want to call out is this enable VPC functionality. So you can run a Lambda function inside of a VPC if you would like to. And so that would enable you to access private resources. So for example, if you had an RDS database in a private subnet, you would want to run this Lambda function in your VPC to enable that communication. For now, we're not going to do that. Let's go ahead and click Create Function. All right, the function has been successfully created, and from here you can configure your Lambda function further. Up at the top, we have this function overview, and this shows you where you have any triggers listed on the left, the function in the middle, as well as any layers, and then the destination on the right. I'm going to go ahead and first explore the triggers. So if we click on Add Trigger, we can then select a source for this trigger. So there are a lot of different sources that can invoke your Lambda function. We have things like API Gateway, which is one that we've already talked about. So this is the one that we are going to select for this. But before we do, let's explore a couple of others. Notice how you can also invoke a Lambda function from an application load balancer, or from CloudFront, or CloudWatch logs, or code commit, DynamoDB, EventBridge, Kinesis. It just keeps going. There's a super long list of potential triggers for your Lambda function. And then if you scroll down, there's another part here coming from AWS EventBridge, which is an event bus service that helps you integrate with software as a service or third-party applications. So you can see that you can also set up Lambda functions to run in response to events that are happening outside of AWS that come through Amazon EventBridge and then would invoke your function. For now, I'm going to scroll back up and I'm going to go ahead and select API Gateway. From here, you can select an existing API or you can create a new one. I'm going to go ahead and select Create a New API. Then we get to choose between an HTTP API or a REST API. The HTTP APIs do integrate directly with Lambda, and because we don't need to do any sort of transformation on this simple proof of concept, this exploration of the service, I'm going to go ahead and select the HTTP API. And then for the security, I'm going to leave it to be open, which means that anybody can invoke this API. Then I will go ahead and click Add. And whenever I click Add, the API is actually being created in API Gateway as well. So if we go here, you can see we now have an API endpoint. So that's where you would send any requests to actually invoke this function. But I haven't really made this function do anything yet, right? We don't have any code uploaded. So in the AWS console, we can click on the code tab, and then I can scroll down, and we have a little code source editor here. You can see here we have the Lambda handler, and this is where the Lambda will begin its execution. So from here we have an event and a context passed in. The event is going to contain information about the payload of the request, whereas the context is going to be information about this specific execution. And then in here is where you would have your code. So this would be your business logic. This would be things like writing to a DynamoDB table, or maybe it would be writing to an SQS queue or doing some business logic that has nothing to do with AWS, right? We can bring all of that code into our Lambda function. This code source editor here is really just for small functions. If you have large code packages, you likely wouldn't be editing your code directly here, but we're gonna go ahead and leave this just with the sample text that says hello from Lambda, since this is just gonna be a hello world function. And then if we scroll down, we can view some of the other information about this function. And if we scroll back up, we can then click on the configuration tab, and then we can see the other types of configurations we can make. So for example, I can have environment variables that my code could access, which are key value pairs. I can tag this function as well, which is another type of key value pair that might be used for things like billing and for filtering your resources or tracking your costs. Then we can also have things like monitoring and operations. So right now we can see we have logs and metrics are enabled, and this is going to send your logs to CloudWatch Logs. That's where you can go to find the logs that are generated by the application, including your application logs. So you have like your Lambda runtime logs as far as like your Lambda was invoked, but then you also have logs that are generated from your application. And then there's a bunch of other things here as well that you can configure. But again, for now, we're just going to try to keep it simple. And what I want to do is simply invoke this function and see if we can get a response. So to do that, I'm going to click on the test tab here. And then I want to create a new event, give this a name, test. It's a hello world template. So we're just going to leave all these values here. And then I'm going to click the test button. And if we expand the details, we can see that it did run and it said hello from Lambda. And from here, we could go ahead and send requests through API Gateway, and this would run our function. Please check out the readings where you can find more information and links on where you can get hands-on with Lambda, run some experiments in your own AWS account, and figure out a little bit more what this service has to offer. Time to think about databases. Before we dive in, let's think about what we know already about the customer's current setup and their goals. We know they are currently storing orders in a MySQL database hosted on premises. We heard from our customer that managed scaling and reduced operations is really important. We also heard that they are really storing some pretty simple data in their orders database and that other systems use their own databases. Let's go ahead and pull up the databases page at aws.amazon.com/products/databases on AWS and get a quick overview of what's out there. All right, so if I go ahead and scroll down, we have another handy table here, and you can see that we have a bunch of different types of databases. And all of these are purpose-built, meaning that they were built with specific use cases in mind. This is important as you evaluate each database for the solution. You may find that by choosing one database type over another, you can save a lot of time in database setup, maintenance, or even coding if the database supports features that you may have otherwise built into the application side. So if we go ahead and run down this list here of the databases offered by AWS, we can start to narrow it down. So we can see on the left-hand side that we have the database type as relational, key value, in-memory. So all of these are the different types of databases. If we start up here at the top, we have our relational databases, and these are going to be the type of database that people generally think about when they think of databases. So for things like traditional applications, where you have a bunch of tables that have a schema and all of them relate to each other, you can run SQL queries on the information in those tables. So for that, we have Amazon RDS, or Amazon Relational Database Service, Amazon Aurora, which Amazon Aurora has an option called Amazon Aurora Serverless that might be good for our customers, so I'm going to keep that one in mind. And then we also have our data warehousing, which is Amazon Redshift. Now, One category down here, we have the key value databases. And for this one, we have Amazon DynamoDB listed. Amazon DynamoDB is also another serverless database, so I'm going to keep that one in mind as well. And then as we keep going down this list, you can see there's other categories like in-memory. This is going to be for caching. So for caching, we have things like Amazon Elasticache. That's going to be a different use case than something like a relational or a key value database. So you can see that we have these purpose-built databases for specific use cases. And if we keep going down here, you can see we have even really specific use cases like a graph database, which is going to be the database Amazon Neptune. So instead of trying to make a relational database work like a graph database, you could just use the graph database. So after quickly narrowing things down here, I am really going to take a good look at both Amazon DynamoDB and Amazon Aurora Serverless as our two database options. First up, let's talk about Amazon Aurora Serverless. Amazon Aurora is a relational database that is available through Amazon RDS, so it's kind of under the Amazon RDS umbrella. Aurora is built for massive scale and for performance. This is really a database that is meant for large workloads that you would usually run on a commercial database that can offer the level of data storage and performance that you would need for enterprise applications. It supports MySQL or PostgreSQL workloads, which is part of the reason why I wanted to look into this service. I know that our customer is using MySQL, which would be drop-in compatible with Aurora. We also know, additionally, the customer wants to reduce operations. Amazon Aurora is a service that is not totally managed in the sense that you can use it in a way where you are managing the underlying instances, such as planning DB instance sizes and resizing DB instances or adding more DB instances as the workload changes. Those are the types of management operations that you could make. This is where something called Amazon Aurora Serverless comes in to simplify that. This would reduce the operational load that you may normally associate with using Amazon RDS because you can determine the appropriate minimum and maximum capacity by running the workload and checking how much the DB instances actually scale. Another great thing about Aurora Serverless is that you only pay for what you use because it scales in and out as demand changes. This would be a good fit for our customers' spiky workload because they don't need the database running at full capacity at all times. All right, so using Amazon Aurora Serverless would be a decent fit for our use case. Now let's talk about our other option if we are looking into Amazon DynamoDB. DynamoDB is a non-relational database option that is also designed for massive scale and high performance. Aurora and DynamoDB are similar in that way. They are both designed for scale. DynamoDB is best used for applications that are looking to store key value data where the application has potentially a high number of concurrent users and connections to the database. It is also serverless, but not as a feature like Amazon Aurora. DynamoDB is fully serverless and it scales the underlying storage of your data under the hood. There's nothing you need to do to scale the storage of the data, which definitely helps with reducing operational overhead. For example, I used to be a database admin, and I was always working on adding more storage to database clusters or adding more table space for quickly growing data sets. Those types of administrative tasks just simply don't exist for DynamoDB because all of that storage scaling is handled for you, which is great. Instead of worrying about data storage, you instead can focus on your application's usage patterns and throughput needs. This means you can provision the throughput needed ahead of time, meaning how much data you read or write per second. Or you can use on-demand throughput, where it scales up and down as your demand changes. For a spiky access pattern like our customer has, the best fit for them would be to use the on-demand mode for their DynamoDB tables. Beyond throughput, when working with DynamoDB, you should have a good understanding of your data access patterns. So what I mean by that is what types of queries is your customer running against their data? With DynamoDB, you don't create a database with multiple tables. Instead, you have tables that are standalone with no built-in ability to do joins across these tables. You instead model your table with indexes that allow you to run the queries that you need. This is a bit different than you would do with something like Aurora, which uses standard SQL queries and has the ability to do complex SQL queries across tables. With that in mind, DynamoDB is not a great fit for every use case. If you do need complex SQL queries or joins, then it likely isn't the best choice. Let's go ahead and call up our customer to discuss this.
Hello, Morgan. What's up?
Hello there. I'm working on building the architecture here for the order service, and I have some questions for you about the types of data queries that you are making to your orders database.
Go ahead. What do you need to know?
Well, I'm looking into potentially using DynamoDB for the database, but to really use this service the right way, you need to know what queries are being made up front so that we can model a table correctly. So, what queries are being made against the orders database right now?
Yeah, we need to be able to create, read, update, and delete orders based on an order ID. We also need to be able to pull back any orders associated with a customer ID. All in all, it's a pretty simple table. We are not doing anything like super complicated or, yeah.
All right, cool. So there are no complex cross-table SQL queries that are usually run as a part of your day-to-day?
Correct. We use the table as a place to stash order information, and that's really it.
Awesome. All right, I think DynamoDB would be a good fit for this use case, but I need to think it through a little bit more to make sure that I'm understanding all of the different features and make sure that it's the best choice. So we'll talk soon.
All right, talk to you soon. Bye-bye.
All right. So knowing what we know now, that data modeling won't be an issue because this is a pretty straightforward use case, I am leaning towards DynamoDB as the best fit here. Amazon Aurora Serverless is a great choice as well, but our customer doesn't need the complex features that Aurora offers, and DynamoDB is easier to get started with and to operate over time. Also, we are using AWS Lambda as the compute service. Think about what happens with database connections when you spin up a Lambda function and you scale it really big. If there are 100 unique Lambda execution environments, each one would create its own connection to the database. During sales events, when their customers are cleaning out their supplies website, buying everything up, the website could flood the database with connection requests, which can cause issues. Luckily, with Amazon Aurora Serverless, this problem has been solved. You'd need to use something like Amazon RDS Proxy to sit in between the Lambda functions and the Aurora database. But then you have another service to manage or to think about. With DynamoDB, that problem doesn't exist and doesn't need to be solved, so there is no need to bring in another service like RDS Proxy. The simplicity that comes along with using DynamoDB is a big reason why I like it for our customer, who wants to go as cloud native as possible, and a cloud native database like DynamoDB is a great choice for trying to keep it simple for them. So let's go ahead and add another block to our diagram. So far, we have API Gateway handling the API layer, and we have AWS Lambda handling the orders processing service, and now we can add DynamoDB to store our order data. We have a long way to go here before this meets our requirements. Up next, we need to think about these downstream calls for accounting, order fulfillment, and inventory. All right, in this video, we are going to explore the service DynamoDB. So first, I will navigate to the DynamoDB service. And if you remember, DynamoDB is our serverless, NoSQL, key value, and document database. And from this Get Started page, I'm going to go ahead and just click the Create Table button. Now remember, with DynamoDB, we don't have databases that you load multiple tables on. Instead, you create tables, and you may have multiple tables, but your application may use one, it may use many, but these tables are standalone. So let's go ahead and give our table a name. I'm going to go ahead and just call this the example table. And then you also have to provide information around the partition key and the sort key. Your partition key is going to be essentially the primary key, and this is a unique identifier for the items in your table. So tables have items, and you can think of that like a row in a relational database. And then each row has attributes, and these attributes are like the columns in your relational database. So it's information about that row. So let's go ahead and give this table a partition key. I'm going to go ahead and say, let's say this is user ID. And then we also want to give this a sort key, and the sort key is optional. So let's say you have a partition key that is not unique and you needed to make it unique with a secondary piece of information. That's when you could bring in the sort key. So partition key plus sort key equals unique. We need to make sure that each of our items has a unique value so that we can identify it, whether it's the partition key alone or with the sort key. In this simple example, I'm going to go ahead and leave the user ID as the partition key. Scrolling down here, we can see that we have some table settings. And in these table settings, we are provided a default mode for this. So the capacity mode is provisioned. So I had mentioned earlier in an earlier video that we are going to recommend to our customer to use on demand. So with provisioned mode, this is the other type where you can go ahead and define the read capacity, which you can see is defined to 5 RCU right now, which is read capacity units. And we have the write capacity, which is 5 write capacity units. You can define these to determine how much throughput you need for this table at any given time. And right here we have 5 RCUs, 5 WCUs, but you could change this to be on demand. So I'm going to go ahead and click the customize settings, and then I'm going to select the table class as DynamoDB standard. And this is the general purpose table class, though you could also select DynamoDB standard IA, which is going to be data that is more infrequently accessed. And this is where you are trying to store data with a low cost. So now if I scroll down, I'm going to go ahead and select on demand instead of provisioned for this one, which means that as we consume more read and write capacity units, this table will scale that throughput automatically on its own. Now, if we continue on with this, you can see we also have the ability to create secondary indexes, and you can create a local index or a global index. And what these indexes are for is you use them to query on attributes that are not a part of your table's primary key. So we have the primary key right now is the partition key defined as user ID. If you wanted to query on something that was not the user ID and you don't want to do a full table scan, then you would have to designate an index to do that. I will include links in the notes where you can read more about that. If we continue to scroll down here, we can also turn on encryption at rest here, and I'm going to go ahead and leave the owned by Amazon DynamoDB option here. And so what this does is it gives you an AWS KMS or Key Management Service key, which is owned and managed by DynamoDB. You could, of course, have an AWS managed key, and this is going to be something that's stored in your account, also managed by AWS KMS. Or you could provide a customer managed key where you manage that key. You also can optionally apply tags to your tables as well, which will help you with billing and tracking your resources. From here, I'll go ahead and click Create Table. And it really only takes a couple of seconds for a table to be created. So we'll go ahead and wait for this to get done. And you can see now that the table is at status of active. If I click on this example table, and I want to go through and look at the types of things that we can do with this table. One thing that I can do is I can click on the Monitor tab, and this will show you any available CloudWatch metrics for this table. So this will show you things like the read usage and write usage. So how much data are you reading and writing from this table at any given time? What types of latency are you seeing here for queries or scans? And a scan is when you are querying an attribute that is not indexed and is not a primary key, so you have to check every single item in that table in order to find a match. So scans, generally, you'll see the most amount of latency. You can also come down here and view all of the other types of metrics that you would have on a table. So now if we scroll back up, I'm going to go ahead and click this button here, and then I'm going to click Exports and Streams. And for this table, what I want to do is I want to enable DynamoDB streams. If you remember, DynamoDB streams capture item level changes in your table and push those changes to a DynamoDB stream. After that, the stream can be processed by another application. So I'm going to go ahead and enable DynamoDB streams. And for here, I want to include the new image. So I want to see the entire new item as it appeared after it was changed. You could choose to only view the key attributes that changed. You could choose to only view the old image or the new and old images. It really depends on your use case and what the applications that are processing the stream are trying to do. But I'm going to go ahead and click Enable Streams. One other thing I want to call out here about DynamoDB is global tables. You can create replicas of your DynamoDB tables in other regions in AWS, and then these tables will be kept in sync with each other through this global tables feature. All right, so that's it for our exploration of DynamoDB. Of course, we'll always include more links to resources where you can get hands-on with DynamoDB and other AWS services. During our customer call earlier this week, we heard from them about some of the issues that their code has. Because the order service code is all wrapped up into one application, if any part of that process breaks, the entire order fails, or some of the downstream calls to inventory, accounting, or fulfillment can break, then the next subsequent downstream call is not made. Part of our plan for the order service is to break it down into smaller, more decoupled components to solve these problems, while also meeting the requirements of improved resiliency, lower cost, and operational overhead, as well as managed scaling. So far, we have designed our proposed solution using API Gateway, AWS Lambda, and DynamoDB, where API Gateway accepts and validates the order, then sends it to the backend Lambda function, which then will do any processing, and then we'll save that order to the DynamoDB table. Now we need to build out the part of the solution that handles the calls made to the downstream services while keeping the customer's requirements in mind. Now, you could, of course, code the Lambda function to make the calls to the downstream services, but then those calls are still tightly coupled with the business logic of processing the orders, which is the same problem that they have now. If I ever down the road want to change the way we fan out these messages to the downstream services, I would have to change the order processing code, which could inadvertently introduce potential bugs. We want to decouple the application code from the downstream calls so that the Lambda function focuses on taking in the incoming order, processing it, and then saving it to the database. From there, we can build out the solution to capture the event of the order being written to the database and send it to the downstream services using a publish-subscribe model without needing to have the order's processing Lambda function do that work directly. So, knowing that there are 3 downstream services already hosted on AWS, and we need to fan out the order that is placed to all of those services as a message, I am thinking of using an event-driven architecture here, which can help us out. Let's start by pulling up the AWS documentation to see what it has to say about event-driven architectures at aws.amazon.com/event-driven architecture. If we scroll down to the diagram on this page, it shows an example of an event-driven architecture. And in this case, we have 3 components. We have the event producer, the event router here in the middle, and then we have the event consumer on the right. A producer publishes an event to the router, which can then filter and push the event to consumers. Producer services and consumer services are decoupled, which means that they can be scaled, updated, and deployed independently. Recalling the architecture decisions we have already made for this order service, we have API Gateway sitting in front of Lambda, which then writes to a DynamoDB table. AWS Lambda is a great choice for event-driven architectures because it doesn't run all of the time. It runs in response to events triggering the Lambda's function's invocation. So we are already in a good starting place for event-driven architectures. We need to consider now how to route the event to the downstream services to be processed. Back to the event-driven architectures webpage, if I scroll down this page, we can then review what AWS services exist that can help us send the messages to the downstream services, since we don't want our Lambda function to do it directly. Under this section titled Where to Start, I can see we essentially have 2 options to push these messages to our consumers. We have Amazon EventBridge here, and we have Amazon Simple Notification Service, or SNS, here. Starting with Amazon Simple Notification Service, let me open my browser tab to aws.amazon.com/SNS. So if we go ahead and scroll down this webpage to this helpful diagram, we can see how SNS works. SNS is a fully managed messaging system that uses a publish-subscribe or pub-sub model where a publisher can send or publish messages or events to something called an SNS topic, and then you can subscribe multiple consumers to this topic so they receive any published messages. SNS has a one-to-many relationship for published messages and subscribers, where one message is consumed by all subscribers to a topic, which is like the fan-out method that I mentioned earlier. Optional filtering can be applied to topics as well, so if you want to set it up where only some subscribers received specific messages but not others, that is possible with SNS. Potential subscribers for SNS topics could be things like an HTTPS endpoint, AWS Lambda functions, Amazon SQS queues, or other AWS services. With our customer's use case, the order being placed would be the message to be published, and the subscribers would be the 3 downstream services who all need to consume the same message. This seems like it could be a good fit for our use case. Let's now go ahead and evaluate Amazon EventBridge and see what that service is all about. Bringing up the Amazon EventBridge page at aws.amazon.com/eventbridge, if I go ahead and scroll down this page, we have another diagram that can help us understand EventBridge. EventBridge is a serverless event bus that connects applications using events. This is very similar to SNS, but there are a few differences. First is that EventBridge supports a lot more targets for consumers or subscribers than SNS does, including third-party software solutions like software-as-a-service applications. And that also includes the other side of things for the event sources. EventBridge supports a lot of different event sources as well, like software-as-a-service or SaaS applications. It also supports message filtering by using rules, whereas SNS only supports filtering based on message attributes. EventBridge can do much more deeper filtering. This can be helpful if you have a variety of messages being published that you need to route those specific messages to specific consumers. In our use case, we know that all 3 downstream consumers will consume the same message, so this doesn't really help us out a lot, even though it is a cool feature. EventBridge also has something called the Schema Registry, which stores schemas generated by your organization's applications, AWS services, or SaaS applications. A schema includes information like the title, format, and validation rules for event data. These can then be used to help you define how you want your messages structured, which can be particularly handy if you are integrating from outside third-party systems. Again, with our use case, we really only have one message type, and we control the shape of that message as well, so this isn't super helpful to us. With all that being said, I think EventBridge is a more complex and powerful tool than SNS. Both SNS and EventBridge are serverless, so we don't need to worry about scaling here, and both services would help us decouple our order service and improve its resilience. So they both technically meet the requirements. However, SNS wins over EventBridge for cost, and it wins for simplicity. With our customer's simple use case, SNS can handle the job very well. I'm going to go ahead and add SNS to our architecture diagram, and this will send the messages to our downstream services. This looks great, but there is still one piece missing. How are we going to get the event that an order was added to the DynamoDB table to be published to the SNS topic? This is where something called DynamoDB Streams and AWS Lambda come into play. DynamoDB Streams can be enabled on a DynamoDB table so that when changes are made to the table, that event is captured in an ordered flow of information called a stream, and that stream can then be processed by applications. In our case, we can process the stream of new incoming orders by setting up another Lambda function and designating the DynamoDB stream as the trigger. This Lambda function will receive the information about the item being added to the DynamoDB table in the payload of the request that gets sent to Lambda. It will then take that data and submit an API call to SNS, publishing the event to the topic. So let's go ahead and add the DynamoDB stream here, as well as our second Lambda function to our diagram. The great thing about this design is that the mechanism of sending the message to the downstream services is handled outside of the order processing code. So if at any point this changes or has issues, it is totally decoupled from the application's business logic. Additionally, if any new downstream services get added, like an analytics service, we can simply just subscribe the HTTPS endpoint of the new service to the SNS topic as a subscriber, and it will start to receive messages, all without making any coding changes to the existing solution, which is the key here. This solution is shaping up nicely, but there are a few more things that I want to add. Let's talk about decoupling some more coming up next. In this video, we are going to explore Amazon SNS, or Simple Notification Service. So I'm going to go ahead and navigate to Simple Notification Service. We will select this service, and this brings us to the landing page. From this page, first thing it's asking you to do is create a topic. So if we remember, Amazon Simple Notification Service is a pub-sub messaging service for microservices and serverless applications. So it essentially allows you to send a message to what's called a topic, which is a message channel. And then this message channel will fan out the message or send the message to all of the subscribed endpoints. So let's go ahead and create a topic and see what sorts of configurations are available to us. So I'm just going to go ahead and name this test and then click next step. Now, from here, if we explore this create topic page, right away I'm noticing that we have two different types of topics that are available to us. We can do a FIFO, or first in, first out, or standard. So a FIFO SNS topic is going to do a strictly preserved messaging order. So if for some reason the order that the messages were received matters to your application, you would want to select this. This will have exactly once message delivery, so you're not going to get multiple messages delivered multiple times. And then also this provides you with a high throughput up to 300 publishes per second. Whereas with a standard SNS topic, this gives you a lot more throughput because this is best effort message ordering. So that means that the order that it comes in may not be the order that it comes out. So a lot of applications, the order doesn't necessarily matter. And in our use case, the order won't necessarily matter too much here because the payment's already been processed and things like that. So we're going to go ahead and select standard, and then we can go down and select some of the other types of configurations that we have for SNS topics. One is that you can provide encryption in transit. And so encryption in transit is enabled by default. And you can also add enabling server-side encryption, which will add encryption at rest for your topic. So you have to kind of go out of your way here to enable encryption at rest, and we will do that. And what this will do is it encrypts your message as soon as it's arrived, or as soon as it's received. And then your message will be decrypted prior to delivery. So that means that when SNS has your message, it's going to be encrypted the entire time that the service is handling that message. So now if we keep scrolling down here, we can also open up this access policy, and this is going to be the last thing that I want to highlight for this service. And here you can see that we can create policies that define who can access your topic. So AWS has these things called resource policies, where you can attach a policy directly to an AWS resource and restrict who can access this resource. So here you can see we have who can publish messages to your topic. You can select only the topic owner, everyone, only the specified AWS accounts. You can also say who can subscribe to this topic. Is it only the topic owner? Is it everyone? Only AWS accounts? Or is it only requesters with certain endpoints? This will, by selecting these, it will kind of change this JSON preview for you over on the right-hand side. But you also can select the advanced mode here and directly edit this JSON. Now we can scroll down here and click Create Topic. And our topic was created. And at this point, we could then go down. We could create some subscriptions for this. So a subscription could be a Kinesis data firehose, an SQSQ, a Lambda function, an email address. It could be an HTTPS endpoint, or it could be SMS for texts. So you can use SNS to send updates to email addresses or phone numbers or all sorts of things. So this is where you would come in and you would create your subscriptions. I'm going to go ahead and click cancel for now. And that is all we have for this SNS exploration video. In the last video, we started to break down the different components of our customer's application and begin to decouple these components from each other using services like Amazon SNS and following an event-driven model. This solved the problem where the application was tightly coupled with the downstream calls being made, but we have not addressed the latency issues with the order acceptance component of their application. Right now, the way their application is written on premises, it's using a synchronous model, where the user submits their order to the order service, the service accepts and validates the order, processes the order, stores it in a database, and then calls the downstream services for inventory, fulfillment, and accounting before it responds to the user. We have heard from our customer that this whole process can be slow and takes too long to complete. If we picture our customer's problem, their end users are probably sitting there watching the browser just clock and look frozen before it finally responds back to the user. I know I get frustrated when websites are slow, and I think most people do, so it makes sense that our customer wants to solve this problem. We have already decoupled the application by separating the business logic from the downstream calls, but we haven't addressed the synchronous aspect of this that is causing the latency for the end user. This especially is a problem during scaling events when the backend starts rejecting requests because it's overwhelmed. I'm going to recommend to our customer that they move to an asynchronous architecture where the request would come in, API Gateway would accept and validate the request, and then from there, instead of sending the request directly to Lambda, it would send it to storage first. This is following a storage first pattern, which is used to reduce API latency. This is how it works. Usually you have this type of setup where you have your API, which sends to your compute, which then processes, writes to storage, and then responds to the API layer, which then sends that response to the client. This is where we are at now, which is causing some latency while the processing is being done in the compute layer. What we want to do instead is move the storage up closer to the API so we can instead have the API accept the request, immediately write the data to storage somewhere, and then respond back to the user quickly and say, hey, we got the data needed, you can move on. Then the compute component can read that data from storage and do its work asynchronously without the user waiting. This is a nice option when working with API Gateway for a few reasons. First of all, API Gateway can handle a lot for you, like authenticating requests as well as validating and transforming payloads before they ever reach your compute layer. So because API Gateway is such a powerful service, you can offload some of that work from your backend compute layer to your API. All of that logic happens closer to the client, which can reduce some latency there. The second piece needed for this storage first thing to work is the fact that API Gateway can directly integrate with other AWS services, meaning that API Gateway can send the appropriate API calls to other AWS services. It knows how to interact with other AWS APIs. So API Gateway can do things like write an item to DynamoDB, or add a message to an SQS queue, or publish a message to SNS. API Gateway can do all of this without you needing to write something like a Lambda function to do it. So, because of these features, you can store your event first, respond to your user, then your compute layer can process asynchronously. This sounds like it'll fix our users' issues, but right now our architecture looks like this. We have API Gateway talking directly to Lambda. So what we need to do is make some space between these two components and add a storage layer between them to create a buffer. This means that we can follow the storage first pattern. I'm thinking about either using DynamoDB as the storage option here or Amazon SQS, or a simple queue service. First, let's explore DynamoDB. This option would seem to make a lot of sense here because we are already storing our data in DynamoDB. So theoretically, since API Gateway is doing the authentication and the data validation of the order, and API Gateway has a service integration with DynamoDB, I'm thinking I can maybe just get rid of the Lambda function that is accepting and writing the orders to DynamoDB altogether. This idea hinges on the Lambda service not doing any real business processing. If there is business logic happening in that Lambda function, then this won't work. But if there isn't, then this is a pretty interesting idea and one I'm keeping in mind. Now for our other option, Amazon SQS. Amazon SQS is a service that is a fully managed message queuing service that enables you to decouple and scale microservices, distributed systems, and serverless applications. The way it works is you create a queue, and this queue then acts as a place to send messages that go between system components. In our case, the message would be sent to the queue from API Gateway, and it would then stay in the queue until that message was processed and deleted. SQS is a supported event source by AWS Lambda, so this would work pretty seamlessly from an integration standpoint. I think that both of these options seem great. They are both decoupling the API from the backend logic, which would help with this latency issue. Both options also increase resilience, so that if there is a large scaling event, even if Lambda is scaled up to any limits set by our customer, the orders would be stored somewhere waiting to be processed, so no orders would be dropped at any point. Both options are also serverless, which is important for our customer who wants to reduce operational overhead and cost and also wants to optimize for performance efficiency. With serverless, you scale up and down on demand, so performance efficiency is really built into both of these solutions. Let's go ahead and call our customer and see if they can give us some more information so that we can make this decision.
Oh, hello, Morgan. I'm just in the lab here testing out some new gloves, products that we are going to add to our website. What's up?
Oh, nice. That's a little bit unusual having a tech worker also working directly with the products you sell, but that's pretty cool.
Yeah, we are pretty much hands-on all around here. Anyway, how is it going?
Well, it's going pretty well. I'm almost done designing the solution for your order service, but I do have a question for you that would help provide me with some clarity. So for this order service, is the service performing any business logic beyond basic data validation or storing the order?
Yeah. Well, it is. It does have some complex business logic beyond just validating and passing data from one place to another. So yeah, the answer is yes, it does.
Okay, well, that is really all I needed to know, but before I let you go, I really love those gloves that you have there.
Yeah, cool. I'll send you a pair.
All right, great, thank you.
Bye-bye. Thank you.
All right, well, that settles it for me. Since we cannot remove the Lambda function doing the processing from the solution, we should use Amazon SQS as the decoupling component between API Gateway and AWS Lambda. Now our solution will look like this. We have API Gateway accepting the request from the front end and sending it to SQS, then immediately responding to the user. From there, AWS Lambda will recognize that there is an event in the queue, run the business logic and store the information in the DynamoDB table. A stream entry will then be created, which then triggers another Lambda function. And this Lambda function will then call SNS to publish a message to the downstream services. It's time to finalize this architecture and prepare to present it to our customer. In this video, we are going to explore the types of configurations that we can make for an SQS queue. So I will first navigate to the SQS service. And from this page, I can go ahead and click the Create Queue button. From here, we can see the types of configuration details that you can make for a queue. And notice how this is already looking fairly similar to the video that we made for the SNS exploration. So there are differences between SQS and SNS, and I highly recommend that you understand those differences deeply. Notice though how we can make a standard SQS queue or a FIFO, or first in, first out queue. So that is very similar to the way that SNS worked. Now, that being said, with SQS, what happens is whenever you create your messages, they remain in the queue until they are processed. Whereas with SNS, messages that you send through just get sent directly to the subscriber. Whether the subscriber successfully received it or not is kind of on the end of the subscriber. Whereas with SQS, if you send a message into a standard queue, for example, that message will remain in that queue until it is processed. So now I'm going to go ahead and give this queue a name, and I will go ahead and just name it test queue. And remember, FIFO, first in, first out, that means that you have preserved message ordering in that queue. All right, so now scrolling down, there's some configurations that are important to know for SQS. And the first one that I want to call out is this maximum message size. Messages can be between 1 kilobyte and 256 kilobytes. So this is really not for large messages. This is for small messages that you're sending between components. You would have to come up with a different solution if you wanted to send large messages between different components using a queue. One way you could do that is maybe by sending an index or a reference to where the next component can go find the message, like a database or something like that. But the maximum message size is 256 kilobytes. The next thing I want to show here is this message retention period, and it can be between 1 minute or 14 days. So your messages will remain in your queue until they are processed up until 14 days, or whatever you want to configure here. We'll go ahead and make it 14 days, the maximum amount of time for message retention. Then we have this receive message wait time, and if we click on info here, it will tell us some information about this. So the receive message wait time is the maximum amount of time that polling will wait for messages to become available to receive. The minimum value is 0 and the maximum is 20. So with SQS, we have something called polling. So SQS is a polling mechanism where the consumers have to poll the queue to say, hey, do you have any messages for me yet? Do you have any messages for me yet? And so whenever SQS receives a poll, it can take a minimum of 0 seconds to respond or a maximum of 20. If you have a low volume queue, you may want to have a longer receive message wait time, and that would reduce the amount of times that you're polling an empty queue. So if you have a low volume queue, maybe use long polling. If you have a high volume queue, you can probably use short polling. It just depends on the type of messages that you have. Now, the other one I want to call out here is the visibility timeout. Visibility timeout sets the length of time that a message received from a queue or by one consumer will not be visible to the other message consumers. And so what this is used for is, let's say you have 5 different consumers all polling the same queue and processing the messages. Let's say you have 5 EC2 instances all using the same queue. You want to make sure that all 5 EC2 instances aren't processing the exact same message, because then you would have duplication of that message being processed. So whenever a message is claimed from a queue, the visibility timeout begins, and during that time, no other consumers can receive that message. So the visibility timeout is another thing that's very important to understand how it works. If we can keep scrolling down here, you can see that we have another opportunity to set a resource policy on this SQS queue. So this will determine who can send messages to the queue and who can receive messages from the queue. And this is a resource policy. And then I'm going to just go ahead and click Create Queue. And then from here, we can view some other information once the queue is completed. You can see if you want to create any SNS subscriptions. So if we click Info here, you can subscribe one or more SQS queues to an SNS topic. So the SNS topic could send messages to the queue. And then we also have things like Lambda triggers. So is this queue going to be triggering a Lambda function, right? And then you can also view monitoring through CloudWatch, and this is going to be very interesting if you have operational issues. You could come in here and you could see potentially, let's say you have a bunch of messages that are showing up and flooding the queue, and you notice that the number of messages deleted is really low. Maybe that means that you have a problem with your code where they aren't deleting the messages after they are processed. So that is all I want to cover for SQS during this exploratory video. And as always, please check out the readings where you can find links to tutorials and blogs to learn more about this service. Great news! We are ready to present our solution for the order service to our customer. Now, it's good to remember before we get into our customer meeting that this initial design will likely change as the solution is implemented and more requirements come to light. I personally have never been on a software or IT-related project that didn't change as it went along. There are still many unknowns at this point in the process. That being said, we have a really great solution that meets the current requirements, and I think our customer will be excited to move forward with building it out. And the next phase for this would also likely involve building a proof of concept for our customer. Let's go ahead and give them a call.
Hello, Morgan. I hear you have our solution designed. I'm looking forward to see it.
Yes, I do. Let me go ahead and share it with you. Let's dive in. I approached this as a greenfield service, knowing that you are open to totally rewriting the code. So with that in mind, try to forget about the way things are currently done, and instead let's focus on this solution and how it will meet your requirements.
All right, great.
Okay, so you have the front-end clients making requests, sending in orders through their phones, browsers, etc. All these requests are going to be directed to Amazon API Gateway, which acts as the front door for your API. API Gateway will handle the authentication for the requests, and it will also validate the format of the incoming request to verify that all the necessary fields are included in the payload of the request. Once it passes through the authentication and validation, API Gateway will then send the message to an SQS queue. The message will remain in the queue until an AWS Lambda function is spun up to process the message. This happens quickly, and it's all automated because there is a polling mechanism built into AWS Lambda that will read the messages from the queue. Putting SQS between API Gateway and Lambda is decoupling the API from compute. So that way, if you have a large scaling event and you reach any predefined limits for the Lambda, the messages will be in the queue and will not be lost. Then Lambda can churn through the messages and catch up, or to catch up even faster, you can raise your Lambda limits and process the messages that are in the queue. Now for the Lambda function. This Lambda function will contain the application code for the order service related to order processing and storing the orders. The orders will be stored in an Amazon DynamoDB table. Once an order is stored in the table, an entry gets added to the DynamoDB stream, which then will need to be processed to send the order to the downstream functions. This is where another Lambda function comes into play, and this Lambda function will read the information on the DynamoDB stream and publish the order information to Amazon SNS. SNS then following a fan-out pattern that will send that message to all of these subscribed endpoints, those endpoints being the 3 downstream services for fulfillment, accounting, and inventory.
Wow, okay, this looks awesome, but I have a question for you. What about monitoring and logging?
Yeah, so all of these services are serverless in nature and have built-in integrations to send metrics and logs to Amazon CloudWatch and Amazon CloudWatch Logs.
Right. It's good to hear that we won't need to do a ton of extra configuration to that get working and in place. What about scaling? Is everything here using managed scaling?
Yes, so the scaling is all managed for these services, though for some of them you can set limits or rates like scaling with Lambda or managing the throughput for DynamoDB. So you can still control scaling events, but it's much more hands-off than when you compare it to services like EC2, for example.
Cool. Yeah, that's a relief. Hopefully I won't get paged for outages anymore when we have sales in our store. That was always the worst, like being excited for a sales event to happen only for our infrastructure to fail when we needed it most, right?
Yeah, I totally understand that. Now, for your other requirements that we went over, we designed this with decoupling components top of mind and with services that scale in when you are no longer using them to optimize for cost and for performance efficiency. So overall, I think you're going to be really happy with operating this solution over time.
Thank you so much. I can't wait to take this back to the team and show them what we will be working next.
You're welcome, and I'm sure we'll be chatting soon as you begin to dive into the details on how all of this will actually work. All right, so in this video, I'm here with Raf. He's a solutions architect now, so we both have our solutions architect hats on. And what we're going to do is we're going to take a look at the architecture that we built this week, and we're going to think about ways that we could enhance this architecture, either to be aligned with some of the things that our customers were looking for, like cost or performance or maybe operational overhead. But we're also going to look at things like, just in general, what types of enhancements could we make to these architectures? So we'll be doing one video like this at the end of every week with 4 different architectures. So that being said, Raf, why don't you go ahead and kick us off?
All right, ready to start here. So the first architecture improvements that I would make in this architecture is implementing DAX. DAX is a cache layer for its DynamoDB accelerator. It's a caching layer for DynamoDB. So you can implement that, and the Lambda functions, whenever going to DynamoDB, the Lambda function can use DAX, which is DynamoDB accelerator. So it caches content, so you don't have database hits all the time on the DynamoDB table.
Right. So with DynamoDB accelerator, it can get you to like microsecond
latency is super fast, but it comes with a cost.
It does.
Right? So depending on what the customer wants to optimize for, you may use a DAX layer here between Lambda functions and DynamoDB, or you could just use DynamoDB with read capacity units that would suffice as well.
Right. It really depends on the goals of the customer. So I would say DynamoDB Accelerator is something that you would introduce after you've determined that the performance isn't good enough.
Yes.
The other thing you could do with DynamoDB in terms of performance is you could potentially remodel your table with the indexes.
Yes. DynamoDB tuning is a big part of infrastructure optimization, right? And you can experiment with DAX, without DAX, so you can do tests. If you have infrastructure as code, you can even mimic that entire environment and do stress tests with DAX, without DAX, compare them.
Do some A/B testing there.
Yes.
All right, so the next thing that I would recommend is going to be for AWS and Lambda. We have our Lambda functions here. And so with Lambda, you get to choose the amount of CPU and memory that you have allocated for your Lambda functions. And so something that is kind of counterintuitive is that if you up the amount of memory that you give a Lambda function, technically you're paying more for that Lambda function. However, the code can oftentimes run faster on Lambda functions that have more memory. So what you can do is you can use a library called AWS Lambda Power Tuning, and that will help you find the most optimal memory and CPU allocation for your Lambda functions. And that's going to help you have your Lambda functions hopefully run more performantly and then actually lower your costs. So it's counterintuitive because the more memory that you give, you can actually achieve lower costs because your Lambda function runs for less time. And with Lambda, you get charged per time.
Yes, that's a good one. Another optimization on the Lambdas as well could be using a feature called Lambda layers. Lambda layers allow you to get code that is reused across multiple Lambda functions. In this case, you only have 2, but as this architecture grows, you may want to have more Lambda functions, and you may potentially have code that is written and replicated across multiple Lambda functions.
Like common libraries and
common
things like
libraries,
that.
exactly.
Yeah.
So you can get these and add a Lambda layer for that, and you can reference the Lambda layer in the Lambda function. So if you want to change that library, you don't need to change every single Lambda function that uses that code. You just change the layer.
Yeah, it also helps with faster code deployments. So it can speed up deploying new code to your Lambda functions as well, because you only would deploy a small amount of code, not the full amount with the libraries included.
Yes.
And so continuing on with the Lambda functions here as well, another thing you can do is look at the code and the way the code is written. So with Lambda, you have this handler, and that's where the execution begins for the program. But what you can do is you can declare variables outside of that handler, and then those variables can be reused across execution environments. So for example, if you have to create some objects every single time a Lambda function is run, you can declare those outside of the handler. And then if this one has, let's say, 100 executions, you could reuse that same variable across them. So that would help you have your code initialization be shorter. So that's a little bit of a programmer one. And I'm a software developer myself, so I can't help myself. But yeah, so that's what I have to say for Lambda on that.
Yes, another enhancement I would suggest was potentially in the future, if there are more needs to do filtering, using Amazon SNS, you can replace Amazon S by Amazon EventBridge. EventBridge can use SNS as one of the consumers, as one of the consumers of the data that gets into the event bus in Amazon EventBridge. And in addition, you could have more than one. So with EventBridge, you could do filtering, and you could have more than one consumer. So if you want to get data from this Lambda function to an SNS topic and an SQSQ, for example, you can put EventBridge in the middle. It would also integrate with software as a service, like SaaS tools from AWS partners and other integration parts as well.
And with the message filtering for SNS, you can only filter based off of message attributes. So if you needed to do like deeper, more specific message filtering, or like let's say the messages coming through weren't uniform, then it would be a good idea to upgrade with something like EventBridge. And then one final thing back to our Lambda functions here is we could optimize logging output and retention for our logs from Lambda. So these Lambda functions are sending logs to Amazon CloudWatch logs, and you could consider using something like AWS Lambda Power Tools. And this is a suite of utilities for AWS Lambda functions where you can ease adopting the best practices for Lambda, such as tracing using things like X-ray or structured logging, creating custom metrics, things like that. So using the AWS Power Tools utility, you can optimize your Lambda functions on that level as well.
All right, that's good. Thanks, Morgan, for helping our students understand and how to mock up an architecture for a serverless web backend. I think that was a strong week that helped our customers a lot on understanding and decoupling event-driven architectures.
Hi everyone, this is a video where I'm going to walk through how to build a POC for this first week solution. So you don't have to do this, but if you would like to, we are going to include some instructions where you can take up the challenge to build a POC like this in your own AWS account if you wish. So this course is mostly going to be theoretical, conceptual, but we wanted to give you the option of building this out if you wanted to. So let's go ahead and get started. First, what we need to do is create some different IAM policies and roles. So let's go ahead and navigate to the IAM console and select IAM. And I have already built these out, but I want to show you what they look like so that you can follow along as well. And like I said, we will include these instructions as well. So the first one that I want to show is this Lambda DynamoDB Streams read. So if you think about our architecture, we have API gateway pushing a message to SQS. Lambda then reads the message off of SQS, writes to a DynamoDB table, which pushes that information into a stream. A second Lambda function reads that information off of the stream and then publishes the message to SNS. So let's actually start with this Lambda read SQS policy. And you can see here we have the API calls that are necessary for this Lambda function to read from SQS. We have delete message, receive message, get queue attributes, and change message visibility. So these are all the API calls that Lambda needs to read from that queue. Next, we also have Lambda write DynamoDB. This policy will also be attached to a role that will be used by the Lambda function to write to DynamoDB once it reads the message off of the queue. So for this policy, we have the actions as put item and describe table. Now, that's all of the permissions that Lambda function needs. The second Lambda function needs to read from DynamoDB streams and write to SNS. So let's first read the Lambda DynamoDB streams read policy. And you can see here we have these 4 API calls: get shard iterator, describe stream, list streams, and get records. And then for the writing to SNS, we have the policy lambda SNS publish, which includes the API calls publish, get topic attributes, and list topics. So these are all customer managed policies that you can see here. And then there are also AWS managed policies. So it's good to know the difference between the two of those. Customer managed policies are going to be managed by you, whereas AWS managed policies are managed by AWS. So what that means is, for example, if we have something like AWS Marketplace Full Access, if you expand this, you can see that it includes all of the API calls that are needed for this particular service. If there was a new feature that came out, AWS would update this policy, whereas these are custom policies up here. So if we needed an extra API call here to use a different feature, we would have to go in there and edit this ourselves. All right, next we need to attach these policies to roles, which again, I have already done. So we have some roles we're going to be using. One of them is API Gateway SQS. And this role, if I click on this, I'm going to go ahead and copy the ARN and paste that into a text editor that I have off the side. We're going to be using the ARNs for these roles in upcoming steps. And you can see the policies that exist for these as well. So for this one, we have this policy that allows API Gateway to push to CloudWatch logs, and this is an AWS managed policy. Now let's go ahead and go back to the roles. And then for our next role, I want to look at this Lambda SQS DynamoDB. This includes the policies for Lambda read SQS, which we just looked at, Lambda write DynamoDB, which we also looked at, and then we have this Lambda basic execution role, which allows the Lambda function to write to CloudWatch logs. So we can go ahead and collapse these policies. And then I want to copy the ARN for this role and paste that into a text editor in another screen. Now back to the roles screen here, let's go ahead and grab the next role, which is Lambda DynamoDB Streams SNS. I'm going to go ahead and copy the ARN for this one, and then I want to paste that off on another screen. And for the policies for this one, we have this Lambda function can read from DynamoDB Streams, it can publish to SNS, and it also has that basic execution role, which will allow this function to write to CloudWatch logs. All right. So that is all the roles that we need for this solution. So next, let's go ahead and create our SQS queue. Type in SQS and then select Simple Queue Service and then click Create Queue. And from here, you can select the type of queue you want, standard or FIFO. We're going to select standard, and then we're going to name this POC, QUE, queue. And then we're going to accept all the default configurations. If you're planning on taking the exam, I would make sure that you understand what each of these configurations is for and what they do. But for now, we're going to go ahead and scroll down, accept the defaults, and then what we need to change is this access policy. So this access policy will determine who's allowed to write to the queue and who's allowed to receive messages from the queue. So if you remember our architecture, API Gateway is going to be publishing messages to the queue. So you want to paste the ARN for the role that API Gateway is going to use here so that we define who can send the messages to the queue, this role, API Gateway SQS. Now, who can receive messages from the queue? We want that to be our first Lambda function. So I'm going to go ahead and grab the ARN for Lambda SQS DynamoDB and paste that here. And then you can scroll through here if you would like to, and you can read through this access policy in JSON. So now we're going to scroll down and click Create Queue. Now our queue has been created. I'm going to copy the ARN for this queue, and then I'm going to paste it in my text editor so that I can use it later. Now let's go ahead to DynamoDB and select DynamoDB here. And I'm just going to double check to make sure that I'm still in North Virginia so that everything's being created in the same account. And then I'm going to go ahead and click Create Table. And here we want to give this table a name. And I have the instructions open in another screen, so that's how I'm remembering each of these little things here. So the table name is going to be orders. Partition key we will say is order ID. Then we can scroll down, keep all the default settings, and click Create Table. All right, so now that we have our SQS queue and we have our DynamoDB table, we need to create our Lambda function. So I'm going to go to the Lambda service and select Lambda. And then I want to click Create Function. And from here, I want to author from scratch, give this function a name, POC Lambda 1. And then for the runtime, I'm going to select Python 3.9. And then for the permissions, I'm going to change the default execution role. And I want to use an existing role. And then I want to select this Lambda SQS DynamoDB and then click Create Function. All right, our function has now been created. We need to now add a trigger. So the SQS queue is going to be the trigger for our function. So we add a trigger, and then we want to select a source, type in SQS, select SQS, and then select the POC queue, and then we can just click Add. All right, so now we have the trigger set up for this queue. The next thing that we need to do is modify the code. So right now, this code is just basically a blank stub that just says hello from Lambda. I'm going to copy and paste some code that we have pre-written for you for this. And this code imports Boto3, which is the Python SDK for AWS. And then we're setting up the clients for DynamoDB and orders for the table. So the client, this is going to be how you interact with DynamoDB. Then you can see we're saying client, which is DynamoDB client dot table for this specific table called orders. And then we have this table object here. And then what we're doing is we're processing all of the records in the incoming event. So there's going to be a payload passed into this function. And then we're doing a little print just to test to make sure that it worked. You could take this out if you wanted to. And then we are setting the payload is going to be the body of the message that came in. I'm doing another print here again, just to make sure that it worked. And you can see that in the logs if you wanted to do that. And then I'm calling table.putItem. We're creating a UUID for that order ID and then including the order information, the payload off of the request. So I'm going to go ahead and click deploy. And then what I want to do next is create a test event in the Lambda console. So I'm copying some information from the instructions. And then we'll go ahead and click test. And we want to create a new test event. We'll just call this test. And then you can go ahead and paste in the information from the instructions. I clicked format JSON to make it look a little bit prettier. So we should see incoming order information. We'll go here. And then we'll go ahead and click save. And then from here, if we click test, we should be able to see that we have test incoming order information. Well, here, that's that printing that I was saying that I had those print statements here. So we can see that it did run. But now if we want to verify that this actually wrote to DynamoDB the way that we would anticipate, we can go back to DynamoDB, select DynamoDB, click on tables, select the orders table, go to explore table items, and then we can go ahead and see that we have our order here with that information that we sent in from that test payload. Now that test payload was mocking what the payload would look like if it came from SQS. So we're mocking the structure of what SQS will pass to that Lambda function. All right, so next what I want to do on this DynamoDB table is I want to click back here to DynamoDB, back to tables, select this orders table, and then select the exports and streams tab, and then scroll down. We want to enable stream details. And then what we want to do is you want to select new and old images, or actually let's just do a new image. We'll do the new image whenever you enable the streams. So what that means is what version of the items do you want to push onto the stream? So do you want just the key attributes? You might use this if you have like a large body, then you might want to just have the key where then it can go look up the payload. Maybe the payload's somewhere else. Maybe it lives in S3. Maybe it's in DynamoDB. It just depends on the size. We're going to go ahead and select new image. And so this will include all of the information on that item once it's published or added to the table. So we'll go ahead and click enable stream here. So now we can see DynamoDB streams is enabled. And the next thing that I want to do is I want to create our SNS topic. So I'm going to go ahead and navigate to SNS, select SNS, and then I'm going to go ahead and give this topic a name. We can type in POC topic and then click next step. And we're going to go ahead and select standard here. And you can see that we have a difference in subscription protocols. So SQS, Lambda, HTTP, SMS, email, mobile application is supported by standard, whereas for FIFO, it's only SQS. So we're going to be testing that this works via email. So you want to make sure that you're selecting standard here. All right, so we're going to select all of the defaults here, except for the access policy. So this looks very familiar to SQS, right? So now we're looking at who can publish messages to the topic. What I'm going to do is select this advanced radio button here, and then we're just going to edit this JSON directly. So what I want to do is let's go ahead and read through this really quick. We have allow star, and then that's going to allow people, anybody, to publish to this particular SNS topic. So what I want to do is I want to change this to instead reference the ARN of the role that the Lambda function is going to be using to publish to this particular topic. So let's go ahead and scroll down, and then we should be able to click create topic. All right, so now let's go ahead to topics. And then if we select POC topic, we can now create a subscription. So you want to go ahead and create a subscription here. And for this subscription, you would want to use email, and then you can put your email address in here. I'm not going to do that right now based off of just the protection of my email address, but this is where you would put in your email. You also could put in your phone number here. So it depends on where you are in the world on how this is going to work. So this works for US destinations, which is why we're going to go ahead and select email. So that way you can put your email in here. Okay, so I'm going to come back once I've set up my email. So you'll see me again in just a second. Okay, so now we have our topic created. I'm going to go ahead and copy the ARN of this topic, and then I'm going to create the second Lambda function. So let's go back to the Lambda console, select Lambda, and now let's create a new function, and let's call this one POC Lambda 2. And then we're going to select that Python 3.9 runtime again. We're going to change the default execution role to use an existing role. And this time we want to select Lambda DynamoDB Streams SNS and then click Create Function. All right, so now what we want to do is we want to go ahead and add a trigger. And then for this trigger, we want to use DynamoDB, and we want to select our orders table. And then we can go ahead and click Add. Okay, so now we have our DynamoDB table set up as the trigger for this function. Next, we will click on the Code tab, and then I'm going to copy and paste the code in from the instructions. So let's go ahead and do that. Now here you can see that we're setting up a client for SNS, and then we are going to be taking the records that were passed in from DynamoDB streams. And then we're going to say, if this was an insert, meaning it was a new item, then we're going to grab the information from that new image. So now you can see why it was important that we use that new image flag for enabling DynamoDB streams, because we are calling on that attribute directly in this code. And then we are calling client.publish, and then you have to fill in here, where are we publishing the message? So client.publish, publish is the API call that we're sending to SNS. Target ARN, where are we publishing this message? Message, what is the message we are publishing? And then message structure, what shape is this message in? Which it's going to be JSON. So let's go ahead and paste in the ARN for our topic here. And then we should be able to deploy this code. All right, so now what we want to do is we can create the API gateway, and then we can test if this whole thing works from there. So let's go scroll up, and then we can go to API gateway, select API gateway, and then I want to build a REST API. So I'm going to go ahead and click build for REST API, and then click OK. And now I want to create a new API, so brand new slate, and I want to call this POC-API, and then I'm going to click Create API. All right, so you can see now we have basically a blank API. We need to set up our methods and our resources. So what I want to do first is I'm going to create a resource, and let's go ahead and call this order, and then create the resource. And then under here, I want to click create method, and we're going to do a post, because theoretically there would be a front end sending an HTTP post to a back end with the path/order that would come in here. So now what I'm going to do is I'm going to select AWS service for the API, because API gateway has a direct integration between API gateway and different AWS services. So we're going to use that API integration with SQS. So next what we need to do is select the region, which we want to use North Virginia here. So I'm going to type in US East 1. And then for the AWS service, we want to use SQS. So we should be able to see that here. There you go. And then we're going to leave the AWS subdomain blank. We're going to select the HTTP method to be a post. So the reason for that is because API Gateway is going to be posting a message directly to SQS. So then we want to go ahead and select the path override. And from here, what we want to do for the path override is we want to actually provide the a pointer to the queue. So the way that we're going to do that is you type in your account name and then or the account number and then slash the name of your queue. So I just grabbed this off of the end of the ARN and then just changed the colon to a slash, and that's what we need there. So next for the execution role, this is going to be using that IAM role that we had created in the first step. So I'll go ahead and paste that here. And then I'm just double checking to make sure that everything looks good according to the instructions. And it does look like we have everything ready. So I'm going to go ahead and click save here. All right, so now we're going to go back to this integration request. And then under HTTP headers, I want to add a header. And for this one, I want to call it content type and then mapped from it's single quote application /x-www-form-URL encoded and then single quote. So then I'm going to go ahead and click the save button here. And then we want to scroll down to mapping templates. And from here, I want to select never, and then I want to add a mapping template, give it the type application-JSON, click on the checkbox, and then we can go down here. And what we need to type in down here, you can copy and paste this from the instructions. So it's going to go ahead and state action, and this is written in VTL. So we're essentially transforming the payload so that it can interact with the SQS APIs directly. So send message and message body equals $input.body. So again, make sure you're double checking things as you're going along here. There's a lot of little pieces that can go wrong. So we have action equals send message and message body equals $input.body. So again, we are taking the payload of the request and we are creating a string. We're creating the language that the SQS API is going to understand so that we can integrate these two things directly. So now I'm going to go ahead and click save. Make sure you're clicking save here. That's very important. And then we're going to go ahead and click back to method execution. And now what we can do is we can actually test this from the API Gateway console here. So you click test, and then down to the request body, add in some information that's like it's coming in off of an order. So we have item, latex gloves, customer ID 12345. I'm going to go ahead and click test. And then over here on the left-hand side, we can read the logs. So we can see sending request to that queue. And then we received the response status 200, which means that it did send. So one fast way to check this is, did you get an email? Did you actually receive the email? And then if you did, you'll know that it went through the entire thing. So let me come back and check my email and see if I got it. 1 second. All right, so I did go ahead and confirm that I do have the email, but we can also go check the DynamoDB table, see if it got that far. So for troubleshooting, something you can do is like check each step. Like we just saw that we got the 200 response from SQS, but that doesn't guarantee that the first Lambda function read it from the queue and then wrote it to the DynamoDB table. So we're going to go ahead and check the table to see if the information is there. If we go to explore items, or we can see our item is right here. So we know that the integration between SQS and Lambda is working. Now, I did get the email, so I know this thing is working all the way through, but if you didn't get the email, I would go about it that way. First, check the logs between API Gateway and SQS. Are you seeing that 200 response? If you are, next, come look at the DynamoDB table. Is your item here? If it isn't, then that means that you likely have an issue with the Lambda function between SQS. The Lambda function isn't actually reading from SQS, or maybe it's not writing to DynamoDB. Most of the time, these are permissions problems if you are having issues. And then if let's say that you have the item here, but it's not in your email, then the next place I would check is the second Lambda function. Is it able to read from the DynamoDB stream? Is your DynamoDB stream configured correctly? And then if it is, does your Lambda function then have the correct permissions to publish to SNS, right? Did you make sure your email is typed correctly is another easy one. All right, so we know that this is working now. I did get the email. So what we want to do now is go ahead and delete everything. All right, so let's go ahead and delete everything. I'm going to delete the table first. Type in delete, click delete table. All right, and then let's go to our Lambda functions. Lambda. And then I'm going to select all my functions and I'm going to delete them. We can type in delete, click delete, close this, looking good. Now let's go to API Gateway. And then from here, I'm going to select that API Gateway that I created and then delete it. And next, let's go to SQS. And from here, I'm going to select the SQS queue and click delete. And just as I'm cleaning this up, if you want to do like a real challenge for yourself, I would recommend trying to do this entire lab using either the AWS CLI or using CloudFormation. So instead of doing everything in a point-click fashion, challenge yourself to do infrastructure as code, or to even try to just use the CLI, just do something that you wouldn't usually think about doing. All right, so we have the DynamoDB table's been deleted, which deletes the stream. We have both Lambda functions are deleted, SNS has been deleted, SQS has been deleted, so is API Gateway. So I think we are all set. All right, good luck.
I hope you are enjoying the course so far, and welcome to the second week of Architecting Solutions on AWS. You may know me as the customer in the first week of the course. During this week, I am going to play the role of a solutions architect helping a customer to achieve their business goals. What I know so far is that the customer is a software company that developed a solution for providing restaurant menus by using QR codes. I've also heard that the customer has good coding expertise, but they need some help architecting their data analytics infrastructure to ingest, process, and visualize data. This feature will be an addition to their main product and will make them more competitive in the market. In this week, you can expect to learn more about Amazon S3, data ingestion, processing, and visualization, all matching customer requirements, which I will collect in the next video. And remember to check the readings between the videos. There is good detailed content in there. That way, you can dive deeper into the content that is more relevant to your own learning. Ready? Join us for the second week, where I will teach you how to map AWS data analytics services towards customer needs. Let's continue, because we have a customer waiting for our call. All right, let's call our customer for the week and learn more about what the current architecture state is and what they expect to be done. During this call, I will also try to outline what is in scope and out of scope for the architecture.
Hi, Raf. Great to hear from you.
Hello, Morgan. How are you doing? How are things going?
Things are pretty good. How are you doing?
I'm doing pretty well. Is this a good time to talk about the use case and the requirements for the data analytics solution we talked about the other day at the cafeteria?
Sure. Let me tell you the current state of what we already have, and then we can talk about what we need. Does that work?
Yeah, sure, that's perfect. I'll be picturing the architecture in my mind as you speak, so I'll be mostly listening, but I'm paying attention.
Cool. So currently we offer a solution that uses an S3 static website to host an HTML web page containing restaurant menus. We have also developed a solution where restaurant admins can log into a system of ours and update that object in the bucket. They do that when they want to edit the menu. We also have a system to generate a QR code pointing to the bucket, so restaurants use that to print the QR code and add it to their restaurant tables. All of that is already done, and we maintain it.
Cool. That's pretty cool and useful during times when we don't want to touch menus with our hands. It is also a solution that helps save paper. I love it. To see if I understood it correctly, when customers are in the restaurant, they scan the QR code, then they choose what they want, but they still have to wait for someone to come to their table. Is that right?
Yeah, that's right. And it's not optimal for restaurants and customers because it adds time between when the customer makes their choice and then actually ordering. We also have a third-party payment processing service that we use for other solutions, and we would like to add an order this item option to these static HTML websites that calls an API that we already have.
Great. Yeah, that all makes sense. That would be a nice upgrade to your product. Tell me more.
Yeah, so we know that we need to do one QR code per table because that will be the order identifier, and that's fine. But since we are doing this product upgrade, we would also like to have data analytics that will help restaurants gain insights into their menus. So, for example, we want to be able to see what dishes in the menu people are viewing. Insights can show us if people are just scrolling through the whole menu or if they stop after appetizers and they don't get to entrees, things like that. We also want to help our customers optimize their menu design through analytics.
Yeah. With that info, you can also discover things like items where customers see the description of it but don't add to their tab, or the amount of time between a customer expands an item's detail and they pay for it. With this kind of information, your BI analysts can make some reports to help restaurants and even suggest specific dishes based on session data. Like if you ordered this from restaurant A, then you might be interested on ordering this from restaurant B. That's called session data. This whole process is called clickstream data analysis. I can help you design a durable and resilient architecture that will receive, store, and process this data. This is perfectly possible using AWS data analytics services. Let me just ask you another question. Do you already have the client-side part that will send that clickstream data? How are you going to send data to be ingested?
So we wrote a JavaScript library that we can use for that. All we need is an endpoint where we can do HTTP posts and then the analytics side. So we would prefer a solution that accepts data through REST standards.
All right, so the coding on the client side and the payment gateway connection are out of scope for this project, right?
Right. We are happy if we have a RESTful HTTPS endpoint where we can send stuff.
Perfect. Now, in addition, do you have any other requirements?
Yes, we do. Cost is a priority for us, so we would prefer to use AWS services that bill per refined usage and not per time. We also would prefer using managed services when possible because we are operating at a reduced staff, so that means like no EC2 instances or operating systems to maintain if possible. We'd also prefer to have the data ingested and available as a backup in another AWS region with encryption.
Absolutely. That seems the right thing to do. I assume you would like encryption both at rest and in transit, right? There is even a quote from Werner Vogels, Amazon CTO, that says, "Dance like nobody's watching, encrypt like everyone is." Thanks for coming to me with well-defined requirements. That's really rare. So we will likely use Amazon S3 for storage, which checks many of these boxes. I will call you with more questions as I progress through the architecture of this solution. Is that okay?
Yeah, please do call me. Call me anytime you have any additional questions.
All right. Thank you. Bye-bye. See you soon.
Bye.
All right. I just had a meeting with my customer, and that was a lot of information. Now that I'm back, it's time to digest and organize everything. The customer is a software company that created a solution for providing online menus using QR codes. Currently, they have a product that uses Amazon S3 for displaying HTML files used by restaurants. Let me start defining what they already have, then I'll navigate towards the requirements. Their current solution uses Amazon S3 with a feature called static website hosting. You can use this feature to host bucket content over the internet with HTTPS as long as objects are public. For instance, this content can be HTML files with images, CSS style sheets, and JavaScript for running code on the client side. They also have a system that generates the menu and uploads it to the bucket. That is used by restaurant admins when they want to change prices, descriptions, pictures, or actually anything on the menu. In addition, they have a solution to generate the QR codes pointing to the bucket, and they provide a self-service system for the restaurant admins to copy the QR code image. The customer also told me they already have written a JavaScript library to collect the clickstream information, so they just need a RESTful HTTPS endpoint to push that data. Probably they need that because they want to take care of request authentication or more flexibility on where to push data without having to change the client-side code. That is already done, and brings us to requirement number 1. Our solution needs to provide an HTTPS endpoint for the data ingestion. This also brings us to requirement number 2. According to my notes, I remember they said they are running with reduced staff, so they prefer using AWS Managed Services for convenience. I will probably lean towards API Gateway here. Cost was also a concern. The customer mentioned they preferred using services that will bill per refined usage and not per time. Because of that, I will avoid using EC2-based services at all. So I will focus on serverless and AWS Managed Services. Usually, managed services are already charging per refined usage and not per time. So the requirements align pretty well with each other. Like Amazon S3, for example. It charges per data stored and not per number of hours a bucket exists. Another requirement was around data durability. I remember they asked for data backups to a different AWS region. Since we will be using managed services for data storage, there are options to easily enable that. Check. Last but not least, I remember the customer also asked for encryption in transit and encryption at rest. I even joked, saying the requirements were so well formed and this is rare. Speaking like that, encryption in transit and at rest can seem complicated, but luckily for us, it is easy to achieve in the cloud. Also, during the conversation with the customer, did you notice how I reinforced things that are in scope and things that are out of scope? I made clear that the payment part and the clickstream code that will collect information on the client side are out of scope. Ideally, that needs to be documented. Doing so is a good practice that well aligns expectations between your customer needs and what you are going to deliver as a consultant. Stay with me to learn more about the services used towards the part that is in scope for the architecture, which is the data analytics part. Together, we will build this solution piece by piece or block by block, then put it all together and present to the customer at the end. Along the journey, I will teach and talk about the possible AWS services used, always taking customer requirements into consideration. It is clear that we are going to use AWS Data Analytics Services. The first thing we need to think about when talking about data analytics is how to use the collected data to produce information that would be useful for business needs. Those are called insights. Sometimes, This journey of generating insights out of data can be complex, involving the use of machine learning, or sometimes it can be quick and simple. I usually say that if you control how the data is produced, things are easier because you don't need to apply data transformation when it arrives. Regardless of whether you are going simple or complex, AWS offers data services to transform data while it's being ingested or after it has arrived. In our scenario, the customer will be using a JavaScript library to produce data, and they are controlling how that data is sent. That makes things simpler because we would just need a service to ingest and store data as is. That's an important consideration. The number one tip is to always think about how data is going to come into the architecture you are designing. This becomes more important if you are building a generic solution that is capable of accepting data from different types, sources, and devices, such as images, audio, log files, pictures, and etc. You may also have heard the saying, use the right tool for the job. The reason for that is because there are so many data services out there in a way that choosing the most appropriate one will usually perform better while saving some money. Which brings us to the question, which one will I choose? So the best way to choose a service is by understanding what each service does. That way, you can map a customer requirement to a specific service that will do a specific task. Let me point my web browser to aws.amazon.com/bigdata/data lakes and analytics. If I scroll down on this page, I have the AWS Analytics services. And AWS puts its data services in 4 categories: analytics, data movement, data lake, and predictive analytics and machine learning. If you need interactive querying, you can use Amazon Athena, which is an interactive query service that makes it easier to analyze data in Amazon S3 using standard SQL. Athena is serverless, so there is no infrastructure to manage, and you pay only for the queries that you run. Definitely a service that charges for a refined usage. If you need big data processing, you can use Amazon EMR or AWS Glue, which are services that can run managed Hadoop clusters or jobs. These are useful for further data transformation. They are cloud big data platforms for doing massive parallel processing of distributed data. It uses open source analytics frameworks such as Apache Spark, Apache Hive, Presto, and others. Remember when I talked about advanced data transformation? Amazon EMR would help you with that. There are so many services, and the goal of this video is not to double-click on each one. The reading you are going to see next will do that for you. The main message here is to choose the right tool for the job, and the job in this case are our customer requirements and needs. Sometimes these requirements and needs are satisfied by more than one specific service. When that happens, it's time to call our customer asking for more detailed information. To give you an idea, here are some questions that would help you decide which service to use. What latency is acceptable between ingesting the data and making it available? Can the customer afford to wait some time to get the data? Where is the data coming from? Are we talking about a database migration, clickstream data ingestion, or batch file uploads? Sometimes, customers want to use solutions they created or software they already have licenses and support for. Sometimes, customers may want to use their own credential federation and integration with existing identity providers. That's fine. If that's the case, you may need to configure AWS services in order to make a bridge between the existing resources and the new architecture you are creating. Over the next videos, I will be discussing some of the data analytics services for clickstream solutions, explaining why you might choose one service over another. For the sake of matching an AWS service with the customer need, I may need to call Morgan while architecting the solution. The analytics solution will need a place to store the clickstream data. In this video, I will talk about storage by comparing some AWS services and tell you why Amazon S3 will be the chosen one. There are many storage options to consider, such as Amazon EFS, Amazon EBS, and Amazon S3. and some other services more suitable for data migration, file transfer, or backups. Let me briefly talk about these three and consider if they should be part of our architecture or not. So let me bring to our table Amazon EBS, Amazon EFS, and Amazon S3. Amazon EBS, or Amazon Elastic Block Store, is a service that provides block-level access when you need a file system. It provides high-end performance and can handle workloads at virtually any scale. But the reason why I'm not going to use EBS volumes in our architecture is because it does not align well with the requirements and needs. Don't get me wrong, I love EBS volumes, and let me explain why I am not using it. The reason why I am not using in this case is because they need an EC2 instance to be attached, and their billing is not as granular as Amazon S3, meaning that if you allocate a 50 gigabyte volume, you will have to pay for 50 gigabytes, regardless if you only have a couple of gigabytes to store. Also, the durability standards of Amazon S3 are higher than Amazon EBS, since S3 replicates data across an entire AWS region. For these reasons, I am not considering Amazon EBS for the storage layer. Okay, what about the next one on the list? Amazon EFS, or Amazon Elastic File System. Amazon Elastic File System can replicate data across an AWS region, so it is a service that has a higher data durability when compared to Amazon EBS. But it also relies on file systems that needs to be attached to resources, such as EC2 instances, containers, or servers. So, although it checks the durability box, it doesn't address a very common ask for most data analytics architectures, which is having a storage layer that lives by itself and does not need to be attached to anything in order to store data. Because of that, I am not using Amazon EFS for the storage layer. That's where Amazon S3 shines, and that's why we usually say it's the storage for the internet. You can interact with Amazon S3 by doing API calls such as put object, get object, delete object, or others. And you can do these API calls from your laptop, from a web page, from a server, from a mobile app, and virtually everywhere. Because of that nature, S3 is ideal for separating storage from data processing. And that is an important thing to have in data analytics or big data operations. Let me explain why. Having a layer that stores only data is convenient because you can use different data processing services or ingestion mechanisms. Remember the saying, use the right tool for the job? So detaching storage from processing gives me the flexibility of using specific data processing services that focus on the right thing. That's why Amazon S3 is also commonly used as a data lake. This term comes from nature, where people usually do an analogy with different biomes and data in nature. That way, data is accessible for specific tools to process and analyze data. Most of AWS and many commercial solutions already know how to work with S3 as the data layer. Now, if we go back to our requirements, you will see that Amazon S3 checks all the boxes. One of the requirements is that data should be stored in a durable way with cross-region replication and encryption. Well, Amazon S3 is known for providing high data durability standards. It is designed to provide 11 nines, or 99.999999999% durability for objects over a given year. S3 gets that high durability because every single object in a bucket gets replicated over different physical facilities in an AWS region. I know that cost savings is also another requirement, and S3 helps by only charging per refined usage, meaning that it charges for 5 megabytes of data if you just store 5 megabytes, or 1 petabyte of data if you store 1 petabyte. Also, speaking about large data amounts, Amazon S3 provides a feature called S3 Intelligent Tiering, which transitions objects from one storage class to another automatically based on access patterns. This does automate cost savings, which is always something my customer will welcome. In a nutshell, Amazon S3 charges per usage, refined usage. It easily enables cross-region replication. It encrypts data both in transit and at rest at no additional cost. And let me use multiple data ingestion and processing systems by being a managed service that does not need instances or servers to operate. It is perfect for our use case and it checks all the boxes. That's why I am using it for the storage layer of my data analytics solutions. Alright, let me load my Amazon S3 web console to show you some exploration we can do in the service. When you open Amazon S3 webpage, which I already have here from the AWS Management Console, you are presented with an option of creating a new bucket. There is a button on the upper right corner that I can choose Create Bucket. When I click in that option, I can specify the bucket name. So let me put my bucket name as ref-restaurant-1. And I can choose a region where I want the bucket to be created. In my case, it is US East 1. So buckets are regional. You don't need to specify an availability zone for a bucket. That doesn't exist. You just specify the region you want the bucket to be created. Scrolling down, you have some options such as blocking public access settings for this bucket. The important word here is settings. By unchecking the box that says block all public access, you are not making the bucket public. You are allowing a bucket configuration to make this bucket public, okay? So I am disabling that for now, which doesn't mean that the bucket is public. I'm just allowing the bucket to be configured in a public manner. So scrolling down, I acknowledge that the current settings might result in this bucket and the objects within becoming public. I kind of want to mimic what our customer have here. They have a bucket that is publicly accessible and they have HTML files with the restaurant menus. So I'm calling my bucket name ref-restaurant-1 in Virginia, and this bucket is not blocking all the public access settings. If I scroll down, there is an option that says Create Bucket. So I'm just going to choose that option, Create Bucket, and now the bucket is created. What I am going to do is just open the bucket and upload a file to a bucket. I can do that by choosing the option that says Upload. I'm going to hit Upload, drag and drop a file that I already have here, index.html. So I am uploading a file to this bucket called index.html. As from the moment I click upload, this file will become a replicated object in my bucket. Now I have a bucket with a file that has 32 bytes. It's a very small file in my bucket ref-restaurant-1. Now, how to make this file, this object, public? The first thing I should do is actually go to Amazon S3, and there is a setting in my account that automatically blocks public access settings for the account. By default, this is on. I went here, I clicked edit, and I turned it off. So by default, it looked like this. You must type confirm. By default, it looks like everything is blocked, and this is in the account level. Even though we had overridden that for that specific bucket, you must disable this in the account, right? So you must go and hit edit and block all public access. You want to disable that, save changes, type confirm, and now your bucket will be effectively able to be public when you configure a bucket policy to do so. So we have our bucket, which is called ref-restaurant-1 with an object inside. And first, before making the object, the bucket public, I would like to go on properties and scroll down everything and enable a feature called static website hosting, which is what our customers have. So I'm going to enable static website hosting, and I can specify an index document which will be served whenever someone accesses the URL for that bucket. I'll just choose index.html, save changes, and now I can go in permissions, bucket policy, and edit the bucket policy. I am going to place a bucket policy that allows this bucket to be public, which is read like this. This is a policy that has a statement ID or SID that says public read, allowing everyone to make the operations of getObject and getObject version everywhere in my bucket. That's how you read this policy. I am going to scroll down and hit Save Changes. Now that I have a public bucket that says publicly accessible, and I have static website hosting enabled, I can go back to Properties and scroll down just to get the static website hosting URL. So each bucket has a URL when you have static website hosting enabled. And that's one of the reasons for bucket names needing to be globally unique, because you cannot have two URLs in the internet with the same name pointing to two different locations, right? So this URL is pointing to the bucket. If I open a new browser tab, or if I simply click in that URL, I have my index.html served automatically, right? And I don't need to type /index.html because the static website hosting feature is doing that for me. If I type index.html, it's the same thing, right? And this could be a restaurant menu. This is an HTML file that I have with just that. This could be a restaurant menu string in it, but it could be a full CSS style sheet with JavaScript libraries running things on my client side, such as ingesting clickstream data to an HTTPS endpoint provided by API Gateway, right? So more to come in the course. Stay with us, and this was the Exploring Amazon S3 video. Now that we know we are going to use Amazon S3 for the storage layer, it is time to talk about which service we are going to use to bring the data to S3 in a scalable way. As usual, there are a variety of services to choose from. While some are ideal for bringing data in batches, some others are most suitable for IoT, database migrations, or even offline data transfer in a truck. In this video, I will compare some of these services and justify my choice for the service that I choose to handle clickstream data ingestion. Before we start talking about services, allow me to make some comments about clickstream data. Clickstream is the term for when we have small events containing pieces of data that are generated continuously with high speed and volume. Usually, clickstream events are generated by user actions, such as in this case, navigating through a restaurant menu using HTML code. Most clickstream data is used to analyze user behavior in a website by logging the user's navigation, such as the amount of time the user spends in the web page, where they usually begin the navigation, how it ends, and etc. By tracking this user behavior in real time, you can update recommendations, perform advanced A/B testing, send push notifications based on session length, and much more. This is the exact need of our customer. As usual, there are many ways to achieve the same results. I will bring the services to the table, and I will remove them one by one until we find the most appropriate one for our scenario. Let me bring the candidates, which are AWS Data Exchange, AWS DMS, Amazon EMR, Kinesis Data Firehose, Kinesis Data Streams, and Kinesis Data Analytics. Let me start with Amazon EMR. A way of doing clickstream ingestion is by using Amazon EMR with a managed Hadoop cluster and installing a streaming framework, such as Spark Streaming. This could do the job, but they run in an Amazon EMR cluster, which, although it's a managed service, charges per time and requires some big data knowledge to operate. Since our customer is running operations with reduced staff, they may not have someone with expertise in big data frameworks, and having a service that charges per time instead of per granular usage would not meet one of the requirements. That being said, I would not consider Amazon EMR for the data ingestion in this case, out of the equation for now. Another data ingestion service is AWS DMS, or AWS Database Migration Service. It is a service suitable for when you want to bring a database to the cloud. It does that by helping you migrate databases while keeping the source database running during the migration. In our scenario, there are no databases to be migrated, just clickstream data that needs to be sent. So for that reason, AWS DMS is not a player in the game here. Another data ingestion service would be AWS Data Exchange. But AWS Data Exchange is not designed for our customers' purpose. AWS Data Exchange is a data analytics service that provides data catalogs and is more suitable for integrating third-party data into a data lake for further analysis. So I am not using AWS Data Exchange for now. It seems that the most appropriate suggestion for this architecture is to use one of the Amazon Kinesis services. Amazon Kinesis is a perfect match for this job. It is designed to ingest large amounts of small bits of data. Kinesis is a family of services, and 3 of them could be used for our scenario. The first is Amazon Kinesis Data Analytics. This service is suitable for real-time data processing of data that is being ingested. That processing can be data transformation, aggregation, filtering, cleaning, or any other manipulation. Since our customer will have control over how the data is being sent, not requiring any transformation at all, I am not going to use Kinesis Data Analytics for now. The remaining services of the Amazon Kinesis family that I'll talk about are Amazon Kinesis Data Streams and Amazon Kinesis Data Firehose. There are some differences among them, which you can find in the next reading of this course. One of the main differences between Kinesis Data Streams and Kinesis Data Firehose is that Kinesis Data Streams requires writing some additional code for the data producer and consumer, so it's less convenient than Kinesis Data Firehose, but it supports lower latency between the moment the data is ingested and when it is available for querying. This latency thing is something I did not capture in my call with the customer. So let me call them to ask something real quick.
Hello.
Hi Morgan, how are you doing, my friend?
Oh, I'm doing great. I'm actually spending some time out at the golf course, just enjoying my day. How are you doing?
Nice. I'm good too. Hey, sorry to interrupt your golf. Listen, I have something to ask you. I'm thinking about which service to use as part of the data ingestion mechanism, and I would like to know what your latency requirement is from the moment you receive the clickstream data from the front end. I mean, can you afford having a couple of minutes before that data is available in the S3 bucket?
Oh yeah, absolutely. There's really no rush on that at all. This is kind of analytics for asynchronous processing anyways, so we don't have anything like real-time dashboards or anything like that. We just need to ingest data to further process it and make it available later. So there's no real-time dashboards or anything like that. So some minutes there are totally fine.
All right. Thanks a lot for clarifying that. That's all I need to decide which service I will pick. Enjoy your golf session.
All right. Yeah, thanks, Raf. And call me if you need anything else.
Yeah, bye-bye, Morgan. Always good talking to you.
Bye.
Bye. All right, so the customer does not have low latency requirements. So I am definitely using Kinesis Data Firehose here because it is more convenient. I think Morgan would appreciate not having to write additional code, especially because they are short-staffed. As you can see, the difference between Kinesis Data Streams and Kinesis Data Firehose is mostly convenience versus control, and there is no best one. There's only the most recommended according to a scenario. In our case, the customer is looking for convenience. Now the thing is, in order to interact with Amazon Kinesis, we need to perform Kinesis API calls, such as put record, regardless whether we are using Kinesis Data Firehose or Kinesis Data Streams. There are at least 2 services that could help with that. So let me put the question mark here, because a service needs to do that integration. And let me bring Amazon Cognito. The first is by using an authentication service like Amazon Cognito. It would provide an identity pool where you can use AWS credentials in order to perform Kinesis API operations. But there is one customer requirement that will make using Amazon Cognito a little more difficult. Do you remember which requirements I'm thinking about? Remember that the customer already has a JavaScript library that they want to use, and that JS library is looking to make an HTTPS post. You cannot do that directly to Kinesis. You have to use one of the Kinesis API calls. What service do you think we could use to proxy these HTTPS requests to Kinesis in order to avoid exposing our Kinesis data firehose delivery streams over the internet? If you thought about API Gateway, you got it right. So let me consider API Gateway here as well. We can use the API Gateway service integration to send data out to our Kinesis stream. That way, our customer does not need to change the logic in their JavaScript library. So I am adding API Gateway to this architecture right now, pretty close to Amazon Kinesis in our architecture diagram. API Gateway is actually not a data ingestion service itself, but it can be used to proxy things and proxy HTTPS requests to other AWS services, which is very handy in this scenario. Alright, let's explore Amazon Kinesis. In this video, I'm going to do a demo where I will have Amazon Kinesis webpage in the AWS Management Console. When you go to the Amazon Kinesis in the AWS Management Console, which you can find by going on the search box and typing Kinesis, you're going to see Kinesis, Kinesis Analytics, Kinesis Video Streams. For now, I am going to Kinesis, which serves like a hub for us. So from Kinesis, you can create Kinesis Data Streams, Kinesis Data Firehose, and Kinesis Data Analytics. In my demo, I am going to show you the Kinesis Data Firehose. You can choose the option Create Delivery Stream, and some questions will be asked, such as, for example, where is the data coming from? What is the source of the data? The thing is that you can chain one Kinesis data streams into another, right? So if you want to put Kinesis Firehose after another Kinesis data streams, you can do that here, and then later you will need to specify what is the other Kinesis data stream. I can do direct put. In this case, I will be doing direct put from API Gateway. So that's an API Gateway configuration. You go on API Gateway and you configure the service integration. For now, we're just configuring the Kinesis Firehose. The destination can be Amazon S3, Datadog, Amazon Redshift, Amazon OpenSearch Service, and there are many data sources to choose from. So one of them, and the most popular one, is Amazon S3. When I specify Amazon S3, I need to specify what bucket I want to have the data delivered. I can create a bucket right out of this creation wizard, or I can browse for an existing bucket in my account. So I am just going to create a bucket. If I click in Create a Bucket, it links me to Amazon S3 console just to create a bucket. So let me create ref Kinesis data bucket. I'm just going to create this bucket. This bucket must not be public because I will want my data to land in this S3 bucket. It's a private bucket, so I will leave the privacy configurations on. It is not a private bucket. When I go back to Kinesis Firehose, I can browse the buckets I have and I can refresh, and my new bucket will be in the list. So ref Kinesis data bucket, I can choose that bucket, and here I have some other options, such as S3 bucket prefix, if I want that Kinesis Firehose to create the objects in the bucket, all with the same prefix, and some other advanced settings like server-side encryption, and etc. For now, I'm just going to choose Create Delivery Stream, and that's how easy you can create a Kinesis Firehose delivery stream. It is creating right now, and the Kinesis Data Firehose, also known as delivery streams, is creating actually. It takes 2 minutes. So once it gets created, you can have CloudWatch monitoring in the same interface. You can change the configuration. You can do data transformation powered by AWS Lambda, so you can trigger Lambda functions. You can have some code processing as data arrives in the bucket and things like that. So that's how easy you create a Kinesis Firehose. After a couple of minutes, the status of the Kinesis delivery stream changes to active and it's ready to be used. For the services in our data analytics architecture, we already know we are using Amazon S3 as the storage layer and Amazon Kinesis for the ingestion mechanism with API Gateway in front of it. In this video, I will cover some options that can access the ingested data that is now in S3. Always remembering matching customer needs in order to find the most appropriate service. Let's get started. As we know, separating data storage from processing is important because we can then use the right tool for the job. In our case, we want to process ClickChain data that sits in S3 with large amounts of small files. Let me show you some services that could do that and discuss them one by one. Candidates are Amazon S3 Select, AWS Glue, Amazon EMR, and Amazon Athena. Starting with Amazon S3 itself. There is an S3 feature called S3 Select that could be used for accessing the data. You can use Amazon S3 Select to perform SQL queries to filter the contents of Amazon S3 objects. It meets customer requirements because it is serverless and managed, and it seems to be a good candidate, right? Well, kinda, because the issue here is that Amazon S3 Select can only query one file per query, one file at a time, and not lots of small files. Our solution is very likely to produce multiple objects, unless we are running something else to aggregate the data, which we are not doing for now. That being said, I am not using Amazon S3 Select for that. How about AWS Glue or Amazon EMR? These services are strong candidates for data processing, but they really shine when it comes to processing unstructured data using big data frameworks. I remember the customers saying they are running on reduced staff, and these services have a bit of a learning curve. They could be used for converting data formats, performing data aggregation, or using AI/ML when processing data, which for now does not seem to be a need. I love AWS Glue, but one of our customer requirements is to keep the architecture the most minimal possible because of reduced staff, cost, and maintenance. If we have that in mind, we can exclude Amazon EMR and AWS Glue, leaving the best choice to be Amazon Athena. Let me open my web browser at the page aws.amazon.com/Athena and see what the web page tells, hoping to read something that matches precisely what we need. Amazon Athena. Start querying data instantly, get results in seconds, pay only for the queries you run. Amazon Athena is an interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL. Athena is serverless, so there is no infrastructure to manage, and you pay only for the queries that you run. Athena is easy to use. Simply point to your data in Amazon S3, define the schema, and start querying using standard SQL. Most results are delivered within seconds. With Athena, there is no need for complex ETL jobs to prepare your data for analysis. This makes it easy for anyone with SQL skills to quickly analyze large-scale datasets. Anyone with SQL skills? I mean, that should be easy enough and not demand any technical skills. This seems to be very well aligned with our customer needs. Let me dive a little further into Athena to explain you some concepts, just the necessary information to help you understand Athena on a Solutions Architect Associate level. The first thing to know is that Athena does not make a copy of your data. When you create an Athena table, you have to specify an S3 bucket prefix for where Athena should look for when running a query. That's why the SQL command for creating a table in Athena is create external table. That's why the word external is in there. Data remains on S3, still providing a centralized data repository and allowing us to use the best tool for the job. When creating Athena tables, you need to create a table that matches the format of your data in the bucket. Let's say the files are in the CSV format and they contain something like customer ID, session time, session end, and number of clicks in the web page. you need to create a table that match that structure. You can also create multiple Athena tables and join them. These tables don't even need to reference the same bucket. The only thing we need is having the data in the bucket matching the table schema. So if the data is in CSV, the table needs to be prepared to query CSV data. Same with JSON or other formats. Let me call my customer and ask something about data formats. Okay, take it off and then put the number. Dialing to Morgan.
Hey, Raf. How you doing?
Good, good. I have a question about the JavaScript library. Is this a good time to chat really quick?
Yeah, sure.
So I'm thinking of using Amazon Athena to access the ingested data. But the thing is that Athena needs a serializer, deserializer on the table to be able to understand what is in the files. And among some of the supported SERDs, which is the term for serializer, deserializer, there is CSV, JSON. There's also a SERD for regular expressions, which gives us more flexibility. My question is, are you sending the data in one of these formats, CSV, JSON? I am asking that because I want to avoid using another service to prepare and normalize the data to be friendly for Athena.
That's a good question, Raf. I'm not sure, but we have some developers in the office today. Let me go ahead and ask them. They're the ones who wrote the code, so just 1 second.
Sure.
Hey, do you guys know what the format of the data's in? Oh, it's in JSON? Okay, cool. All right, cool. So yeah, it sounds like it's in JSON format.
Well, that helped me a lot because I can ingest data as is and query with no modification. As long as you send data in the same format, it's all good. That's all I need for today. Thank you. Bye-bye.
All right, bye.
It is clear that Amazon Athena is a good choice here. Now, one thing is to access the data. Another thing is to have a graph. I can use Athena to make SQL queries based on clickstream data. But how about presenting that data in a pie chart or comparing data among different queries? That's where BI and analytics applications come in. Stay with me for the next video. Let's explore Amazon Athena, a service that allows you to start querying data instantly. I am going to Amazon Athena in the AWS Management Console. And first thing I see when I go to Amazon Athena is an option saying Explore the Query Editor. If I choose that option of exploring the query editor, I already have some Athena tables here that are pointing to CSV files in an S3 bucket that I have. One of the tables is called Year 2018, and if you click on the 3 dots to show more options in that table and choose Generate Table DDL, DDL as in Data Definition Language, it will send Athena a command that will show me the create table command that was used to create this table. So create external table because the data actually resides in S3, then table name, and then I have the fields such as vendor ID, passenger count. This is a table that points to CSV files that I have in a bucket in my account called nyctlcref. So the bucket contains prefixes, and within each one of these prefixes, I have CSV files. And these files are in CSV, and I am using the SERD, the serializer, represented by CSV. So I have fields terminated by comma. So because they are CSV files. If I do queries in this table, such as, for example, select star from table limit 10 and clicking run, I will have Athena doing a SQL query in CSV files that are in my bucket. This is just dummy data. This is just data that I have to show you this exploratory Athena demo. And this is how easy to use Athena. You create the tables, you point the tables to buckets. Buckets must have files that must be in the same format that Athena understands how to deal with these formats, either if they are JSON or CSV, or Parquet, which is a columnar data storage. So once you have the files in the bucket and the Athena table correctly configured to know where to look for, you can start querying the data and even joining multiple Athena tables. Our data analytics architecture is almost ready, and I can't wait to show it to the customer. We have decided to use API Gateway and Amazon Kinesis Data Firehose for data ingestion, Amazon S3 for storage, and Amazon Athena for querying the data. Now it is time to add a data visualization layer to complete the solution. The visualization layer needs to connect with Amazon Athena, which is our query service. There are multiple data visualization options in AWS. Among them, candidates for our needs are Amazon CloudWatch, Amazon OpenSearch Service, Amazon Managed Grafana, and Amazon QuickSight. Let me briefly discuss each one, starting with Amazon CloudWatch. Amazon CloudWatch offers dashboards, and that's why I listed it here under data visualization. Amazon CloudWatch monitors your AWS resources in real time, but it is primarily a monitoring service for operational metrics, such as CPU utilization for EC2 instances, number of objects in an S3 bucket, and things that are more related to the operation of the services. Although it can create alarms and detect anomalous data, it is not intended to be used for BI as part of a data analytics architecture. Amazon CloudWatch is more used by system administrators looking for operational metrics, so I am not going to use it for our data visualization here. Amazon OpenSearch service would also give me a dashboard. OpenSearch is a distributed, community-driven, Apache 2.0 licensed, 100% open source search and analytics suite that is used for a broad set of use cases. The issue here is that when I create an OpenSearch cluster, it comes with storage and processing power embedded, and I want to decouple that by using Amazon S3 for storage. Because it has processing, the cost of that cluster may be higher than the scenario using Athena for querying and another service only providing data visualization. I love Amazon OpenSearch service, but there are better services to satisfy the requirements here. Another option would be Amazon Managed Grafana. Grafana is a popular open-source analytics platform that you can use to query, visualize, alert, and understand your metrics no matter where they are stored. Grafana really shines when you need to visualize time series data. Time series databases are built specifically for handling metrics or measurements that are time-stamped. Since our clickstream data may have that property, it could work. I will keep it on the table for now. Although Grafana dashboards are mostly used for monitoring and operational dashboards, it is pretty well suited for BI and data analytics as well. Another offering is Amazon QuickSight, which is a data visualization service that integrates with other AWS services such as, guess what? Amazon Athena. This makes it an ideal candidate for our architecture. Amazon QuickSight has no servers to manage, offers a pay-per-use pricing model, provides native AWS service integrations with built-in security, also enabling data insights. Since both Amazon Managed Grafana and Amazon QuickSight can do the job here, let me call the customer and ask if they are already using one of these services for another project. Because if they are, I can use the same one for our project, saving on potential licensing costs or reducing learning curve. Remember that cost savings is a requirement.
Hello again, my friend. What's up?
Hi, Morgan. Is this a good time to talk?
Sure, yeah. How's the architecture going? I've heard some good things so far.
Yeah, it's going pretty well. I am now choosing what data visualization service to use, and I have a question for you. By any chance, are you already using Amazon Managed Grafana or Amazon QuickSight for another project?
Now that I think about it, yeah, we are. We are using Amazon QuickSight for the sales dashboards in another project. I'm not sure if we can use the same license there, but we would prefer using it because our BI team is already familiar with the tool.
Right, yeah, that's good to hear. I was in between choosing Amazon Managed Grafana or Amazon QuickSight, but knowing that your team already knows how to use Amazon QuickSight makes me think as the service used for data visualization here. Sometimes the best service is the service that your team already knows how to use, right?
Yeah, definitely. I agree. We can have some more internal trainings here so that other people can help the BI analysts learn how to provide insights for the restaurants by looking at the QuickSight dashboards. So this sounds great and would be super handy.
Okay, I got all I need. The architecture is almost finished. I'll call you soon to schedule a date for you to come at our office to see my architecture proposal. Is that good?
All right, looking forward to it. Talk
All
to you
right.
later.
Cool. Bye-bye. All right. Amazon QuickSight it is then. I think this closes the gap between the part that is in scope for our architecture. In the next video, I'll call the customer again to show the full picture. Our solution seems to be complete and we are ready to call our customer and talk about it. So let me call Morgan and explain why I choose these services.
Hey, Ref. How's it going?
I'm doing fine, thanks for asking. Came to the office today, traffic wasn't so bad. How about you?
I'm doing great. Do you have any questions about the architecture?
No, I actually finished it up and would like to show you explaining why I chose one service versus another. Can you come to the office today so I can show you?
Yeah, sure. I can do that. I can drive on in. I'll be over there soon.
Well, that was fast. That was fast, I must say.
Yeah, I'm a very fast driver. On the highways, there wasn't a lot of traffic. So, I got here really quick.
Awesome. Ready
Yeah.
to get started in the architecture?
I am. I'm ready to see. Let's get started.
Okay.
Just as a reminder, one of the things that we were looking for was we have this clickstream data JavaScript library that we built, and we need an HTTPS endpoint to send that data to so that we can then do analytics on it in the background. So my first question for you is, which one of these services here is providing that HTTPS?
Yeah. So it's API Gateway. It's Amazon API Gateway, which is integrating with Kinesis Data Firehose. There is a service integration between Amazon API Gateway and Kinesis Data Firehose that can deliver data to Firehose. Our primary data ingestion mechanism is Kinesis Data Firehose, but we don't want to expose Kinesis Data Firehose API endpoints on the internet, especially because you are doing HTTPS posts from the JavaScript library, right? So I am fronting that with API Gateway, which gives you more ability of specifying your custom domain name, your own SSL certificates if you want, and you don't need to change your code.
Okay, that's awesome. So it sounds like API Gateway is basically just acting as like a proxy for this architecture, and then Data Firehose is the actual data ingestion mechanism.
Yes.
Okay,
exactly.
awesome. So it looks like Firehose then sends that data to S3.
S3, yeah. And I'm choosing S3 here. I had many storage options, service to choose from, and the reason why I chose S3 is because it allows me choosing the right tool for the job. In other words, if I want an ML data processing engine, I can use S3 with that. If I want to have data delivered to another Kinesis data streams, or if I want to have execution of Lambda functions, for example, I can use S3 for that, because S3 is detached from any processing or compute or visualization layer, allowing me to use the one that best fits for the job, which in our case is Amazon Athena, right? So remember when I called you asking if data is in CSV or JSON or any other format?
Yeah, I do remember that.
Yeah, it is because data will come from your front end through API Gateway, Kinesis Firehose. It will land in an S3 bucket. And once this data is in the S3 bucket, you're going to use an Amazon Athena table. So you're going to do a SQL query on the table, and the table must match the same structure that you have in the files.
Got it. Okay.
Right?
So with Athena, we can just use regular SQL for that. We don't have to learn anything new.
You can
for
use
that.
regular SQL.
Okay,
Yeah.
that's great news.
Yeah, and because you are controlling how that data is produced, we are not modifying the data before it lands in the S3 bucket. So as long as you send the data on the same way it is produced, which are JSON files, right? And you have the table schema in Athena pointing to the S3 bucket, you can do SQL queries. Now, when you do SQL queries in Amazon Athena, you're going to have a table as an output of that query.
Right, and so so the output is just like a list of data, right?
Yes.
Yeah, and so ideally we want to be able to visualize that data and actually draw insights from it. So I'm assuming that's where QuickSight comes in.
Exactly.
Okay.
Yeah. Remember when I called you about Amazon QuickSight or Amazon Managed Grafana, if you're already using one of these?
Yes.
It's because I was thinking about which data visualization service to choose from the list.
Okay, great. And then we're already using QuickSight, like I mentioned, so that's great to hear because then we can just reuse that license and we don't have to train our business intelligence team on a new tool. But something you mentioned I thought was interesting. So you're saying we're not modifying the data as it comes through this pipeline here, but we have, potentially thousands of restaurants all generating clickstream data. And so what would happen if one of those websites was misconfigured and was sending data in the wrong format? How would we fix that?
Very good question, yeah. So far in this architecture, we are not modifying the data that comes. But if you want to have that option, there are some data manipulation mechanisms in Kinesis Firehose. And there is also a feature called bucket actions, where you can run Lambda function code in response to put object events in the bucket. Okay. So for every single JSON file that you have, and Firehose aggregates them, so for every file that you have that becomes an object in the bucket, you can run a Lambda function, and that Lambda function can sanitize the data, for example, by cleaning fields that shouldn't be there or things like that.
Right, because as we know, this is the real world, right? So things don't ever work exactly the way we want them to. But so that makes sense. So we're going to use Firehose to send to S3, and it also is. It's kind of cool that it doesn't do every single data point, but it will aggregate into files. And then that way the Lambda function isn't running all the time. It's just when a new file gets added?
Only when new files get added.
Okay, awesome.
You could also have the option of preserving the original data in one S3 bucket. And then when you run the Lambda functions to modify that data, you can use a secondary bucket. Right, this is a pretty common approach as well.
Okay,
and this way I am expecting that no data modification will be needed. But if you need, you can work with two S3 buckets, one for raw data that comes and one for the processed data. And that Lambda function that runs can do other things as well, like querying DynamoDB tables or querying RDS databases and enrich that data and put that enriched data in a secondary.
So then we could have even more data to draw insights from at that point.
Yes, you could have that option.
Well, I think this looks awesome. It seems to meet all of our requirements that we had set out. So I'm really excited to take this back to the team. And I'm also really excited that everything's serverless and it also doesn't require us writing any code. So I think this is great. And thank you so much for putting it together.
Yeah, sure. I remember that cost was a concern. So I only chose services that bills per refined billing.
Yeah, I appreciate that.
There's no cost per hour if you're not using. So at 2 a.m., 3 a.m., 4 a.m., where the restaurants don't have people and you're not generating insights, the cost is lower because all of these services here, they bill by a granular usage.
Right? Okay, perfect.
So yeah, I hope you enjoy. Let's present that to your team later. And thanks for trusting me on designing the data analytics solution for you.
Yep, thank you.
This was the proposal of the architecture to the customer. In this meeting, Morgan also had the chance to ask questions and ask me to rethink some aspects of it. There may be some last-minute requirements that would need an architecture revision, which is not ideal, but unfortunately can happen. As a solutions architect, I can stop here, or I can move further, possibly with additional consulting hours or implementing a proof of concept. It varies case by case. In our scenario, the architecture was simple, with the usage of just 5 AWS services, which was ideal for this course, so I could talk about them a little bit and explain my reasons on which one to choose. It may make sense for solutions architects to stop at the architectural part because scenarios can get way more complex with third-party integration for identity federation, dozens of AWS services, data ingestion from different sources, and etc. I hope this week helped you learn more about each AWS service that we presented. Again, our goal is not to double-click and dive deep into each of the services, but instead show you an approach for how to decide which service to use according to the requirements and customer scenario.
All right, so now that we've built and presented this architecture to the customer, or me, we will both now be playing the solutions architects, and we'll discuss some of the things that can be enhanced or at least considered for the sake of making this architecture better. Rethinking current architectures should be a never-ending effort, and it is a good practice to revisit solutions from time to time because new services may be announced or conditions may have changed. So if we're ready to get going here, if we look at the blocks, we have these extra blocks that were not on the table before. So can you explain a little bit about what those are?
Correct. We have the full picture here, right? So we have both the part that is in scope, which are the blocks at the bottom of the table, the data analytics solution, API Gateway, Kinesis Data Firehose, Amazon S3, Amazon Athena, and Amazon QuickSight. And on top of the table, we have the part that is out of scope of the solution, meaning that customers on their mobile phones, they will scan the QR code. Once they scan this QR code, they will be served with an HTML web page out of Amazon S3. So Amazon S3 is serving that web page. Customer also has a system where restaurant admins can use that system to update the QR codes.
And this system is currently being run on EC2, I think, right?
Yes. Okay. So they upload the S3 bucket with new items in the menu if they want to change prices, if they want to change descriptions, whatever modification they want to do to the restaurant menu. So it goes to S3, and then S3 starts serving that web page for customers who scan the QR code.
Makes sense. All right, so kind of knowing that we have this full system here, we're going to also suggest improvements to the existing out of scope.
Yes.
So with that in mind, I want to make our first suggestion for this architecture, and that would be to potentially look at using a serverless service for this menu update system. So right now, this is running on EC2 somewhere, and that server is running all of the time. But these restaurants aren't updating their menus all of the time at all hours of the day. You know, that's not something that happens constantly. So instead, what we could maybe do is try to change this into a serverless architecture for this part of the system. And so if we think about it, like this one block would probably become many blocks, right? As we break it down into multiple serverless components. So that is going to be my first recommendation for this architecture.
Yes. Another thing I have in mind here is now we have two S3 buckets. One for the data analytics that is in scope of what I suggested to the customer, and another one that is out of scope, which is the bucket that is serving the restaurant menus. There is an AWS service called Amazon CloudFront, which is a content delivery network where you can use Amazon S3 as origin. So Amazon CloudFront can cache contents before delivering to customers, and it has a cheaper data transfer out when compared to Amazon S3.
So instead of the clients coming directly to S3 to get the HTML, they would hit CloudFront
They would hit
first.
CloudFront first.
And so if that data, that HTML data is already cached at CloudFront, that request would never come to S3.
Exactly.
And so with S3, you pay per request as well as the data storage. So if you can reduce the amount of requests that are actually being sent to S3, then you can save some costs there.
Yes, absolutely. And it's also faster because the content may be cached in a location that is potentially closer to where the client is.
Right.
Right.
All right, so the next thing I want to recommend for this would involve getting rid of Amazon API Gateway. So API Gateway was used in this architecture so that we didn't expose Kinesis data firehose directly to the internet, right? We want to have some sort of authentication or some sort of barrier between our firehose and the internet. So what we could do instead is get rid of API Gateway and instead introduce Amazon Cognito. And Amazon Cognito is an AWS service that provides identity pools for authorization. So you can set up authorization workflows with Cognito, and then you can integrate that directly into the JavaScript. So this would require some changes to that JavaScript client library. So our customer would have to make changes to this code, and that would authenticate with Cognito. And then once you're authenticated, you could then send the calls from JavaScript directly to Firehose. So that means you wouldn't need to host and maintain and pay for Amazon API Gateway anymore if you're using Cognito.
And you can use the AWS JavaScript SDK for that, right, on the HTML files.
Right.
Another suggestion that I would do to enhance this architecture is making a CloudFormation template out of this entire solution in a way that you have the entire set in a state where you can reproduce in another AWS account.
All right, so why would we want to have this architecture in different accounts per customer?
Yeah, well, spoiler alert, week 4, we'll talk about multi-account strategies, and we'll do a good job on explaining the advantages of doing that. But you can have better governance. You can have separated billing per account. So if the customer wants to charge a specific restaurant chains for their whole infrastructure stack, in addition to the value they add to them with the system to update the menus and everything, you can have that on separate stacks. Also reduces manual mistakes when operating the infrastructure. So it is a good idea to have that into CloudFormation templates, which is an infrastructure as code tool, which is the first step that you would like to have this same environment on multiple AWS accounts.
Right, okay, that makes sense.
Yeah,
All right,
what else?
So the next thing that I'm thinking here is, again, with that client library, so I'm gonna keep picking on that one there, but for that client-side library, we have it currently sending requests to API Gateway, and the same thing would apply even if it was talking directly to Firehose. You wanna make sure that you have appropriate retry logic embedded into the client side. And you want to also make sure that any retry logic that you have has something called exponential backoff. So for example, let's say you're sending requests from the JavaScript to API Gateway, and API Gateway in, let's say, the region that you're using is experiencing some intermittent issues. You don't want to just continue to flood that service and just keep retrying and retrying and retrying. Instead, what you do is you retry, and then you retry less and less over time as it continues to fail. So implementing things like exponential backoff is a good idea, but having retry logic on the client side is important. And luckily, in the JavaScript SDK for AWS, some of that retry logic is built into the SDK as well.
Yes. Another optimization that I think about here is to change content in the bucket to be more friendly to Athena, for Athena to perform better. You can partition the content. You can transform the content to a columnar data store by converting files from CSV or JSON to Parquet, Apache Parquet. And then you can have Athena doing faster queries, faster and cheaper queries.
All right, so I think that's all of the enhancements we have for this architecture. So thank you, Raf, for designing this week to help our students better understand how to use and mock up the data analytics services. And I think this was a really strong week to help everybody understand a little bit more about how to use each individual AWS data analytics service and when to use them to match the customer requirement.
All right.
Hello, welcome everybody to this video. In this video, we are going to do a walkthrough of how to build a proof of concept for this week's architecture. Again, this is an optional step if you would like to create this in your own AWS account or follow along, but we are going to include some instructions if you do want to do that. So just as a quick reminder, we're going to be building a proof of concept. So this isn't supposed to mimic exact real life conditions. Instead, this is supposed to show our customer how to build the solution that we designed and show them how these services integrate and show them a proof of concept, right? That this does work the way that we said it does. So what we're going to do is build out the API gateway. That's the endpoint where the clickstream front end is going to be sending the data. We're going to be sending that data to Amazon Kinesis Data Firehose, which will then invoke a Lambda function that does some really simple formatting. And then Amazon Kinesis Data Firehose will send that data to Amazon S3 for storage. Once the data is stored in S3, we'll use Amazon Athena to query that data, and then we'll use Amazon QuickSight to visualize that data. So to get started, we need to create some IAM policies and roles in order for this to work. So I already did that. Let's go ahead and navigate to IAM, and I will show you the roles that I created for this demo. All right, so from here, I'm going to select roles. And then we have this role here, API-Firehose. If I click on this and then scroll down, we can see the different policies that exist. I have two policies attached to this. I have customer managed policy and an AWS managed policy. This first one is called API Firehose, and this allows the action Firehose put record. So this is the API call for Kinesis Data Firehose of how you can send information into your Kinesis Data Firehose. So that's the API call, put record, and then we're allowing it against star, which is all Kinesis Data Firehose resources, but you could also put the ARN of the specific Data Firehose once you have it created. And then if I scroll down, we also have this Amazon API Gateway push to CloudWatch logs. This is allowing API Gateway to send logs to Amazon CloudWatch logs. So this role is going to be used as the execution role for our API Gateway, which is going to integrate with Kinesis Data Firehose. All right, so let's go ahead and first let's create our S3 bucket. So from here, I'm going to type in S3 and navigate to the S3 dashboard. And from here, I'm going to select Create Bucket. And now we need to give this bucket a name. Bucket names need to be globally unique across all accounts. So I'm going to go ahead and give this a name, test bucket -Morgan 2022. And then I'll just go 1, 2, 3, 4. Hopefully that's unique enough. And then I will scroll down and we'll accept all the defaults and click create bucket. Now this bucket by default is going to be private. So that's the default configuration. We will later modify the bucket access policy for this bucket to allow Kinesis Data Firehose to put objects in this bucket. But for now, we're going to open up the bucket and click on the properties tab. And then I'm going to copy the ARN for this bucket, because in order to integrate these services together, you have to kind of point one to another and manage permissions and things like that. So I'm going to copy this ARN, and then I have a text editor open on a different screen. And I'm going to be copying and pasting as needed for these tasks to create this POC. So we have our bucket now, and we've copied the ARN for future use. So the next thing that I want to do is actually create the Lambda function that Kinesis Data Firehose is going to be using. So to do that, I'm going to navigate to the Lambda console. And then from here, I'm going to click Create Function. And then we're going to actually use a blueprint for this one. So it's very common to need a Lambda function to work with Kinesis Data Firehose to transform your data before it gets to S3. So what we're going to do is create one of these Lambda functions using a blueprint, and I'm going to type in Kinesis to filter them. And then we're looking for the one titled Process Records Sent to a Kinesis Firehose Stream, specifically in Python 3.8. You'll notice that there is one with the same name for Node.js. So you want to, I think it's, let's see, where is it? Oh, here. Yeah, so Process Records Sent to a Kinesis Firehose Stream. You want to make sure you're picking the right one. So choose the one that's Python 3.8 because that's what we have the code written in for this step. So make sure you're selecting the right one if you choose to do this. So essentially what this function is going to be doing is modifying the data that comes in through Kinesis data streams before it gets to S3. And the reason for that is because with Amazon Athena, it needs every piece of data to be on a new line in order to register it as like a unique item that it's querying. So what we need to do is make sure that each individual event that comes through as our clickstream process gets put onto a new line. And Kinesis Data Firehose right now, as of the time of me creating this demo, puts everything on one line. So we want to make sure that we are allowing those new lines to be put into place. So that's what this is for. So then we'll go ahead and click Configure. And now we can give this function a name. And I'm going to call this Transform Data. And then we can go ahead and scroll down here, and we're going to leave this stubbed out code here for now. I'm just going to go ahead and click Create Function, and we will modify this code in just a second. I have the instructions open on another screen as well, where I'm going to be copying and pasting in information like the code for this Lambda function. All right, so I'm going to go ahead and scroll down. Our Lambda function has been created, and this is the code source panel. So this is where you can actually edit the code. I'm going to highlight this code and blank it out and paste in the code from the instructions. And so you'll notice that this is written in Python. We have some import statements at the top that we're using in the code below. Boto3 is the AWS SDK for Python. And then we are setting up a variable called output, and then we have our Lambda handler. This is where the execution of this code is going to begin. So this is like the entry point, and this accepts an event and a context, which has information about the event. So that would include things like the payload of the event, and then context, this is about the execution. And then we have some code that's looping over all of the records in the event. And then what we're doing is we are decoding that data. We are adding a new line to the end of that data, and then we are re-encoding it, and then we are going to be appending all of that data, formatting it, and then we're going to be appending all of that data to itself, kind of keeping a running tally here with each new event having a new line at the end of it, and then we're going to be returning that data as records, output as JSON here. All right, so now we can go ahead and click Deploy. And then the next thing I want to do is click on the configuration tab. and I'm going to edit the general configuration, and I want to change the timeout to be 10 seconds. And this will just minimize the potential of this function timing out if you had like a large payload. So if you had a ton of events that you were looping over, then you may time out depending on, how many you have and the type of processing you're doing. In our case, it probably won't time out at 3 seconds. It'd be very unlikely, but I'm going to go ahead and up that to 10 seconds anyways. And the reason that we most likely wouldn't time out is because this is a POC. So we're not going to be sending in a ton of data. We're just going to be sending in enough data to prove that this solution does work. So I'm going to go ahead and click save. And now I want to scroll down here and I want to then grab the ARN. So I'm going to scroll up and then I want to copy this function ARN. And I'm going to paste that into my text document off on another screen. And again, this is going to be used for future steps in building out this POC. All right, so now we have our Lambda function created, but this doesn't have any triggers. It's not being used by anything yet. So what we want to do next is create the Kinesis data firehose, which will actually use this Lambda function. So I'm going to go ahead and navigate to Kinesis and click on Kinesis service. And then we can click on, under the Get Started pane, you want to select Kinesis data firehose and then click Create Delivery Stream. And then from here, we want to choose a source and a destination. Our source is going to be a direct put because API Gateway is going to be directly putting events using that put record API call directly to Kinesis data firehose using an AWS service integration. And then the destination is going to be S3. And then you can give this delivery stream a name if you like. I'm going to go ahead and just leave the generated name. And then I'm going to change this section here where it says transform and convert records. We do want to turn on data transformation. So I'm going to select enabled here. And then I'm going to paste in that ARN for our Lambda function. And then we can choose an alias, which is going to be latest. And then I'm going to scroll down. And then we need to change this section here, the destination settings. So where we're going to be sending this data downstream, S3, that bucket we created. So I'm going to go ahead and choose this bucket. And then you can also add a prefix there if you would like to. I'm going to go ahead and just let it put it directly in the main folder of that bucket. So I'm going to scroll down and then click Create Delivery Stream. All right, so now our delivery stream is being created. So you can see it's in this status creating. I'm going to go ahead and copy the ARN for this for now while this is creating. And then if we come back to delivery streams, this is where you would kind of come back and check to see when this is done creating. So I'm going to take a pause here. And then we'll grab some more information about this delivery stream once it's created, and then we'll continue on creating this POC. This step can take some time. So if it's in this creating phase, just keep coming back to this page and refreshing the screen, and it will eventually say that it's ready, it's been created. But it does take a couple of minutes, so be patient, and I will come back when this is done. All right, so I'm back and we can now see that this Kinesis data firehose delivery stream is active. And the next thing I want to do is open back up the stream. And then I want to scroll down and select the configuration tab. And then I'm going to scroll down to the permissions section. And then note how this has an IAM role here. So whenever we created this Kinesis data firehose delivery stream, it created an IAM role for us, and we are going to need the ARN of this role. So I'm going to go ahead and click this. It will open up the IAM console for me to that specific role. And then what I want to do is copy the ARN for that role, and then I'm going to paste that into my text document on the side. And we are going to use this ARN to modify the bucket access policy for our S3 bucket that will allow Kinesis data firehose, this specific delivery stream using this specific IAM role, to put data into that bucket. So with that being said, let's go ahead and navigate to the S3 console and select S3. And then we want to select the bucket that we created, and then select the permissions tab, and then scroll down to bucket policy. Notice how it's currently empty. We're going to add a bucket policy there. So click edit. And From here, you're going to paste in the JSON from the instructions. You also could use the policy generator by going through and adding statements here and things like that. You can also look at policy examples, use the policy generator, which is right here. You could click that, open it in a new tab. But notice how for the one that I just pasted in, let's go ahead and read it. We have a statement. And for this statement, we are first we have one that says I want to allow what principal, the AWS principal, we need to paste in the ARN for that Kinesis data firehose role. So I'm going to go ahead and do that. Notice how I'm getting rid of both of the carets there. You want to make sure that yours looks like this, where you have the complete ARN of that role without the carets on either side. And you will need to make sure you have both double quotes as well, because this is in JSON. And then for the action, we have the different actions that we will need in order to upload objects to this bucket. And then finally, we need to modify this last section, which is against what resources can I make these actions. Notice how I just copied the bucket ARN from up top here. They make it very easy to do that. So I'm going to paste that in here, and then I'm going to paste it in again on the next line. So I'm saying against what resources can this role complete these actions, this bucket, and everything inside of this bucket, right? Okay, so now we'll go ahead and click Save Changes. All right, so now we have our bucket policy has been edited successfully. So the next step that we need to do is create the REST API, which is going to be the endpoint for our front-end clickstream client. So I'm going to go ahead and navigate to API Gateway, select API Gateway. And then I want to choose what API type I'm going to build. I'm going to be using an AWS service integration between API Gateway and Kinesis Data Firehose. And as a part of that, I want to be able to transform the payload of that request using mappings. So I need to choose a REST API to do that. So I'm going to go ahead and select REST API and click Build. And then I'm going to click OK. And then under Create New API, I'm going to select New API. And then we can give this a name, which I'm going to say Clickstream -ingest -API, or sorry, -POC. And then we can leave our endpoint type as regional, and then you just click Create API. All right, now we want to define some methods and our resources. So I'm going to click this actions, and then I'm going to click Create Resource, and then I want to name this first resource. I'm just going to say is POC, and then I'll click Create Resource. This is creating like where you'd send the endpoint. So this API Gateway is going to give you a URL. And then if I did like that URL /POC and then make a post to it, that's what I want our front end to do. So I'm essentially creating a location that you can send this data to. And then I need to create the method for this POC resource, which is going to be, again, a post, because I expect our front end client to make posts to this. All right, next we need to choose the integration point for this method. I'm going to use AWS Service for this because, again, we are using an AWS Service integration to do this. I'm noting I'm in North Virginia. I've been building everything in North Virginia. So for the AWS region, I'm going to choose US East 1, which is the alias for the North Virginia region. And then for the AWS service, I need to select Firehose here, which is right here. Notice how there is also a selection for Kinesis. You need to select Firehose because we're using Kinesis Data Firehose. All right, so now for the AWS subdomain, we're going to go ahead and leave that empty. Then for the HTTP method, we're going to select post because API Gateway is going to be making a post to Firehose once it accepts the request from the front end. And then we're going to leave this use action name bullet selected. And then under the action type, we're going to put record. This is the API call that's going to be made to Kinesis Data Firehose. So this is actually a Kinesis Data Firehose API. And then finally, the execution role. This is that role that we created in one of the first steps in IAM. So we'll paste the ARN for that role right here where it says execution role. And then what we're going to do is leave this content handling as pass through. And then we will also keep this check mark here and just click save. All right, so now what we need to do is modify this integration request further so that this API can transform the incoming request from the Clickstream client into the shape that the Kinesis Data Firehose needs. So I'm going to select integration request. And then what I want to do is I want to scroll down here and I want to select mapping templates and then scroll down. And then what I want to do is I want to select when there are no templates defined. And then I want to add a mapping template. Under content type, I'm typing in application/JSON and then checking this checkbox to get that to save. Then I'm going to click on this and scroll down. And now what we need to do is paste in this VTL from our, which I forgot a curly bracket there. This is from our instructions. So VTL, this is going to be the code that's going to be actually doing the transformation on the payload. So we have to shape the incoming data to be matching the parameters that Kinesis Data Firehose is expecting. So Kinesis Data Firehose put record is looking for parameters, the delivery stream name, and then the records are the actual data. So I'm going to copy the name of the Kinesis Data Firehose delivery stream and go ahead and paste that right here. And then I have the records. So if we just read through this, there's nothing we need to change. But essentially what we have here is we have some VTL that is formatting the information that's coming off of the input, which is the payload. So we are transforming that to be recognized as JSON. We're replacing some characters and we're base64 encoding it. So I'm going to go ahead now and click save. So you need to make sure you click save here. It's a very important step. All right, so now what we need to do is scroll back up, and now I'm going to click back to the method execution page, and now I want to click test. And so now from here, what we're going to do is we're going to test this API out. We're going to be simulating events as if they were coming from our clickstream front end. So I'm going to paste in some information that's from the instructions. This is just a really quick mocked up structure of JSON of what it could look like coming from the clickstream. So again, in the real world, you would likely want to have a library that sends a bunch of data as it would in the real world. If you're building this out to like QA or something like that, before proof of concept, this is perfectly fine. So it has the element clicked is whatever entree they're on, the time spent in seconds, the restaurant name for the menus, like what menu are they on? Because remember, this is a software house, so they have multiple customers. And then the date it's created at. So I'm going to go ahead and click test. All right, and then over here on the right-hand side, we should be able to look through these logs and see the response that we got back from Kinesis Data Firehose. So we can see the request is being sent to this to Kinesis Data Firehose, and then we can see that we received the response status 200. If you see status 400 here or 500, something like that, 400, your stream might not be created yet. So you might need to go and look and see and make sure it's in that active state. If it's not, wait a little bit, try again. If this is 500, then you might want to check the VTL that you pasted in, make sure that's all structured correctly, make sure that your integration request is created properly. And then if you have some sort of permissions error, check your role that API Gateway is using and make sure that that has the permissions to post to your Kinesis Data Firehose. But for us right now, it looks like this did work, so that's great. I'm not done yet though. What I'm going to do is I'm going to generate a couple of different entrees to kind of simulate what some data would look like if somebody was clicking through the menu. So I'm just going to do like, let's say 7 or 8 different tests here. And what Kinesis Data Firehose is going to do is it's going to collect all this information and it's going to aggregate it, and then it's going to throw it into S3. So whenever Kinesis Data Firehose does this aggregation, there is a bit of a lag for time. It can be like 60 seconds or something. So we can verify that this is working by actually querying the data in S3, or you can go to S3 directly. So first, let's go to S3 directly to see if that data is there. It's not going to be there yet because, again, this takes time to actually get posted to S3, but I can open up this bucket, and then I'm going to pause here, and we'll come back. You can just kind of refresh this, maybe give it a couple of minutes. Refresh it, you should see some information pop up here. So I'm going to pause it, and then I'll come back when it's done. All right, I'm back, and we can now see that there's a folder here. So if I drill down into this, we can actually see the file that was dropped here by Kinesis Data Firehose. And so notice how this is partitioned via date. So that's going to become important in the next step as we create the Amazon Athena table that we're going to use to actually query this object. So let's go ahead and go to Athena and select Athena. So now we're at the Athena dashboard, and you need to make sure that you first, before you can create a table, you need to go into settings and then select manage. And then from here, you need to select a query result location. And so this is going to be where you enter in the S3 prefix in this region where you want your query result to be saved as an object. And so if you browse, and then you can select the bucket that you created in the earlier step. And then I just appended result on the end of that and then click save. And you need to make sure you do this before you create the Amazon Athena table. So now we can go back to the editor, and then you can copy and paste in the query to create the table. And there's a couple of things that we can notice about this and a couple of things we have to change before you can run it. So this is creating a table called my ingested data, and this has the rows, element, click, time spent, source menu, created at, which is the exact same structure that was sent in by our clickstream data front end, what we kind of mocked up an API gateway. And then down below, we have partition by date hour string. And then we have the serialization, deserialization, which is going to be in JSON. Because again, we're sending in our data via JSON. And then with these properties, element clicked, time spent, source menu, created at, so it kind of knows how to map that JSON into something that Athena can query. And then the table properties, this is going to be how it's partitioned. So like I had mentioned before, it partitions the data over dates in a specific format. So this is just kind of telling Athena like how you can find the files to query based on the way this data is partitioned. So now what we need to do is take our bucket name that we created in that earlier step. And then you want to make sure that you are replacing this location here, S3:// and then your bucket name. And then down here on line 20 as well, you want to make sure that you replace it here also. All right, so now that looks good. Let's go ahead and click run. All right, so now our table has been created. And now if we want to actually query the data in this, we can click on the plus sign to create a new query. And then we can say select star from my ingested data, semicolon. And this is going to pull back all of the data in this table. We should only have 7 items in the table. In the real world, you might have hundreds of thousands, right? So if you do have hundreds of thousands, you want to make sure you're setting up query limits or that you're filtering or selecting on something more specific. So that way you aren't running giant queries on accident in Athena that cost a lot of money and take a lot of time and resources. So instead, you want to make sure you are limiting these when possible. But right now we know we only have 7 in there. And we're just trying to make sure that this works. So now we're going to go ahead and run the query. All right, and we can see we have 7 results, which is great. We have all of our entrees, the amount of time they spent, so we can see this data's in here. So now the last step is to go to QuickSight and create a visualization there. So let's go ahead and navigate to QuickSight. And whenever you come to QuickSight for the first time, you may need to create an account. I already have an account with QuickSight, but you might need to go ahead and create an account. So once you have your account created, something else you need to do is actually give QuickSight permission to that bucket. So I'm going to go ahead and click on Manage QuickSight. And then on the left-hand side, I'm going to say Security and Permissions. And then I'm going to click on Manage under QuickSight Access to AWS Services. And then I want to make sure that this Amazon S3 is selected. And then you want to make sure that your bucket is selected, specifically the one that you created. And then also click the checkbox for write permission to Athena Workgroup, and then click Finish. And then click Save. All right, so now this is looking good. We can go back to QuickSight just by clicking the upper left-hand corner. And next, what I want to do is create a new data set. So I'm going to click on Datasets on the left-hand side, select New Dataset, and then I want to select Athena. And then I want to give this a data source. So I'm going to go ahead and call this POC clickstream, which is the data source name. And then I'm going to click Create Data Source. And now we can select the table that we want to visualize, which is going to be that my ingested data that we just created. Click select. And now I want to click import to Spice for quicker analytics and click visualize. All right. And now what we want to do is actually create a visualization here. So you can see all the different visual types that you have down here in the left-hand corner. It depends on how your data is shaped on like what's going to be the most important to you, or not necessarily shaped, but what the attributes are and what insights you're trying to derive. So you can go through and you can explore these different types of data sets if you would like. We can see our field list is over here. I'm going to go ahead and just select a pie chart for now and then select element clicked. And there we go. It took a second to refresh, but now we can see we have, equal amounts of clicks for each entree because we only entered in one for each thing here. So this is how you do some visualizations. You can go through and you can click through these and explore them. And we will create a link in the instructions where you can read more about how this works with QuickSight. All right, so it looks like our POC is working. The last step for us that we need to do is delete all of these resources. So in QuickSight to start, since we're already here, I'm going to go ahead and go back to the QuickSight dashboard, and I'm going to click on datasets, and then I'm going to select my ingested data and then click delete, and then click delete. All right, and then if we go back to analyses, we can select our analyses that we just created and click delete, and delete again. All right, and now we're done with that. So now let's switch to the Athena dashboard. So now we're in Athena, and what I want to do is delete this table. So I'm actually going to just change this query and say drop table my, if I can type, there we go, ingested data, semicolon, click run. And that drops the table. So it deletes that table, and then we can go ahead and delete these queries or close the query. If you would like, you can just exit out of that one. All right, so now Athena's been deleted. So now if we kind of work backwards from here, let's go ahead and go to API Gateway and delete that. So click on the API, actions, delete, click delete. Looks good there. Now we can go to Kinesis Data Firehose, click on Kinesis, and then click on the delivery streams, and then select this Kinesis delivery stream. And then we want to type in the name. I'm just going to copy and paste it there. Give this a second to delete. Now you want to make sure that things actually delete in AWS so that way you don't get charged for things that didn't delete correctly. So if you ever see a failure with the deletion of a resource, just make sure you open up an AWS support ticket so that you can get some help with that. There we go. It's successfully deleted. Great. So now we can see that's deleted. So now let's go ahead and go to Lambda. And we'll delete the Lambda function. Select Lambda function, click actions, click delete, and then type in delete. You want to spell delete correctly. There we go. Click delete, click close. And what's next? Probably the S3 bucket. Select S3. And then I want to select this test bucket that we created. I want to first empty the bucket. So select all the objects, click delete, type in permanently delete. I'm just going to go ahead and copy this and paste it below. Delete objects. Looks good. Now I'm going to go back to the source bucket and go back to buckets. Select the bucket, and then I'm going to delete it. And then I'm going to paste in the name, copy and paste the name of the bucket in there. Click delete bucket. And I think that that is everything. You could also delete the IAM roles if you would like. All right, so that is it for this POC. If you are looking for troubleshooting tips, I would recommend that if you see that API Gateway is not integrating with Kinesis, check the permissions between those two things. Make sure Kinesis is actually created. The next step is Kinesis and Lambda. Make sure that you actually have the Lambda function created correctly and that you have enabled data transformation on the Kinesis Data Firehose. The next step is S3. Check your bucket policy. If your bucket policy is not allowing that role from Kinesis Data Firehose, then it's not going to work. And then after that, we have Athena. So you want to make sure that you have those settings for your results set up so that it knows where to post the result object. You need that set up before you can run a query. And then for QuickSight, you also have to allow the permissions to your specific S3 bucket in order for it to read that data. So you want to make sure that you have it there as well. So again, you can kind of go step by step by step to see like how far did the data get in the solution. And then honestly, most of the time, the issue is permissions. So you want to make sure you're double checking your permissions every step that you get. All right, thank you. And that's it. See you guys next time.
It's time for week 3 of our time here together, and this week, Raf will be playing an enterprise customer who is working on migrating some containers to AWS. It is, of course, more complicated than that, and we'll hear from him up next to see what the use case is. It's important to note here that we are purposefully focusing on certain aspects of an architecture without diving into other aspects. We are essentially zooming in on one piece of a larger story. So keep that in mind as we move through the content, that at times we are purposefully simplifying things so we can teach you about the different AWS services in context of solving a problem. Actually solving the problem and building out the solution in real life is a different story, and you'd likely see requirements shift over time and change as you move through a project in real life. As usual, we will hear from our customer and hear their use case, and then we will build out the solution together. Should be an interesting week, so let's go ahead and hear from our customer. Okay, are you ready to hear from our next customer? Let's go ahead and give them a call.
Hello, this is Raf from Any Company Insurance. How can I help you?
Hey Raf, it's Morgan from AWS. We've been emailing about your team's next project. Is now a good time to talk about that?
Yeah, absolutely. Let me give you some background on what we are trying to do and where we are at. So our company has been migrating workloads to AWS as our data center contracts expire. We have already moved some things to AWS, but now we are reaching a point where we want to migrate a workload where half of the servers have expired contracts and half do not. So essentially, we want to move half of the workloads to AWS and leave the other half on-prem for a few years before we can move the whole thing to AWS.
Okay, so it sounds like you're looking at a hybrid deployment with AWS. So question for you about this. I'm assuming the pieces running in AWS will need to communicate with the pieces running on premises.
Yeah, thanks for bringing that up. We will need to maintain network between AWS and our on-prem servers, but it is really important to us that we have the lowest amount of latency and consistent throughput possible for the network between the environments. We don't want to see any significant slowdowns because we split the workload in half. And we will likely have a high volume of network communication from on-prem to AWS. The part of the workload running in the data center will create files that need to be accessed by applications in the cloud. And we would like to ideally store that data in AWS, since eventually everything will be moved over anyways.
Okay, I got it. So I think that makes sense. We need to make sure that the communication between the two environments is reliable, and we need to think about how to store those files in AWS. All right, so what else can you tell me about this workload that you're splitting up? Does it run in VMs? Do you use containers? What type of tech are you planning on using?
We actually use containers right now for all of our applications except for databases. So we plan on using containers in AWS as well. Also, these applications are all internal, so we need to make sure that there is no access from the intranet to the containers we move to AWS.
Okay, great. I love working with containers. They're super awesome. They can make migrating to AWS so much easier, so I'm glad to hear that.
Yeah, we love the portability of containers. And speaking about containers, we really want to try to use the same management tools across the environments wherever possible. Same thing for containers orchestration. We would prefer not using two completely different orchestrators from on-prem and AWS. Would it be possible to use the same things across environments?
You know, I think so. I will look into it to be sure, but I think there are a few AWS services to help simplify operations for you with hybrid deployments like this. I am going to remember that as a requirement.
Great, thank you.
Okay, so you mentioned that your databases on-prem are not running in containers. Do you plan to migrate those databases? And do the applications running in these containers need to access these databases?
Yeah, we plan to migrate a few PostgreSQL database over to AWS alongside the container workloads. That being said, we really do not want to rewrite our code for this migration. So if you can find a solution where things work basically the same on AWS as it did on-prem, that would be awesome.
Okay, yeah, understood. So I'm hearing that you want to try to do a lift and shift approach for this as much as possible, and I can definitely keep that in mind. Is there anything else that you want to tell me about this workload?
Yes, we are really trying to make sure that everything we build has a high uptime. So that is the most important aspect for this migration for us.
Great. Okay, so what I'm hearing is you want to run containers in a hybrid workload. You need dedicated connectivity to AWS for communication. The container workload should be private, not public. And you need a database in AWS that's compatible with PostgreSQL. And then you want to maximize resilience and fault tolerance when possible. And you want to try to use similar tooling across environments when possible with embedded resiliency and fault tolerance.
Yep, you got it. I'm sure more questions will come up as you are working. Feel free to call me at any time.
Oh, I'm sure I will. I'll talk to you soon.
Talk to you soon, my friend. Bye-bye.
Bye. All right, so we just heard from our customer, and here's what we know about their current setup. They are running container workloads on premises and are running PostgreSQL databases also on premises. We know that they have contracts for their current data centers, and half of the applications they're running now are running in locations that have contracts that are expiring, and therefore those applications or workloads are going to be migrated to AWS. The other half of the applications will remain on premises until their contracts are up too, and then those will also eventually be migrated to AWS. Our customer wants to continue using containers on AWS, which is a major requirement, so I will spend some time considering the options we have for running containers on AWS. Then there is that database of theirs. We will need to figure out how to best migrate that to AWS as well, so we need to remember that as a requirement. I also noted that our customer wants to use the same orchestration tools for both on-premises and on AWS if possible, and AWS does have some services that are great for hybrid deployments, so I will be exploring what is out there and what will work best for this use case. We also know that the applications that will continue to run on premises need to store some data in AWS, and the containers running in AWS will need to access that data. But the customer said that they don't really want to rewrite the applications running on premises, so we may need to follow up with them on this requirement when we get there. Another requirement I heard during that meeting was that they really want to optimize for resilience when possible. This is an enterprise customer working in the insurance business. It's extremely important that they have a resilient solution that is fault tolerant, so I'm going to keep an eye out for any single points of failure. Since the customer explained a few times during our call that they don't want to rewrite applications as much as possible, I am thinking we are doing a pure lift and shift for this migration as much as we can. There might be some things that don't totally map without reworking, but it is a priority of mine to try to keep this migration simple for them as far as leaving their application code alone. Luckily, containers are portable in nature, so theoretically, the containers should be able to run the same on AWS as they do on premises. I think this all makes sense, and I'm ready to dive in and begin designing this solution. So let's go ahead and get started. Hybrid solutions like the one we are designing for our customer require network connectivity between the customer's on-premises data center and AWS. If we take a look at our desk here, this is where we will be representing our solution with the building blocks. I have the customer data center represented by the box on the left, and then the AWS cloud represented by the box on the right. We will place service blocks in both of these boxes to design our solution. So first, let's quickly get some details about the network aspect on the AWS side out of the way. For hosting the resources in AWS, we will have the customer use a virtual private cloud or VPC. And to start, we will be looking at this from the perspective of one VPC, one AWS account, and one AWS region. Though later we may decide to change that, but for now, for simplicity's sake, one VPC and one AWS account. Now, in this account, we need to make sure that we have subnets where our customers can place their resources. On our customer call, they mentioned that they are migrating internal applications that do not need to have ingress connectivity from the internet. So that being said, I'm going to suggest that we have more and larger private subnets than public subnets. Now that we have that settled, let's get into the deeper question here. How will we connect the customer data center to AWS? If we go back to our desk here, we need a service between AWS and the data center. There is going to be a lot of traffic flowing between AWS and the data center, and we know that the connection needs to be reliable. So let's talk about a few different choices you can pick from when you're looking at connectivity between AWS and a remote site like a data center. First is the public internet, which I am not going to pick for this one, but let's talk about why that is. The first reason to not use the open internet is security. We want to make sure that no one can do any sniffing on this insurance company's activity. So using a non-encrypted connection over the internet is not a good idea. On top of that, we know the company is really concerned with the latency between AWS and their data center. And using the open internet means that you are at the will of how much throughput is available at any given time, because the overall bandwidth of the internet is shared by everyone using it. So, if there just so happens to be a lot of people consuming a lot of bandwidth in the local area, it could impact the operations for our customer. Not great. So, now let's move on to our next option, which is AWS Virtual Private Network, or AWS VPN. VPNs are a really common and popular way to securely connect your remote network to AWS. So this would take care of that security piece that is needed for our customer. AWS VPN consists of two different services, AWS Site-to-Site VPN and AWS Client VPN. AWS Site-to-Site VPN is used to connect a remote network like a data center to a VPC or AWS Transit Gateway. So this would allow resources living in a customer-managed data center to connect to AWS. Then there's AWS Client VPN, which is more for connecting your administrators to AWS or to your data center. So this is more like when you need to log into VPN from your laptop to access things like corporate resources. AWS Site-to-Site VPN is more aligned with our use case here. Now, VPN connections are still using the public internet in this case. It's just that those connections are private, but it is still at the will of the internet, meaning that if the bandwidth is not available, then performance may suffer. Because of this requirement of having low latency between the data center and AWS, I am considering another service instead of just AWS VPN, and that service is called AWS Direct Connect. AWS Direct Connect is a service that provides a hosted private connection to AWS through a Direct Connect delivery partner or through AWS. Direct Connect provides a private, dedicated connection, so this isn't using the regular open internet to send data between point A and point B. While the data sent over Direct Connect is in transit, the network traffic remains on the AWS global network and never touches the public internet. This reduces the chance of hitting bottlenecks or unexpected increases in latency. Given the fact that we know our customer is going to send a high volume of traffic to AWS and they want reliability with the throughput for this connection, I think AWS Direct Connect will be the right choice for this architecture. So let's go ahead and add the block for Direct Connect to this architecture. Now, if our customer has multiple AWS accounts or regions that they need to connect to with a Direct Connect connection, then I might also want to add something like AWS Transit Gateway in there as well. For this, though, we are going to keep it simple, but I will include links in the readings to highlight some common patterns using Direct Connect, VPNs, and Transit Gateway for hybrid connectivity to AWS. I highly recommend that you read the resources linked out in the readings. It's time to think about those containers. Our customer is running containers on premises and wants to run those same containers in AWS. Luckily, AWS has a number of container hosting services. So first, let's explore the container orchestration services. Container orchestration services exist to help you carry out tasks like launching new containers, deleting containers, scaling containers, and more. These sorts of operational tasks may be easy to manage if you are only running a few containers across a few instances. But with the workload we are talking about, there will be hundreds, if not thousands, of containers that need to be managed. So you really need an orchestration tool to do the heavy lifting. AWS offers two container orchestration services, Amazon Elastic Container Service and Amazon Elastic Kubernetes Service. These two services will manage containers on top of a compute platform, either a cluster of EC2 instances or a serverless AWS Fargate cluster. So, for the first decision, we need to pick between Amazon Elastic Container Service or Amazon ECS and Amazon Elastic Kubernetes Service or Amazon EKS. Customers that pick Kubernetes generally are already running Kubernetes on premises, or they want to have the most flexibility possible. EKS provides a vibrant Kubernetes community, consistent open source APIs, and broad flexibility. This is great, but there is a decent learning curve when it comes to Kubernetes. Just like most technology choices, things generally fall on a scale of convenience versus control. Kubernetes is not super convenient to use when compared to other services, but it does give you a great amount of control. Now, ECS, however, was designed for simplicity and falls on the convenience side of the spectrum. It takes a more opinionated approach on how to run containers, which in turn decreases the number of decisions a customer needs to make when it comes to things like the network or security configurations. For example, if you need a load balancer, multiple types of load balancers on AWS integrate with Amazon ECS, so you don't need to figure out how to do that integration on your own. This idea applies to many services in AWS. ECS is built to integrate with other AWS services natively, so that means less work for you to do custom integrations. All right, so those are two options, ECS or EKS. Now for the compute platform that these orchestration tools place containers on to actually run them. The options for this are EC2-based clusters or AWS Fargate clusters. You can again use the convenience versus control spectrum to help you conceptualize these two services. EC2 is on the control side. You can choose your own AMI for the cluster. You can manage the patching and scaling of that cluster. And you have SSH access to the cluster if you need it. So you really have a lot of control over your cluster. Fargate is much more convenient because it's serverless, but that also means you cannot do things like bring your own AMI or SSH into an underlying instance. It really depends on what you need to decide which option you would choose. So that being said, I think we need to call our customer back for both of these things.
Hey Morgan, what's up? How is the architecture going?
Hi there. So I'm looking at the containers that you want to move to AWS, and I have a couple of questions for you.
Absolutely. What do you need?
Well, I'm looking at the orchestration service and which to use. So what do you use on premises right now?
Right now, we are using a tool that is super old and sort of buggy, actually. We would love to replace it with something more modern.
Okay, well, have you considered using anything like Kubernetes in the past?
Yeah, we considered Kubernetes in the past, but we got overwhelmed by the learning curve and how deep it gets. And honestly, we are not doing anything super complicated with containers. We just have a large quantity of them. Our operation is simple, so I'm not sure if it would be worth it for us to invest in time and effort into having the team learning Kubernetes for now. Yet another thing to take care of.
Yeah, I totally get it. Kubernetes can be worth the investment depending on your use case, but I think that you would really like ECS. It's quite a bit simpler to use.
Yeah, I'll have to look deeper once you design it, but we really just want something easy to use that supports lots of containers running at the same time.
Yep, copy that. So I'm hearing that you want a scalable solution that isn't super complicated. Now, I have another question for you too while I have you here. Is there any reason that you would need SSH access to your cluster for your day-to-day operations?
Yes, we want to provide our own image for the cluster servers, and we also want to be able to SSH into servers whenever we want. This is what we currently do on-prem, and I want to do one change at a time. We can learn a new orchestration tool, but otherwise I'd rather keep things aligned to, what a regular VM can do as much as possible for now.
All right, I think I got it. Thank you so much. That is all I need for now.
All right, cool. Call me if you need anything else.
Will do. All right, so based on that clarification from our customer, I'm going to recommend two things. First, that we use ECS as the orchestration tool, and then second, that we use EC2 instances for the cluster. Let's go ahead and add those to our diagram, Amazon ECS and Amazon EC2. We'll place ECS here in the AWS region, but not in the VPC, and then we'll place EC2 in the VPC here. Now, these EC2 instances will be in a private subnet because we already learned in the initial customer conversation that these are private workloads. This means that these instances will have no internet connectivity, either ingress or egress. Now, let's say there's an EC2 instance or container running in a private subnet that needs to download information from the public internet. For example, let's say I have user data scripts that run on the EC2 instances on boot up. This user data script is used to bootstrap the instance, installing the necessary software at boot so it's primed and ready to go for the specific use case. Oftentimes, this type of thing connects to the internet to download software packages. With the setup we have now, those requests would fail because there is not a path to the internet from our private server. Because of that, I want to add a NAT instance or NAT gateway to this diagram. A NAT resource, which stands for Network Address Translation, would sit in a public subnet and would have access to the internet. What it does is, if there's a resource in a private subnet that needs to reach out to the internet, but can't because it's private, the request from the private resource would be routed to the NAT resource instead. The NAT resource would receive the request and say, listen, EC2 instance in the private subnet, I know you cannot talk to the internet, but I can, so let me go ahead and do this for you. Then the NAT resource would make the call to the internet, get the response back, and then send the response back to the original private EC2 instance that made the request in the first place. This all happens without ever exposing that backend resource in the private subnet. So these NAT things are actually pretty important. We have two options for this as well, a NAT instance, meaning NAT software installed on an EC2 instance, or a NAT gateway, which is a serverless NAT service. The key to knowing which one to choose is based on 1, cost, 2, scalability, and 3, reliability. Maybe not in that order. It depends on what you're optimizing for. A NAT instance's performance will be bound by the underlying EC2 instance type and size. So if you pick a small EC2 instance type for it, then you may become resource or throughput constrained if you have many private resources all using one smaller NAT instance. This is, however, oftentimes a more cost-effective option over a NAT gateway. That being said, NAT instances are also not inherently redundant. You'd need to host multiple NAT instances in each availability zone to ensure that if one goes down, you have a backup available, and then you would need to manage failover. You also could set up a NAT instance in a steady-state auto-scaling group and set the min, max, and desired to 1. That way, even if the NAT instance went down, it would spin up a new one right away in its place. That is surely an option for someone who is trying to be cost-conscious but has smaller workloads. That being said, we have an enterprise customer who has a large workload and who is trying to ensure that there are no single points of failure and that their solution is reliable. NAT gateways are managed and they are also massively scalable, so there is no underlying instance that you need to worry about becoming overloaded. NAT gateways scale up and down as needed, and they are hosted redundantly within an availability zone. You would want to ensure that you have one NAT gateway per availability zone so that the workload is AZ independent. That is true for most services that go inside of a VPC. You want to make sure you are utilizing at least 2 AZs and spreading your workload across them so you have resilience and fault tolerance. I'm going to go ahead and add the NAT gateway block to this desk that will be used by the EC2 instances in the private subnet. All right, so far we have AWS Direct Connect connecting the data center to AWS, ECS to manage the containers in AWS on an EC2-based cluster, and a NAT gateway for egress communication from our private instances. Lots of work to do, so join me in the next video and let's keep architecting and learning together. In our initial customer call, we learned that they are running a PostgreSQL database on premises that needs to be migrated to AWS. And we also heard about how resilience and fault tolerance is extremely important to them. Instead of comparing a bunch of database services in this video, I am instead going to start with the best fit for this use case, and then explain some of the features that can be used to help improve resilience and fault tolerance. The service I'm going to be talking about is Amazon Relational Database Service, or Amazon RDS. Whenever you create an RDS DB instance, you select which database engine you want to have installed and configured on that instance. For our customer, they would select PostgreSQL. Once the DB instance is booted up, they can then connect to the instance and load their database schema and begin to migrate their data to the instance. So let's say they have one instance up and running. What would happen if that instance went down? If this is an AWS service, does that mean it's going to automatically provision a new one in its place? We know from our customer that resilience is important to them, so we should be asking these types of questions every step of the way. What will happen if this component breaks? Well, in the case of RDS, when you create a single DB instance with the default settings, if that instance becomes unhealthy, there are no magic underlying mechanisms to fix your instance. You have to ensure that you are selecting the right configurations for high availability and resilience. Luckily for RDS, we have RDS multi-AZ deployments for this problem. With a multi-AZ deployment, there are 2 DB instances, one in each AZ. One is the primary instance, and the other is the secondary instance. The applications that connect to the database use a DNS name that points to whichever instance is the primary instance. If the primary instance becomes unhealthy, failover is initiated, and since failover happens via DNS, the endpoint doesn't change, but the secondary instance would become the new primary instance. All of the synchronization and failover is managed by AWS, which makes this a great option for running highly available databases. Once failover occurs, you can then look into why the primary instance failed. Another feature RDS has to offer that could be helpful depending on the use case is read replicas. Let's say our customer is running business intelligence reports from their PostgreSQL database, and these reports require complex SQL to be run. Complex SQL queries generally consume a lot more CPU than something like a simple read or write does. So the more reads of the data that are being done with complex SQL, the more CPU is being used. If there is not enough CPU available when reports are run, then the applications using the database may be impacted as well, and you could see latency or potential failures when working with the database. This is where read replicas can be helpful. Read replicas are created from a source DB instance and are then kept in sync with the source so that read-heavy workloads can be directed to the read replica instead of the primary instance. For our example, if we had our customer run their business intelligence reports on the read replica instance, this would reduce the CPU usage on the primary instance and therefore would help keep that instance healthy without needing to scale up the instance. Read replicas are supported by multiple DB engines that are supported for RDS, and some even support cross-region read replicas. Now, beyond this hypothetical situation for business intelligence reporting, we know for sure that our customer needs to migrate their database to AWS. So how exactly does a migration like this work? You first need to build out the schema on an appropriate database instance in RDS, and then you need to migrate the data over. You also need to ensure that the databases are being kept in sync all the way up to the point of cutover so that there aren't any gaps in the data when the new database on AWS goes live. I plan to recommend our customer to use AWS Database Migration Service, or AWS DMS, to help with this task. DMS helps you migrate your databases to AWS with pretty much no downtime, which is pretty much awesome. When setting up DMS, you would make the on-premises database the source and the RDS database the target. Once you set up DMS, any data changes to the source database that occur during the migration are continuously replicated to the target, which means that the source database can be fully operational during the migration process. After the database migration is complete, the target database will remain synchronized with the source for as long as you choose. You can switch over to the target database at a convenient time for you. Let's pull up the documentation for this service to take a look at a helpful diagram. We can navigate to aws.amazon.com/DMS. Now if we scroll down, we can view some of the use cases for DMS. Under use cases, you can see that the first one we have listed here is homogeneous database migrations, or when you're migrating from one database instance to another but using the same database engine. This is our use case and the most straightforward one. You can use DMS to migrate to RDS or Aurora from an on-premises database, EC2, or another RDS instance. You can also use DMS to migrate heterogeneous database migrations, where the source database uses a different database type than the target database. To do this, you would need to use another service called AWS Schema Conversion Tool to convert the source schema and the code to match the target database. Once that is done, you would create your target database and then use AWS DMS to migrate the data and keep the two databases in sync. Some more use cases for DMS are keeping development and test databases in sync with production. This would be great to use so that the data you are working with in testing is the same data that you work with in prod. You could also use DMS to consolidate databases, so migrating multiple database instances into one Aurora instance, for example. And finally, the last use case I want to go over is continuous data replication. This use case is great for disaster recovery, and I also want to note that the source destination databases can be located in your own data center outside of AWS, running on an EC2 instance, or running on an RDS database. All right, with all of that being said, it's time to update our architecture. This time, we will add Amazon RDS to the AWS side of things, And we will also add DMS to the AWS side of things as well. Right now, we are simply picking out the services we will be using, but I will be building out a more detailed architecture diagram later, so stay tuned. Okay, so in this video, we are going to go ahead and explore Amazon Relational Database Service. You can see that I am already in the console, and I'm going to select Amazon RDS. This brings me to the Amazon RDS dashboard, and from here you could view any databases that you already have, but I'm going to go ahead and create a new database. So selecting Create Database, and this brings us to the page where we can choose our database creation method. I'm going to select Standard Create. And here for the engine options, you can see the different database engines that we have, like Amazon Aurora, MySQL, MariaDB, PostgreSQL, Oracle, or Microsoft SQL Server. Our customer is using PostgreSQL, so I'm going to leave that one selected. And you can see that you can also choose the database version. So if you're using a specific version on premises, it's probably a good idea to use that same version in the cloud when you first get started to make sure that your applications operate the same way. If we scroll down, I can then select whether I want this to be a production database, a dev test database, or a free tier database. I'm going to go ahead and select the free tier database, and then from here, you can see that this availability and durability was just grayed out. And this is where you would select things like the multi-AZ DB instance or cluster, or whether you want a single DB instance. We have the single DB instance selected because this is a free tier RDS instance. If you were using production, you would likely choose a multi-AZ DB instance. Now we can scroll down and we can see the DB instance identifier. This is just a name for your database. We'll leave it database 1 for now. Then we have the credential settings. We have a username and a password. And this username and password is used to connect to the database. So if you're using a client to interact with your database, like for example, if you're using MySQL, you would use MySQL Workbench. So you would use this username and password and the endpoint to connect so that way you could load your schema and you could begin migrating that data. So I'm going to go ahead and give this a password. And this password and username would also be used for any applications that are writing to this database. Then I can scroll down and we can select your DB instance class. If I open this, you can see that everything's grayed out except for the free tier eligible instance types. So I'm going to go ahead and select the default. And then scrolling down, we can then select the storage type. So with RDS, this is going to be backed by essentially EBS volumes for the storage layer. So you can see that we have the EBS volume types, like general purpose SSD, which is GP2, or provisioned IOPS, which is IO1. General purpose SSD is a solid state drive, and this will give you a baseline of performance. And so it's kind of right down the middle. It's good for most use cases. And for cost, it's right in the middle. Then we have provisioned IOPS. This will give you a larger amount of throughput for reading and writing to disk. So it will make things faster for reading and writing data. And so provisioned IOPS gives you more IOPS. So input output per second is what that is standing for. And that's IO1. And then we have magnetic disks. This is going to be the slowest as far as IOPS goes, but it's also going to be the most cost effective. So you kind of have this balance that you have to make on the type of storage drives that you want to use. I'm going to go ahead and select general purpose SSD. And then you can also allocate the amount of storage that you want to have based in gigabytes. It's important to note that the size of the drive that you have is also going to be correlated to the amount of IOPS that you have. So the larger drive you have, you can have more IOPS. So we have here that it notes higher allocated storage can improve IOPS performance. That's something that might be useful to know. I'm going to go ahead and enable storage auto scaling, and this will allow the storage to increase automatically after a specific threshold has been exceeded. And then you can go ahead and you can define that threshold. Now we can scroll down here as well. And this is going to allow you to choose whether you want to set up a connection to a compute resource for this database. I'm going to go ahead and leave this as no for now, and then scroll down. And from here, we can look at monitoring. I'm going to leave Performance Insights on. If we click this info here, we can see that Performance Insights is an advanced database performance monitoring feature, so it makes it easy to diagnose and solve performance challenges on RDS databases. So we're going to leave that enabled. And then we can scroll down here as well and click Create Database. Now, RDS takes a couple of minutes to create, but once you have your database all created, it will give you an endpoint, and then you can connect to that database, load your schema, migrate your data, and begin working with the database. That's all I wanted to show you for this RDS exploratory demo. As always, we will link out to more information where you can get deeper learning on RDS. We heard from our customer that they will have applications that continue to run on premises, and these applications will create data that needs to be accessible from both on-premises and AWS. So what we need to do is now review some storage services that may come to mind when designing the solution. Let's go ahead and pull up aws.amazon.com/products/storage to review what storage services are out there and their use cases. Again, you may know off the top of your head the different storage services that are out there, but it's a good idea to check the AWS documentation every now and again so that you are up to date on any new releases, as these new releases can modify the approach that you take to architecting solutions. All right, so checking out this page, I'm going to scroll down to the AWS Storage Services section, and in this section, we can see that we have listed Amazon Simple Storage Service, or S3, Amazon EFS, or Elastic File System, Amazon FSX, and Amazon EBS, or Elastic Block Store. These are the services that I want to compare before making a decision. All right, so first is Amazon S3. S3 is something you should be familiar with by now, but as a reminder, S3 uses a REST API to store and access objects, and it scales automatically because this is a serverless service. You place objects in buckets, and each object can be up to 5 terabytes in size, though each bucket does not have a size limit. This means that you can store virtually as much as you want in a bucket, but any individual object needs to be under 5 terabytes. S3 is used for object storage, and object storage is best used for data that is written infrequently and read often. Because for object storage, anytime a file is changed or saved, then the entire file must be rewritten. This is unlike block storage, which has the capability to write only the blocks that have changed. Now for Amazon EFS. Amazon EFS is file storage for the cloud, and it uses the NFS protocol for file storage. Multiple compute instances, like our containers, can all use EFS to access the files at the same time. This is also a managed service because the underlying storage is scaled automatically, which makes it a great choice for hosting file systems with low operational overhead. Then there's Amazon FSX, which is similar to EFS in that it provides a file system in a managed, scalable way, but Amazon FSX is built for file systems like NetApp on top, OpenZFS, Windows File Server, and Lustre. These are all different file system software, so if our customer was already using one of these file systems, then we might consider using Amazon FSX. Then finally, there is Amazon EBS. EBS volumes are like virtual hard drives that you can attach to EC2 instances. And they are block storage, so they are ideal for running things like databases on EC2, but they are not managed for scaling, and they also need to be attached to an EC2 instance to be used. EBS volumes come in different sizes and types, just like EC2 instances, and I highly recommend that you get familiar with the different sizes, types, and use cases. I'll link out in the notes for further reading on this. Before we make a decision, we should find out a little bit more information on the data that is going to be stored and how it's going to be used. Let's give our customer another call.
Hello, hi there, Morgan. How can I help you?
Hello, so I'm working on this project for you, and I'm at the point where I need to decide where we are going to store that data that is being generated from the on-premises applications. Can you tell me about how that data is used once it's stored?
Sure, yeah, let me think. Well, the data is generated by the applications and then stored in files in a file system we have here on-prem. Once the files are in place, they are read by other applications, but that data is not changed. It's just referenced or used by other applications.
All right, that makes sense. So what types of processes are accessing this data?
Well, we use it mostly for analytics, processing, and machine learning. And those are the applications we are planning to move to AWS, but are currently running in containers on-prem.
Okay, yeah, that's great context for me. So you have a lot of data that will be stored and used for these applications, I'm assuming. So I need to make sure that it's scalable. What about the life of these files? Once files are processed by the other applications, how long does that data need to stick around?
Yeah. Well, now that you mentioned it was an issue we are dealing with right now, we have all of these files and no reliable way to automatically move storage classes for files when they aren't needed anymore. For us, files are generally processed after a week they are created, then we may access them a few times here and there, but after a year, we don't really look at them anymore. We would like a way to automatically move files to a lower cost storage class so we can save some money on the storage part.
Okay, cool. So Amazon S3 has something called lifecycle policies that may be able to help there. It's something for me to think about. Now, I know you mentioned before that you don't really want to refactor the on premises applications if possible. So, that being said, do you know what protocol is being used to store the files right now on premises? I'm wondering if I can come up with a solution so that you can keep using whatever protocol is already being used.
Well, we use a Linux file system on-prem, so we are using NFS and we would like to continue using that protocol in the cloud as well. We do plan to eventually rewrite the applications to use cloud native object storage for many reasons, but for now we just want to continue using NFS.
All right. And what about latency? Are there any considerations to be had around the latency for reading or writing that data?
Yeah, if it's possible, we would like our on-premises applications to have the lowest possible latency for writing files. We want to avoid a situation where a write is taking forever to upload because it needs to traverse the internet. So we want to optimize the writes for speed.
All right, understood. That's all for now. So thank you.
All right, thanks, bye.
Bye. All right, so knowing we want to use NFS protocol to store and access the files, that can help us narrow down our storage choices. Amazon EFS seems like a natural choice here. It supports NFS file systems, and you would be able to use the file system with the on-premises applications over Direct Connect as well. EFS also supports the use of lifecycle policies to move older files to a more cost-effective storage tier. The only thing I can see being an issue here is that the customer wants to optimize for local writes so that there is minimal latency when uploading files to AWS. The files will be stored in AWS, so if we use EFS, the applications writing the files will need to wait for the network traffic to get to AWS and back over Direct Connect before moving on. There is some potential for latency here. I'm not sure how much of a problem it would be or not, but there is another option I'm thinking of, and it does use Amazon S3 behind the scenes. Now, Amazon S3 itself does not support NFS like our customer needs, but there is a service that is designed for hybrid solutions like our use case called AWS Storage Gateway. Pulling up the Storage Gateway webpage at aws.amazon.com/storage gateway, AWS Storage Gateway is a service that provides on-prem applications access to cloud storage. And if I scroll down to this helpful diagram here, you can see that we have 3 different services outlined under the Storage Gateway umbrella. First, there is File Gateway, and this will provide either NFS or SMB protocol, which we know fits our use case. And what it does is provides low latency local access and efficient data transfer to an S3 bucket in AWS. But your local applications can still use industry standard file protocols like SMB or NFS. So this would be great because our on-premises applications would not need to be rewritten. Then Storage Gateway also provides Volume Gateway, which is for the iSCSI protocol. And finally, there is Tape Gateway, which is for the iSCSI VTL protocol. Let's focus in on Amazon S3 File Gateway. The way this works is that applications running on premises would write their files to Storage Gateway using NFS. Then Storage Gateway would asynchronously write that data to S3 behind the scenes. So this addresses our customers' latency concern, because the Storage Gateway is a local device, so it will be low latency for both reads and writes. From there, the data would be in S3 for the applications running on the containers to access. There is a local cache of data kept on premises using File Gateway, so if any applications needed to read files from S3, they could do so with low latency, and they could also use NFS. Through Storage Gateway, you can take advantage of S3 lifecycle policies to manage storage tiering and deleting old objects to keep costs down. And the great thing is that all of these files are in S3. So later down the road, if the customer does decide to use native object storage with S3, all of the files are already there. So there won't be any secondary data migration for these files. So given the hybrid nature of our solution and knowing that Storage Gateway was built for these types of hybrid solutions, I'm going to go ahead and add Storage Gateway to our diagram. And I'm going to add it twice to the table. Once on the AWS side of things, and I'm also going to add it in the corporate data center side. Then we also need to add another block here, which is Amazon S3. That's where our data is going to be stored. So I'll add this to our diagram as well. You can see that I'm already logged into the console, and what I want to do for this video is explore Storage Gateway. So what I'm going to do is select the Storage Gateway service, and this will bring us to the Storage Gateway dashboard. Now with Storage Gateway, you are going to be using it as a hybrid service, so we can't really deploy this service, but we can explore it and understand a little bit more about what configurations are available to us, and that helps us wrap our head around what we can do with this. So on the left-hand navigation, you can see we have file shares, FSX, file systems, volumes, tape library. So if you remember, we had those 3 different types of Storage Gateway. There was the file gateway, the volume gateway, and the tape gateway. I'm going to go ahead and click Create Gateway, and then give this gateway a name. So I'm going to just go ahead and name it Test. And let's go ahead and expand this How It Works section here. So the way that this works is you create your gateway and you connect it to AWS and activate it. So this is something that you need to do with your on-premises device. And then you create your gateway configuration and you can start using it in AWS. And then you can create your resource. After your gateway is all created through this wizard, you can start to store and access your data in AWS using Storage Gateway. So I'm going to go ahead and give the gateway a name Test, and then you can select the local time zone based on where you're deploying your gateway. So where is that device going to be on premises? What time zone is that? And you want to go ahead and select that here. So I'm going to go ahead and select Eastern Time, and then I'm going to scroll down, and you can see we have to select what gateway type we want. Amazon S3 File Gateway is going to allow you to store and access objects in S3 using NFS or SMB. And this also includes local caching where that device is installed on premises. Then we have FSX File Gateway, and this is going to allow you to use Windows File Server using SMB protocol. Then we have Tape Gateway, where you can store virtual tapes in S3 using iSCSI VTL. And this would also allow you to store your archive tapes in S3 Glacier Flexible Retrieval or Glacier Deep Archive. So if you have tape backups, this is something that would be helpful for that. And then we have our Volume Gateway, where you can store and access iSCSI block storage volumes in Amazon S3. So now if we scroll down, this is where we kind of have to just imagine what the process would be like. So you have to select here what your host platform is going to be. Is it going to be VMware? Is it going to be Microsoft Hyper-V, the Linux KVM, Amazon EC2, or do you have a hardware appliance? So you would select that, and based on what you select, the instructions will change on how you are going to connect this to AWS. So you can see that we have some instructions here to set up your gateway. This will include things like downloading information, installing it on your gateway, and then after that, you can say, yes, I downloaded the template and installed it, and I'm ready to keep going. And then from there, that's when you could continue setting it up and figure out the rest of the configurations that you need for your gateway. This is about as far as we can take it without an actual hybrid deployment going on here. So I'm going to go ahead and click Cancel, and then click Leave. And from here, I'm going to just remind you to please dive into the documentation where you need extra information on how AWS Storage Gateway works. It's time that we take a look at another requirement that our customer told us about, where they want to use the same operational tools across AWS and on-premises where possible. Luckily, AWS has a lot of different services that work for a hybrid deployment, like the ones that we are working with. I would recommend that if you want to pursue a career in architecting solutions on AWS, that you become very familiar with migrations and hybrid deployments. It's good to know the use cases for these services before you need them so that you can more easily draw on your knowledge of AWS to construct a solution. Again, I'm going to use the AWS website to see what exists. So much about working with AWS is knowing what services exist and their general use cases. Once you have that down, you can dive deeper into the solution and see what is a real fit or not. But if you don't know what exists, then how can you make that determination, All right, so if we pull up the product page at aws.amazon.com/hybrid, we can scroll down to a list of AWS hybrid cloud services. I'll choose a few to review here, and then we can think about which ones could be incorporated into our architecture to meet our customers' requirements. First, in the compute section, there are some really interesting services I want to talk about. The first being AWS Outposts. Outposts is such an interesting service because it's one of the few services that involve actual hardware being delivered to your data center. With Outposts, you can essentially run AWS services on premises through the use of Outpost racks or servers. This could be great for a use case that requires super low latency, where traversing the internet to AWS is just not a feasible option. Or it could be great for working in a highly regulated industry that require things like data needing to be stored in a very specific location. Next up, let's go ahead and talk about containers. For containers running in a hybrid deployment like our customer has, there are two major choices for container orchestration tools as we've talked about, Amazon ECS and Amazon EKS. We have already chosen Amazon ECS for our customers' containers in the cloud, but AWS also has services that provide consistent tooling for managing containers on premises as well as in the cloud. These services are Amazon ECS Anywhere and Amazon EKS Anywhere. With these two services, you can reduce support costs for running containers in a hybrid environment, and you can reduce any redundant efforts for managing these containers. This would help solve our customer requirement of using the same tooling across environments where possible. So I'm going to go ahead and add ECS Anywhere to our diagram now. Using ECS for our customer will require them to redefine and redeploy their container deployments on premises, but the actual code or containers themselves will likely not need to change. The way ECS Anywhere works is that you first need to create an activation key so you can register the VMs you plan to use for the containers on premises. Then you need to install the AWS Systems Manager agent, or the SSM agent, and the ECS agent on those servers using that activation key. We will talk more about Systems Manager in a few minutes here. After that, you then define your application and deploy it the same way you would with ECS in AWS, and ECS can then manage those containers on premises. Okay, so back to our hybrid cloud web page here. The next category for services is storage. You should be familiar with one of these already, as AWS Storage Gateway is listed here, and we do intend to use Storage Gateway for file storage. Then there is AWS Backup, which is a really awesome service that you should be familiar with. AWS Backup centralizes data protection management and compliance for your applications running on AWS or in hybrid environments. Using AWS Backup, you can protect VMware workloads running on premises and on AWS, as well as data stored on AWS Storage Gateway volumes. Our customer may want to consider using AWS Backup to manage their backups across environments. So let's go ahead and add AWS Backup to the architecture diagram here as well. Our customer may or may not choose to use this, but I will include it on their architecture and they can look further into whether it's a fit or not, but I want to make sure that we bring it to their attention. Now onto networking. For networking, we have listed here AWS Direct Connect and Amazon Route 53 Resolver. We are already using Direct Connect, and you should understand why this service is such an important thing for hybrid deployments already. Moving on to the management category, and this one has a lot of different services listed. There are a few for identity and access management, like AWS Directory Service, which you can use if you want to use Microsoft Active Directory to connect AWS resources to on-premises. And there is AWS Identity and Access Management, or IAM, as well. Then there are other monitoring and observability services like Amazon CloudWatch and AWS X-Ray, which can be used across environments. But the service I really want to discuss here is AWS Systems Manager. AWS Systems Manager is a secure end-to-end management solution for hybrid cloud environments. What Systems Manager is all about is helping you manage and operate your resources at scale. The at scale part is important because we are essentially talking about automating tasks instead of doing them manually. For example, let's say I have a massive fleet of servers, both on AWS and on premises, and I need to run the same script on all of these servers. I could, of course, do this all manually. Log into each instance, run the script, record that I ran the script, and then do it again and again until it's all done. The issue with this is that it is 1, time-consuming, and 2, prone to human error. Systems Manager offers a feature called Run Command, which makes this a lot easier. As long as the instances you are managing have the SSM agent installed and configured correctly, then you should be able to group these instances appropriately in Systems Manager, and then designate a script to run on the chosen instances. You can group instances by tag or other metadata to make more granular groupings of resources. This makes it a lot easier to manage your fleet. Also, remember ECS Anywhere? I stated earlier that in order to use ECS Anywhere, you need both the ECS agent and the SSM agent installed on the VM. So the SSM agent is used to manage and operate resources, and ECS Anywhere uses this agent to manage the on-premises VMs to orchestrate containers. Systems Manager has a lot of different features, and I covered one, which is Run Command. I could spend probably an entire class deep diving into all of the features of Systems Manager, but instead I will link out to the Systems Manager documentation, and I really encourage you to give it a light read and familiarize yourself. If you are ever overwhelmed by the documentation, I would recommend reading the Frequently Asked Questions or FAQ pages, which often give you the highlights without getting too detailed. All right, so that being said, I will go ahead and add our last block to the desk. Systems Manager on premises here, and Systems Manager on the AWS side to represent that we will be recommending to our customer that they can use the same tool to manage virtual machines both on AWS and on premises. Now, this diagram is a little bit busy and really doesn't capture all of the detail needed for this architecture. Just like our customer is bound by their on-premises resources and wants to move to the cloud, I am bound by the physical resources of these blocks and this desk, and I need to expand my capabilities. So I have created a digital version of this architecture with greater detail that I will go over in the next video, so stay tuned. Let's explore AWS Systems Manager. So if I go to the navigation bar here in the AWS console and type in SSM, I'm going to select Systems Manager. And Systems Manager is really a big collection of different features and services that we have for management tools. So Systems Manager is going to help you gain operational insights and also take action on AWS resources, but also on hybrid resources. So something really quick to understand about Systems Manager before we dive in any deeper is that Systems Manager has something called the SSM agent that you would install on any nodes that you intend to manage or operate using Systems Manager. So there has to be a process running on those machines in order for it to be used by Systems Manager. So if we look in the left-hand navigation, there's a lot of different things that is offered by Systems Manager. First, we have Operations Management. So if I go ahead and click on Explorer here, you can see that we have Operations Management Explorer, quickly view ops data and take actions against ops items. This is where you can create customizable operational dashboards for your AWS resources. So you can aggregate any data and work items related to operations across AWS accounts and across regions. Now, if we keep going down to application management, let's go ahead and go to Parameter Store. So Parameter Store is a totally different service. So if we think of, we just looked at Ops Manager, and that helps you with operations dashboards, Systems Manager Parameter Store does something totally different. So what this allows you to do is it allows you to create key value pairs and then reference those throughout your code or command. So let's go ahead and create a parameter. I'm going to click Create Parameter. And then from here, we can give this parameter a name. So for example, let's say I want to reference the name of an S3 bucket in my code somewhere, but I don't want to hard code that bucket name, because if that bucket ever changes, then I have to redeploy my code. So instead, when we have constants like that, we want to externalize them either as environment variables or as parameters. So here I'm going to go ahead and create a parameter. I'm going to name this S3 bucket for app, and then we can determine if we want to have a standard parameter or advanced. I'm going to go ahead and just select standard here. And then we can determine what type of data this is. This is just going to be a string because it's just the name of a bucket. And then we can have our data type. Do we want this to be text or do we want it to be something else? I want it to be text. Also, one more thing about the type, notice you can have a secure string. This means that it would encrypt the data using KMS. There is also another service, though, called Secrets Manager that can do things for secure strings as well. So we're going to go ahead and leave this just as a unencrypted string. And let's say that the value of this bucket name is Morgan example bucket. And then from here, I can go ahead and click create parameter. And now we have a parameter that I can then use in either things like commands. So maybe I have a script that's referencing this. Maybe I have some application code that's referencing this. But parameter store is a place where you can store a key value. So the name, the key, is S3 bucket for app, and the value is going to be Morgan example bucket. So that's another thing under AWS Systems Manager. Now, if we keep exploring Systems Manager, we can scroll down to the next category, change management. Let's select maintenance windows here. So you can see already that these services are all operational in nature, but they are very different. There's a lot of different things under Systems Manager. So for maintenance windows, you can schedule and implement maintenance tasks across your fleet. So this allows you to select or create a maintenance window and then assign targets to that maintenance window, assign tasks to the maintenance window, and then review the status after the execution is completed. So for example, let's say I needed to do patching, and I want to do patching during a certain time of night. I could create multiple groups of my nodes, or let's say EC2 instances that I want to apply this patch to. I could create the maintenance window here in Systems Manager, assign the targets based off of the nodes that have that SSM agent running. Then I could assign the task, which has the patching instructions in there, and then I could review the status after that execution has completed. So maintenance windows is another thing within Systems Manager. Now scrolling down, I want to do one more, and that is for run command. AWS Systems Manager run command is going to allow you to create predefined commands, or documents is what we call them in run command, where you can basically have a script that runs across EC2 instances without needing to SSH into those instances and run it. So if I click run a command here, we're not going to actually run one, but we can see what types of command documents exist. So for example, let's select AWS configure Windows Update. And from here, we can see the description. I want to enable or disable automatic Windows updates. So maybe I'm having an issue right now where I say, the latest Windows update is causing some issues with our software. I want to disable automatic Windows updates for all of the nodes within a particular resource group. I could use this document to do that. So if we click on the content, you can see that we have a JSON here that is going to have a bunch of different information that includes this PowerShell script, because PowerShell runs on Windows. And then you can see the actual command that's going to be run. And so if you were so inclined, you could read through this and read what it's doing. But the other thing here too to note is that you can create your own documents. So you can have documents that are custom made with your custom scripts, and then you could deploy those to manage your fleet of servers. All right, so let's go ahead and navigate back to the AWS Systems Manager dashboard. And that's all I wanted to highlight for this particular service. As you can see, this is a big service with lots of different things. So you want to make sure that you spend some time getting to know the high-level use cases for these services. Systems Manager is kind of like a world of its own, and you don't need to know every single thing deeply, but I would say that you should understand from a high level the main functionality and features of Systems Manager, including things like run command, patch manager, maintenance windows, and then maybe session manager, things like that. So I would go ahead and take a light read through the AWS Systems Manager documentation and make sure that you are familiar. Like I said in the last video, as our customer is bound by the physical constraints of their data center, I am bound by the physical constraints of these blocks and this desk. So we are moving digital to review our architecture. So looking at this diagram, it paints a bit more of a detailed picture than before. Let's go ahead and call our customer with a screen sharing session to review the architecture with them, and I'll cover any smaller components that I added to this whenever I converted it to digital.
Hi there.
Good news. I have an architecture diagram to review with you.
Wow, that's great news. Let's dive in.
All right, so first, let's start with the network connectivity. First, I want to highlight that I've determined, given the information that you laid out for me, that AWS Direct Connect will be the best choice for connecting your data center to AWS. The reason for this choice is that you need to send a high volume of data to AWS and you need consistent throughput for this connection. So AWS Direct Connect will be the better choice over something like AWS VPN.
Interesting. Okay, that makes sense. Tell me more.
All right, so the containers that you plan to run in AWS will be managed by the container orchestration tool Amazon ECS. And here's the fun part. The containers in your data center that you do not plan to migrate will also be managed by Amazon ECS using the feature ECS Anywhere. This will require that you create task definitions for all of your containers, but the containers themselves or the code in those containers aren't likely to need to be changed.
Okay, cool. What about a container registry? We are currently using Docker Hub for the container registry. Can we still keep using that?
So a container registry being the repository for your container images, you can use Docker Hub to integrate with Amazon ECS, or if you want to change to using Amazon Elastic Container Registry or Amazon ECR, I did go ahead and add that to this diagram. That can always change though, depending on what your goals are. Remember, this is just a first pass at this solution, and I anticipate that a bit of this will change to meet your specific needs.
Okay, I'll keep that in mind. We can iterate on this. I can look into ECR.
Great. Okay, so with ECS, you'll need a cluster to place your containers on in AWS. So we need the compute part to actually host these containers. I chose Amazon EC2-based clusters for this task so that you can bring your own AMI and you can keep SSH access to those underlying instances. This should help keep operations similar across the two different environments. I also noted using Amazon EC2 autoscaling here to scale the cluster, but there are some container-specific things that will help you scale here as well. That's another conversation. For load balancing these containers, I chose the application load balancer for you.
Great. I'm getting excited looking at this. There is lots of work to be done, but I think it's a good start.
Exactly. So now for the PostgreSQL database. We have Amazon RDS with a multi-AZ deployment with one instance in two different availability zones. We recommend that you spread your workload across at least two AZs so that you can see that with both the EC2 instances in the ECS cluster and the RDS DB instances, we have these spread out redundantly across AZs. This is so that you have a resilient and fault-tolerant workload. If one AZ becomes unavailable for some reason, your workload can still run in the other AZs.
Thank you for keeping resilience in mind. That's always a good thing to have. What else is here? I saw you added storage gateway too. What is that?
Yeah, so I know you mentioned that the containers running on premises will need to be able to store files on AWS using NFS. So Storage File Gateway helps you do just that. You can store files using the same protocol, and then Storage Gateway will keep a cache of files locally in the data center, and then push those files to Amazon S3 to be stored asynchronously long-term. I know that latency was something you were concerned about with this file storage, so this should be able to solve the latency problem while still giving you the tools to store files in S3 using NFS.
Wow, that's super cool. AWS has what, hundreds of services? I didn't know about that one.
Yep, AWS has a lot of different services. Now, I want to point out that in the VPC, the ECS cluster and the RDS instances are in private subnets. So I added a NAT gateway and a public subnet in each AZ for egress communication with the public internet. This is so that these instances can download things from the internet without being exposed to the internet.
Yep, I'm following. That makes sense.
Then finally, I tried to find tools that you can use to manage your resources in AWS and on premises. So for that, I included AWS Systems Manager for things like running scripts, doing patching, and other operational management tasks. And I have AWS Backup here for you to manage all of your backups on premises and on AWS in one central place.
Wow, this is awesome. I need some time to sit down and think about all this. I'll bring this to the team and we will get back to you with questions or suggestions that we may have. Is that okay?
Yep, sounds good. Thanks, and I will talk to you soon.
All right. Talk to you soon. Bye-bye.
All right, hello and welcome back. I'm sitting here with Raf, and we are both solutions architects in this video. And what we're going to do is we're going to review the architecture that we built for our customer, and we're going to identify places where we could maybe optimize it, make it a little bit better, or maybe just have some different options for our customer. So, Raf, would you like to kick us off?
Yes. So to start with, customer has a direct connect, right? Connecting the corporate data center with the AWS cloud. A good idea could have a VPN over the internet as a redundancy for the direct connect.
Okay, so why would we need that?
In case there are any issues with the direct connect in the router that runs on the corporate data center, or in case there are some issues with the configurations or something else. AWS Direct Connect provides you two endpoints in two different availability zones. So physical issues are less likely to occur on the AWS cloud part of the diagram, but
on the corporate data center
But on the corporate data center, you're going to need a router, right? So you can have a VPN over the internet just as a failover to be used when or if direct connect configuration has some.
Which is important for our customer who is an enterprise customer, and they really needed resilience. So we would want to make sure that there are multiple ways that you can get to your AWS accounts just in case something fails. So that makes sense. Another thing that I was thinking for this customer is for Amazon RDS. So RDS is kind of like a sort of managed service, but the actual DB instance itself doesn't scale in and out like serverless services do. So you have to think of ways to build in scaling. And so one thing that we have for RDS is called auto storage scaling. And so that will scale the underlying storage mechanism up as it needs more storage. So that's something that a database administrator may have to do. But instead, if you enable the storage auto scaling, then the underlying storage, as you consume it, it will grow. So you don't have to log in and add more storage capacity. So I would recommend that for this customer as well.
Yeah, that adds extra resiliency as well. Another idea would be using, because the customer is an enterprise customer, another idea would be using a secondary AWS region for a failover. There are some failover strategies. You can have multi-site active, where you have everything running in one region, also running in a secondary parallel region. There is pilot light, standby, multiple. There is even a white paper, an AWS white paper that talks about DR strategies using multi-regions.
Yeah,
Could be interesting to deploy that. And one thing is that for multi-regions, you're very likely to need infrastructure as code.
Yes.
Because you would like to have the exact copy of what you have here running in another region.
Right, so there's different approaches you can take for disaster recovery that kind of range from like the most cost effective to the most resilient, right? So there are trade-offs there. So the multi-active for multiple regions, it's going to cost the most because you have an exact replica of this whole thing in another region, but you can do smaller versions of that as well. It just depends on what your goals are and what your budget is.
For example, you can have a mimic of that, but instead of having the full fleet of EC2 instances, you can have a reduced fleet in an auto-scaling group.
Right, I think that's, isn't that called like a warm standby or something like that?
The pilot light, you have a small, right?
Yep.
But one thing is important. You would like data to be already there. You would like data to be already replicated and running in a different region. So, which brings me to the next enhancement that I could suggest, which is enabling S3 lifecycle policies and also cross-region replication. Amazon S3 cross-region replication can replicate the contents to another AWS region, even though the bucket contents are encrypted. And S3 also does lifecycle policies for data intelligence tiering. So it can transition objects from one storage class to another to have automatic cost savings.
Right.
That's a good recommendation.
Yep, and that's also important. If you are replicating your data across regions, then you have multiple copies of it. So it becomes more important then to make sure that you have
that you have less storage costs.
Exactly. You want to reduce that storage cost since you are duplicating. So that makes sense.
Yeah, and you can use DMS for if you're not using Aurora multi-region. You can use AWS DMS for having a copy of your data running.
Right, that continuous replication.
Yes.
Right. And then one other thing here that I want to call out is with our containers, ECS on EC2. So the EC2 instances can be scaled in and out using auto scaling, but with the containers on top of the EC2 instances, you kind of have to use the built-in mechanisms with ECS to do that container scaling. So it's important to understand when you're working with ECS or container services that there are other scaling mechanisms that are specific to ECS that you're going to have to bring into the fold here whenever you're thinking about how do I scale this compute layer as well.
What else we have here?
Yeah, so one more thing that I would recommend for Amazon RDS is, in the spirit of resiliency for our enterprise customer, is you can use read replicas across regions. So like we were saying before, you can do multi-region deployments. And so with RDS, you can have read replicas across regions for certain database engines. And one of the database engines that supports that is PostgreSQL, like our customer needs. So then at that point, any of the read replicas could be promoted to be the primary. So I would recommend that to our customer as well.
All right. Thank you, Morgan, for helping our students understand hybrid deployments in AWS. This was a great rundown of the types of services that can help running hybrid workloads in AWS. Week 4, here we are. I hope you have been enjoying the course so far. In this week, we are going to explore a very common scenario, which is something that actually happened with me almost a decade ago when I started discovering the AWS cloud. At the time, I had some Linux skills and I was working for a startup company. I knew how to configure web servers, so I started configuring environments for the application the company was creating. Naturally, I started taking care of these environments and then became responsible for them. Month after month, the responsibility was growing in a way that I realized that taking care of account governance and cloud infrastructure required a full-time job. I started my career as a software developer at that time, then slowly I moved into SysOps, then DevOps, then Solutions Architect, and nowadays I work as a principal cloud technologist in AWS, teaching everything I had learned in my journey so far. In this week, Morgan will be playing a customer who is in a very similar situation that I was in the past. Enough talking. Let's go straight to action and call our customer to learn about their current architecture and what I will offer as an enhancement. Okay, let's call our customer to learn more about the current status of what they have in the cloud.
Hello, Morgan speaking.
Hi Morgan, how are you doing? This is Ref. Do you have some time to talk? I remember you asked for a meeting to discuss something about your concerns with the environment.
Yeah, so I had some meetings with our team here, and I put together a list of items that I urgently need to remediate. I'm afraid that things in my AWS environment are getting out of my control really soon because I don't know that the way that things are running right now are ideal, and I kind of know it's not ideal, and I just really need some help.
I know how it is, yeah, but don't worry. Together we are going to devise a plan to organize things out. I remember you said you have everything running in the same AWS account, is that right?
Yeah, that's correct. So right now, the way it is, we have one AWS account. We call it the prod account. And let me tell you a little bit of history on how we got here. So we're a marketing agency, and we create websites for our customers. And sometimes these websites run on EC2 instances with RDS databases. Sometimes they're serverless. Sometimes they're in containers. It kind of varies a lot from project to project. But we have everything for all of our customers running in a single AWS account right now.
Yeah, I assume that's not what you want because you may end up touching the wrong environment by accident, right? I mean, even if you do infrastructure as code, which I remember you said you do for some workloads, you may touch the wrong stack and bad things may happen. I assume you are looking for an organized way to divide these big accounts into smaller pieces of infrastructure. Am I correct?
Yeah, that's right. And we've already had some of those things happen where I've accidentally changed the wrong thing and made some mistakes. And so the way that this kind of happened was I was one of the first employees, and because I had some Linux skills, I initially created the environments that we needed. And now I'm kind of responsible for everything that we do in the cloud, which, is sometimes okay at the beginning, but now as our company grows and evolves, we have a lot more things that I just can't really handle. So now I'm kind of concerned with the management side of things as well as billing. So the way that things are now, everything is like kind of tagged, and I can kind of do billing reports based on some tags, but not everything is tagged, and I have no way to reinforce tags. And as I'm no longer going to be the only person working in our AWS account, new developers keep asking for AWS access, and I just don't know how to dole out that access or how to manage the resources that they create and make sure they're tagged, things like that. And I'm just really, really worried about all of this getting out of control, being in one account and all of it being in my hands.
Yeah. I've seen this happening a lot. I mean, not having things getting out of control, but I've seen customers sharing your very same concern. That's pretty normal. Well, there are strategies and lots of guidance to mitigate that feeling. And I am thinking about devising a strategy that uses AWS services to provide a multi-account strategy with proper governance and security guardrails. Tell me how you are logging into this AWS account nowadays.
Yeah, so I'm actually logging in with my personal email address. So that means that I use the root user to log in. And then I have some of the staff that I've added recently. They use IAM users, but they promise that they're always super careful not to do things without letting me know.
Yeah, that's bad. You are relying on a very basic permission mechanism, right? And I personally believe it's a matter of time before an accident happens. According to your scenario, I can define some requirements for organizing things out. How does that sound?
Yeah, that sounds great, Raf. I've been to some AWS reInvent breakout sessions, and I know that we can organize all of this mess that I have into a very mature architecture. So I know it's possible. I just need some help getting there.
Yeah, absolutely. So, tell me more about the team of people that needs access to the AWS account. Are they developers?
Yeah, so they're really good technical people, and they have some cloud and coding expertise. Our company works with some projects for customers, and usually our team members are the most skilled technical personnel on a given project that are accessing our AWS resources.
All right. In the future, these folks can be part of what we call a Cloud CCOE, or Cloud Center of Excellence, which will be the group of people who will have access to the accounts. For the sake of doing that the right way, I am defining our requirements to have a shared services account where they log in and from there use single sign-on to access other accounts. We are going to use multiple AWS accounts, and using centralized credentialing would avoid replicating users on every account. And because you are going to have multiple accounts, I will let you know everything possible to reinforce resource provisioning and automatic configuration across these AWS accounts, okay? So I am listing that as a requirement as well.
All right, yeah, that sounds great. Do you have anything else in mind that could help me out here?
Yeah, I'm also adding a requirement to have a dedicated account for logging, like security or API activity. That's a good practice in terms of governance. So to see if I captured it correctly, we have 1, the need for multiple accounts with automatic account provisioning, 2, a shared services account that people will initially log in, 3, single sign-on among the accounts, 4, security guardrails on these accounts, and 5, an account for logging. Did I get it right?
Yeah, I mean, you're the expert here, and that sounds like a dream to me. So I think you got it all. I think that would be awesome, and I'm just looking forward to getting a plan in place.
Okay, Morgan, I will get back to the office and starting devising that plan.
All right, thank you so much. Hopefully after all of this is done, I can sleep better at night because it's really been driving me crazy.
No problem. Talk later. See ya.
All right, bye.
Bye. Wow, that was a lot. I must confess, I had to take a deep breath when Morgan said she uses the root user for logging into the account. But that's unfortunately more common than you think. Our customer has a pretty typical scenario where cloud is not their main expertise. They are a marketing agency that needs cloud environments to deploy customer workloads. Because they need environments, they started with a single AWS account a while ago, and that small AWS account grew as the company grew. You might have noticed that our customer was a bit anxious, unsure, didn't know what to do. That's common. And sometimes customers don't know what they don't know, or at least they don't know what they need. In that case, part of the solutions architect role is to help the customer understand what's missing. Customers may not come with well-defined requirements, and that's fine. In this case, me as the solutions architect or someone in the role of a consultant can and should help the customer define their requirements based on architectural best practices, which is what I did. So let's recap the requirements we have so far. It is clear that our customer will benefit from well-defined governance standards by having multiple AWS accounts to organize things. So I set that as one of the requirements. As you're going to see in the next video, there are some ways to group AWS services into separate accounts. This can be per workload, per client, per environment like dev, QA, and prod, and other arrangements. As usual, here there is no one best strategy. We will discuss some strategies and pick one to use as an example in the lectures. Another requirement is enabling a shared services account that the admins will initially log into. When users log into these accounts, they can use single sign-on to log into other accounts. That's needed because we do not want to replicate user credential among all these accounts. Another requirement is to set automatic account provisioning and enforce configuration standards for newly created accounts. This can be done. Last but not least, I defined a requirement to have centralized logging in an account, which is a security best practice. That account can employ stronger security best practices like prevent logs from being deleted. All that seems complicated, but you will see that it's not. With the usage of the right AWS services and knowledge, we can devise a plan to bring this architecture to the next level and help our customers' success. Each business need is unique, and there is no definitive formula to choose how resources should be grouped together. But there are some recommendations. And the first one is to group workloads based on business purpose and ownership. Different business units or product teams might have different processes. An option is to isolate distinct business units into different groups. Business units isolation can help teams operate with greater decentralized control while still having security guardrails. This approach is actually one of the most used ones, and I remember our customers saying they are a marketing agency running workloads for other customers. I think this approach fits their need, and it's the one I will choose for our scenario. On top of segmenting per business unit, we can apply a workload segmentation model. That way, each environment from each separate customer will have its own organizational unit, or OU. For example, Customer A can have its own organizational unit. Within that OU, Customer A can have 3 other OUs, one for dev, another for testing, and another OU for production. In the dev organizational unit, developers can have dedicated AWS accounts for themselves with a Cloud IDE configured. With the help of mechanisms such as SCP or service control policies in AWS organizations, you can prevent developers from spinning up resources that are not authorized, like large instance types on dev environments. All that while still having billing controls individually per account. Splitting all that into separate AWS accounts facilitates governance and access, making it easier, for example, to limit the access to the prod account to only members from the Cloud Center of Excellence, or the most experienced people in the company. Also, billing in AWS is naturally charged per account, so having multiple accounts facilitates billing a lot, making it easier to identify potential billing bottlenecks. Now, one thing is right. From the moment you start having multiple AWS accounts, you gotta have 2 things in place: automation and centralized credentialing. If you don't embrace these 2 aspects, things can and will get hard to manage pretty quick. There are many advantages to use multiple accounts. To summarize, you can 1. Group workloads based on business purpose or ownership, 2. Centralize logging, 3. Constrain access to sensitive data, 4. Limit blast radius from adverse events, 5. Manage costs better, and 6. Distribute AWS service quotas and API request rate limits across accounts. Stay with me for the next video, where I will explain the basic authentication mechanism across AWS accounts, or IAM roles. You might be familiar with the term IAM roles. If you aren't, stay with me in this video and you will understand what they are for and how they work. IAM roles are part of AWS Identity Access Management, or IAM. It is a service that manages credentials for access to an AWS account. AWS IAM provides, among other things, IAM users, IAM groups, and IAM roles. IAM users and roles are IAM entities that provide credentials and permissions for access. IAM groups are a collection of users. Users have permanent credentials, and roles provide a temporary credential or a URL for signing. This operation is called assume role. Using roles is important because when you have multiple accounts, you would like to prevent replicating IAM users on every account. That's where IAM roles come in. Let me show you a demo of how it works. Alright, so this demo will create a role in what I call the account A, allowing a user, an IAM user from account B, to do the assume role operation, the assume role API call. So account A is the account that will contain the IAM role, and the account ID is the account ID that finishes with 8173. It is called developer account A. I will create a role in this account, and the role trust relationship, meaning who is authorized to assume this role, will be an IAM user called Raphael from another account. That another account will be account B, which will contain the user who will assume the role in account A. The role permissions will have administrator access, and the role name will be called admin role. So I will be logging into the AWS Management Console for account A, and I will create a role that has a role name of admin role with the permission as administrator access and the trust relationship as an IAM user from another account. When we refer to that IAM user, we will need the ARN, or the Amazon resource name of that user. ARN for IAM users starts with ARN, AWS, IAM, account ID, user / the username, which in my case is Raphael. Let me go to the console of account A, and let's create the role by going to the Identity and Access Management IAM dashboard and choosing the option Roles. I can choose Create Role from the top right corner, and here I can specify who will be able to assume that role. What is the trusted entity? What is the trust relationship for that? Notice that I can allow EC2 instances to assume role. Notice that I can allow Lambda functions to assume role. In my case, I want to allow an AWS account to assume a role. This role will be called a cross-account role. I can specify another AWS account, and I need to provide the account ID. I am going to copy the account ID from my document, and I will go and paste right on the box that says account ID. Next, I can choose what are the permissions I want to allow for this role. I can search for administrator, and I can scroll down, and there are some administrator access there, and one of them provides full access to AWS services and resources. This is the one I want. But if it was an auditor role, for example, I could create an IAM policy that only allow listing resources. Actually, that policy already exists. Once the policy is defined, I can proceed and give the role a name. Admin role is the role name, and I can even put a description. IAM role to be assumed by another user from another account. Scrolling down, I can click in Create Role. The role is now being created, and if I choose the option View Role, I can go and see the permissions. I can edit the permissions later, and I can also edit the trust relationship. When I specify that another account ID can assume the role, it assigns root. I can change that to be user / Raphael, which is the ARN for my user in the other account that wants to assume the role. When I update the policy, now this role is allowing the user Raphael from another account to assume. What I am going to do next is log in the AWS Management Console as Raphael from the account B, and I will assume the role. And now I am logged as the user Raphael from the other account. To assume the role, I can refer to the top right corner of the AWS Management Console and choose the option Switch Role. Then I choose Switch Role again, and I can specify what is the account that has the role and the role name. The account that has the role is the account that ends with 8173, which is the account that I created the role. So I am going to copy and paste it here. And the role name is admin role. When I choose the option Switch Role from the AWS Management Console, the operation Assume Role is being done right now, and I am now logged assuming a role in another AWS account. From there, I can do API calls to the services. In this case, because I have administrator access, I can do pretty much everything in the account. If it was a role that restricts access to view only, for auditors, for example, then I could only be able to list resources but not create resources. And that is done with the policy that is attached to the role. Luckily for us, there are AWS services that can provision new accounts as needed. This service will already create administrative roles on newly created accounts. The understanding and usage of IAM roles is vital because it is the core cross-account authentication mechanism. As I showed in the demo, these roles can be configured to have select IAM users, groups, or even other roles from another account to be assumed. This is useful to avoid replicating the very same users across accounts, and it is the basics for centralized credentialing. Now that you know the basic cross-account authentication mechanism, it is time to talk about AWS Organizations, a managed service that will help you organize your accounts. AWS Organizations help you centrally manage and govern your environment as it grows. Let me open a web page at aws.amazon.com/organizations and explore the service from there. Remembering I am exploring it on an AWS Solutions Architect Associate level, so I won't be going too deep here. This is the web page for AWS Organizations. It says, centrally manage and govern your environment as you scale your AWS resources. Scrolling down, there is a section that says how it works, with a logo of AWS Organizations telling centrally govern your environment as you grow and scale your workloads with AWS. With AWS Organizations, you can create accounts or add existing accounts, so you can invite other existing accounts to your organizations as well. You can create groups, which organizations calls organizational units or OUs. Then you can apply policies powered by a mechanism called SCP or Service Control Policies. I'm going to do a demo and you're going to see how it works. And you can enable or disable AWS services in the child accounts inside your organizations. The AWS Management Console for AWS Organizations provides you with an option called Create an Organization on the upper right corner. If you choose that option, AWS Organizations will create the basic organization having the current account as the management account. From there, you can create other OUs, which I am going to do by going in Actions and create new organizational unit. So I'm going to choose the root organizational unit, Actions, create new organizational unit. Here I will create an organizational unit called Customer A. Create organizational unit, simple as that. Now inside Customer A, I want to create another organizational unit because we are dividing per customer and then per workload. And inside Customer A, I will call Dev Environments as an organizational unit inside Customer A. So far we have the root organizational unit, Customer A, and inside Customer A we have Dev Environments. Now another thing I can do with AWS Organizations is using SCPs or Service Control Policies. We can find it on the sidebar searching for the word policies, and Service Control Policies is available right there. So I can click in Service Control Policies and enable the usage of Service Control Policies. Service Control Policies are permission mechanisms that govern the entire organizational unit boundary or account boundaries. So I can click in Create Policy and choose a name for my new service control policy. I will create an SCP that prevents instances other than T2 micro, other than the instance type T2 micro from being created. So I'm going to add the name T2 micro only, and the policy description, I will say only allow T2 micro instance type. Scrolling down, I can specify the policy JSON document, which I already have here. I am going to paste and explain what I am doing, what this policy is doing. There is a statement in this policy that is allowing EC2 instances to be from being created, right? Now, there is another statement that is an explicit deny on the operation run instances if the instance type is not T2 micro. So this policy here is explicitly denying EC2 instances other than T2 micro from being created. Create policy, that policy got created. I just created an SCP. What I am going to do next is go on accounts, choosing customer A, choosing the dev environment's organizational unit, choose policies, choose attach, and I am going to attach the T2 Micro only policy within that entire organizational unit for dev environments, meaning that every single AWS account that is within that organizational unit will have that policy that has an explicit deny on creating EC2 instances that are not T2 Micro. Now I'm going to add an AWS account, and I can do that by choosing the option Add an AWS account. I need to provide that AWS account a name, which in my case will be dev workload A. It could be anything. And I need to provide an email. Also, AWS organizations will suggest me to create a role with the name organization account access role, which I will leave it there and I will copy that for now. Once I choose create AWS account, AWS organizations is creating one brand new AWS account for me. I'll just wait for some minutes for the accounts to be created, and meanwhile I can view all the pending creation requests. There are no pending creation requests. Probably the account had already been created. Let me refresh the page. And I can see that I already have a dev workload A, which is a brand new AWS account that was created. I can now select that account and move that account to our organizational unit. So I am going to move this account to the dev environments. From the moment I move this account, that SCP is already governing on the account, meaning that not even the root access for that account can create instances that are not from the type T2 Micro. Right? Okay, so I just created a new account, I created a new organizational unit, I created an SCP, I attached the SCP into the organizational unit, and how do we log into that new account? So I can assume a role via the AWS Management Console by selecting, and remember the role demo that I did, I can get the account ID, copy, and I can go on the upper right corner on the AWS Management Console, switch role, I provide the account ID of the account I just created and the role name. The role name is Organization Account Access Role, which is the default one that organization suggested to me. So you can see that I just created a new AWS account. That new AWS account had a role in it, and I just did the assume role API call, which you should be familiar by now. Now let's do some tests to see if the SCP is actually working. Let's go to EC2 and try to launch an instance. So I am going to launch instance, and I am going to leave everything on the defaults. Even the name, I'll leave on the defaults, and instance type, I will choose an instance that is not T2 Micro. So let's say I want to launch an instance that is C5.12x large. Launch instance, proceed without a key pair because we just want to test the SCP. And then you will see that this instance creation should fail, which is what we got here. Launch initiation failed. And that failed because the SCP is governing. You can see the SCP in action. If I go there and change the instance type back to T2 Micro, and launch the instance will be able to successfully launch. And now we have an instance where the instance state is pending. If I want to go back to the original account, I can go to the upper right corner in the console and choose switch back. This way I am back to my shared services account, to my main account. All right, let me call my customer to share the good news.
Hey, Ref, how's it going?
Doing good. So, for the account creation automation, there is a service called AWS Organizations. With AWS Organizations, you will have a mechanism for creating accounts and applying security boundaries with the SCPs, which are service control policies applied at the account level. Not even the root user of these accounts can do anything if there's an explicit deny in one of these policies. AWS Organizations can also remove accounts, ideal for cleaning up resources with no leftovers. It also provides billing separation per account. A long time ago, before AWS Organizations was launched, This feature was called AWS Consolidated Billing.
Ooh, that sounds super nice, very helpful. And what a coincidence. I was actually reading about this service yesterday. The thing is that to log into the newly created account still requires me to assume a role, right? Like users still have to log into the AWS console to one account in order to jump into another, right?
You are correct, but there is a better way to do it. Next, I am going to tell the students who are watching us to stay with me for the next video where I will talk about IAM Identity Center, which does single sign-on in multiple accounts using custom identity providers like Microsoft Active Directory. It works as a charm.
Nice, Raf. Listen, thank you so much for the help on this.
No problem. Bye-bye. Talk later. So far, we are using AWS organizations in our main account, or the shared services account. So let me add the AWS organizations block into our architecture diagram in the main account, in the shared services account. AWS organizations can automate the creation of other accounts, such as, for example, accounts for workloads A or accounts for developers. For that reason, I am adding a developer account into my architecture diagram with an IAM role inside it. This IAM role will be created automatically by AWS organizations when the account is created. Perfect. I just covered how to automatically create new AWS accounts with AWS organizations and apply security boundaries with SCPs, or Service Control Policies, which is an AWS organization feature that applies guardrails at the account level. With that level of granularization and organization, no pun intended, you may end up having tens of accounts. So you may be asking if there's a way to use single sign-on and move between these accounts. The answer is yes, and let me show you how to do. For that, you can use IAM Identity Center, which is a new name for a service formerly named AWS Single Sign-On. You can enable AWS IAM Identity Center, and when you enable that, it will give you the option of creating users. Users can have email addresses, first name, last name, and in this demo, I will be creating users and using these users to connect to a single sign-on to AWS accounts in my organizations. So the first thing I am going to do is create a user for myself. I can go on Users, and I am using the IAM Identity Center user directory. I could federate that with Microsoft Active Directory using the AWS AD connector for that. I am going to choose the username ref. I am going to generate a one-time password that I can share with the user, or I can have the service sending an email to that user with the password and instructions on how to change. I am going to add an email address for that user. Confirm the email address. Right? So I can provide more information. This is a directory, so I can put address, I can put preferences. Next, I don't want that user to be part of any group for now. I will just choose the option add user, and I am going to copy that user password to my clipboard. Now, I am going to what we call a permission set in IAM Identity Center, and I am create a permission set. Create permission set. I want to choose a predefined permission set, in this case, administrator access. Choose next. Created the administrator access permission set. Now I am going to choose AWS accounts. And for my surprise, or not, the account I created under Customer A Dev Environments is already here. So you can see that IAM Identity Center and AWS organizations, they are best friends. When you create an account in AWS organizations, it is ready to be used by IAM Identity Center. So I am going to click in the account Dev Workload A that I just created. I'm going to Users and Groups, and I am going to assign users or groups that are able to access that account, remembering that these users are IAM Identity Center directory users. and I am going to choose the administrator access permission set that I just created. What I am telling to the service now is that ref can use that account with a permission set of administrator access. Now, when I choose submit, it configures some roles in the AWS account that will allow the single sign-on to be made. And that single sign-on is made by a dashboard. So you can copy the AWS Access portal URL and paste that in a new browser. You will see an interface allowing you to put IAM Identity Center users, such as the one I just created with the password that is in my clipboard, and signing in. The system asks to change the password on the login, so I am going to change the password now. All right. And now I am setting a new password. So this user, ref, is a user that only exists in the IAM Identity Center user directory. Once that user logs in, the user can see AWS account, see the accounts they are authorized to access, and they can now choose between command line or programmatic access, or a single sign-on URL to go to the management console for that account. If I choose command line or programmatic access, there will be instructions to get access key ID and secret for that account, which is ephemeral, it's temporary. Or if I choose management console, single sign-on working right now. So with a user in IAM Identity Center that I just created and assigned permissions, I am able to navigate and move from one account to another by doing single sign-on. This is the very same account that we created, which is the account for the developer. And if I go to EC2 instances, I will see that the EC2 instance is there, which is the EC2 instance that I just created. And this is an account that I accessed via IAM Identity Center that is part of the AWS organizations with the SCP. So same thing here, if I try to launch instances that are not C2 Micro, then the launch operation will fail. All right, we just discovered a way to perform single sign-on to different AWS accounts in my organization. IAM Identity Center and AWS organizations are best friends. So when you create accounts in AWS organizations, they are ready to be configured in IAM Identity Center, as you just saw in the demo. Let me go back to the table and place AWS IAM Identity Center in the management account or shared services account, which is where it should be configured. There are some AWS services that provide you logging capabilities. When I talk about logging, I mainly divide it into application logs and infrastructure logs. Application logs are mostly data like web server access logs, error logs, database logs, or logs generated by exceptions in source code. App logs are the kind of information that helps you identify and troubleshoot application issues. This can live inside your servers or inside a managed service like CloudWatch Logs or even Amazon S3. AWS Lambda, API Gateway, Elastic Load Balancing, S3, static website hosting, and Amazon CloudFront are some examples of services that integrate app logging with Amazon S3 or CloudWatch Logs. When configured to do so, you can choose a bucket or a CloudWatch Logs log stream that belongs to the same or to a different AWS account. You can also use CloudWatch Logs to make custom API calls to send your log files. After data is in a CloudWatch Logs log stream, you can navigate from a centralized place and query your data by applying filters on specific fields. For example, you can filter for HTTP 404 errors in log streams from your web servers. By doing that, you can create a CloudWatch metric, have a CloudWatch alarm, or even use machine learning for anomaly detection. Infrastructure logs are data produced by infrastructure change events, such as IAM calls made to an AWS account or infrastructure differences between these API calls, like how it was before and after the change. Networking and security logs are also in this category. These are helpful for infrastructure administrators to have some sort of paper trail about the environment. It is useful for auditing and even doing forensic analysis to find out when an event happened if something goes wrong. Some AWS services that can do infrastructure logging are AWS CloudTrail, AWS Config, VPC Flow Logs, and Amazon Guard Duty. In this video, I am going to focus on how to configure CloudTrail to concentrate data in the shared services account in the organization. Navigating through the AWS Management Console and finding CloudTrail is pretty simple. You just search for Trail on the search box. When you find CloudTrail, you can find an interface that will allow you to create a new trail. By creating a new trail, you can give that trail a name, and I will call it Centralized Logging. And now there is an option called Enable for all accounts in my organization. I will surely click on that, and I can have the option of creating a brand new S3 bucket for these logs. I can disable KMS encryption for now, just to make the demo simpler, and hit Next. Now I can choose which type of events I want to log by CloudTrail. In this case, I just want management events, which captures management operation performed on your AWS resources. By hitting Next and Create Trail, it is configured. It is that simple. So now I have a trail in CloudTrail called Centralized Logging. It stores everything in the S3 bucket from the account. And it's a bucket called AWS CloudTrail Logs, and then an ID, a random hash. I can choose the prefix CloudTrail. I have nothing so far because it takes a while to generate logs. But let me do a test by using AWS Single Sign-On or AWS IAM Identity Center and going in one of the accounts and doing some activities. So I am going to open my IAM Identity Center and log with my user. And I will do a single sign-on to one of the accounts, which is the dev workload A, Management Console. And I am just going to do some API calls, some navigation on the EC2 console. I will choose instances to see what instances I am running. I'm going to see what are the instance types. I am going to Amazon S3 and see bucket contents. So I'm just doing some API calls in one of the child accounts in my AWS organization's account. So I'm just navigating through the console, create bucket. I could create bucket. I could go on SQS and see the queues. I'm just generating some traffic for CloudTrail to capture. So create a queue, for example. Created a new queue, right?
A few minutes later.
If we go back to CloudTrail in our shared services account and choose the centralized logging trail and see the trail log location, which is the S3 bucket that is logging all that activity, that S3 bucket will have AWS logs /o/an ID. That's the ID for our AWS organizations. And then it separates per account. So right now we are in the shared services account, which is the ID 3061. I did the API call in a child account, in the developer account. So I'm getting the ID 4718 and CloudTrail, US East 1, 2022, and then a timestamp. And these are the compressed log files for the API activities I did on the account while I was browsing the account, logged by AWS Single Sign-On. So you can see that the information is in the bucket, and this bucket belongs to the shared services account. We now have CloudTrail data from all our accounts concentrated into a single S3 bucket. Now remember the SCPs, the service control policies? These are AWS organization policies that are applied to the entire AWS account scope. Also, remember you can add explicit deny statements to SCP policies, like the one we made with our dev environments preventing instances other than T2 Micro to be launched. A security best practice is to apply an SCP in the root of the organization, explicitly denying API calls that would remove or tamper with the CloudTrail configuration and the bucket objects. As you might notice, CloudTrail makes it easy to have every account in AWS organizations, existing or new ones, ship data to one account. It configures everything with the push of a button. So far, we have AWS organizations provisioning new accounts and roles, AWS IAM Identity Center providing single sign-on, and now I am adding AWS CloudTrail in my shared services account. But what if we want to implement an account provisioning factory? Something that would automatically deploy infrastructure stacks whenever new accounts are created. That could be useful to create account templates with built-in configuration and also centralized application logging, such as having centralized CloudWatch logs, log streams. This would be very helpful for our customer. Using an account factory would help a lot on that. If you're wondering if that is possible, stay with me for the next video. Alright, so far we have the following. AWS Organizations provides account creation and deletion, service control policies, control security guardrails, single sign-on with IAM Identity Center, and there is centralized logging with CloudTrail, sending logs to a single account. What about custom environment provisioning? Like the entire dev environment for a new account. Imagine the following scenario. Let's say our customer has a new developer on the team. Her name is Maria. Maria spends her first day in IT support getting her laptop and configuring things on it. She spends her second day learning about the code and meeting other developers. As she learns more about the code, she realizes she can contribute to the project. Maria needs a dev environment that matches production, and she doesn't want to spend even more time configuring environments in her laptop. The team has dev environments in the cloud for each developer, and Maria wants to know if there is a way for her to get access to an AWS account with an AWS Cloud9 IDE and access to some AWS services so she can start developing and doing pull requests. Question is there a way to set that up automatically for her? The answer is yes, and it can be done by a managed service called AWS Service Catalog. You can use AWS Service Catalog to create and manage pre-approved portfolios and products. Imagine AWS Service Catalog as an infrastructure vending machine where users can get products to use. It uses AWS CloudFormation as the creation engine, and it works like this. The portfolio admins can build CloudFormation templates to provision AWS resource. This is called a product. Each product can be added to a portfolio, and users like Maria can browse the portfolios and launch products in their accounts. For example, you can have a portfolio called Dev Environments, with products that launch different dev environments according to your team's needs. You can have a product called Single Instance SQSQ and API Gateway for Project A, which will launch a T2 micro instance, an SQSQ, and an API Gateway endpoint pointing to pre-configured mock Lambda functions. These building blocks are very convenient and safe because by using them, you start having infrastructure recipes that can standardize your architecture. You can specify instance types, service configurations, proper tagging strategies, security guardrails, and actually everything supported by AWS CloudFormation, which is a lot. But wait a minute, you may be asking, if your developer has an account that has just been provisioned, how would the entire service catalog be there and ready to use? Because new accounts created by AWS organizations are pretty much empty. And I still haven't learned a way to automatically configure stuff for new accounts. There must be a missing component there. If you're thinking like this, you are correct, but things will change for the better by introducing AWS Control Tower. AWS Control Tower automates account deployment. If you imagine AWS Service Catalog as a resource vending machine, you can imagine Control Tower as an account vending machine. See the difference? Do you see that each service has its own scope? AWS Service Catalog mostly runs within one account. Control Tower can create new accounts and automatically deploy not only AWS Service Catalog portfolios, but also everything else as soon as the accounts are created. But AWS Control Tower goes beyond that. You can configure landing zones, which runs CloudFormation automatically when new accounts are created. You can use that to deploy a service catalog in the account and/or everything else you need automatically without needing to manually launch anything. This is helpful for preventing account drift. Drift in this context means divergences, or things that are not standardized across your accounts. By having a way to automate account creation and provisioning by configuring resources, we can customize everything. By using the AWS Service Stack, we now have a solution that creates new accounts with AWS organizations, applies security guardrails with SCPs, authenticates users into accounts with IAM Identity Center, and has CloudTrail centralized logging. I am now adding AWS Control Tower to the Shared Services account because it is the service that will automatically configure new environments on newly created accounts. These environments can deploy a portfolio of products for developers to use in their own accounts. So I am also adding AWS Service Catalog to our diagram as well, in the developers account. Now, AWS Service Catalog can be used to deploy environments that have built-in centralized application logging, sending log to a CloudWatch Logs log streams in the Shared Services account. So let me place CloudWatch Logs in my Shared Services account right now. It's a lot, I know, but now it seems that we have architected a multi-account strategy solution that meets all the requirements from our customer. Now that we have enough knowledge, let's show them the full architecture. It's time to call Morgan again. Our solution seems to be complete. We are ready to call our customer and talk about it. So let me call Morgan and explain a little bit more about the services I am going to use for our multi-account environment.
Hello.
Hi Morgan, how are you doing? So I have good news.
I'm hoping that you've devised a plan to rectify our massive AWS account with solutions for Account Factory and things like that.
You were correct. I did it. I used some AWS managed services. We will create a new account, which will be the Shared Services account. That account will have AWS organizations to configure new accounts and also provide security guardrails with the use of SCPs, or Service Control Policies. In that Shared Services account, we will also configure IAM Identity Center, which is a service that will provide single sign-on to other accounts created by AWS organizations. We will also have centralized logging with AWS CloudTrail, and we will be using AWS Control Tower and AWS Service Catalog to orchestrate the configuration of new accounts and environments. Service Catalog will provide infrastructure workloads already capable of logging application logs to a CloudWatch Logs log stream in the Shared Services account.
Wow. All right. That's a lot, but that's great. I do have a question though, and that question is, how are we going to implement this? Like, what's the plan?
Yeah, that's just the schema, the model. There are mainly 3 large steps, and they are not something you're going to do in an afternoon. As I said, what I am presenting to you is just the architecture schema, like the scaffolding. After that, we need to devise a plan to create our infrastructure stacks like infrastructure as code. When we have that, we will be able to start doing workload migrations to new accounts. During that time, you will experiment with infrastructure as code and account deployments. When you develop some maturity, when you have the grip of it, then we start thinking about database migrations to these new accounts. You can use some other managed services like AWS Database Migration Services or DMS to move data while keeping databases online. And again, this is not something you are going to do in an afternoon. It requires some time, but this scaffolding for sure is an initial step to be familiar with governance and managed services.
All right, thanks, Raf. I'm pretty sure this is going to help us a lot. And honestly, with the company, the way we've been running things now with AWS, it's been making me anxious. So this makes me feel a little bit better knowing that there's light at the end of the tunnel. We have a plan in place and we're going to fix it.
Yeah, I think that's better than using the root account, right? To log in a single account with all the services. I'm glad I was able to help. Let's talk later. Thanks and bye, and call me anytime you need any question.
I'm sure we'll talk soon. Thanks. Bye.
Bye. All right, now Morgan and I are here in front of the camera and we will both play solutions architects roles. Let's take that multi-account architecture to the next level. Ready to begin talking about some?
Yes, I'm ready.
All right, nice to have you back as an SA.
Yeah, glad to be back. All right, so to kick us off here with this architecture, I'm going to recommend that this customer refines the use of their service control policies with AWS organizations. So something we heard from our customer is that they were using the root user. And so something you can do with organizations' service control policies or SCPs is to restrict the use of the root user across the member accounts.
Like the developer accounts or other accounts that are created, right?
Exactly.
So they are created with a root user with a password that you don't know what it is.
Right.
But you could also recover the password by going forgot your password.
Yep.
In this case, if they have access to the root account of developers' accounts in the organizations, the root could do anything.
Pretty much
and you're
anything.
telling that because the SCP applies to the account level.
Right. So
Right.
what you can do with the SCP is basically say, I'm going to restrict specifically the principal of the root user from making a list of AWS actions. You could restrict all AWS actions if you wanted to for like EC2 or whatever you're trying to restrict. So that's the first thing that I would recommend. And the second thing, which is just another use of the service control policy with organizations, is to make sure that the member accounts can't disable things like CloudTrail in those member accounts. So again, it applies at the account level, it's account-wide.
Yeah. You can put SCPs on the root organizational unit, which encompasses every single
Every
account,
account.
including the main account or the shared services account.
Right.
So you can put an SCP explicitly denying CloudTrail configuration and the buckets from being tampered, right?
Right. So what else can we do with SCPs?
Another thing that I have in mind here is also on the SCPs spectrum, rejecting console logins from IP addresses that are not from the office or from corporate VPN.
So you would do that with conditions in the
You
policy.
can do that with conditions in the policies, yeah. So if you have an IP address list of the IP addresses from the office or from the VPN endpoints, if you're using VPNs for the CCOE members, the Cloud Center of Excellence members, to connect into the account, you could restrict only to allow IP addresses from known IP addresses like the office or VPN
Yeah,
connectivity.
and that makes sense because that's what a lot of companies do for on-premises, right? Is if you want to access corporate
Restrict
resources,
the
you have to
physical-
come through
yeah.
the VPN, so you're coming from a specific IP address. The same type of idea applies here, and you can enforce that with SCPs.
All right.
So another type of policy that you can use in an organization is called tag policies. And so one of the things that we were talking about with this customer this week was the fact that we have all these resources and they're not tagged uniformly. So one of the best practices with AWS is to make sure that tagging is applied uniformly across not only this shared services account, but across any member account within your organization. So organizations allows the use of something called tag policies, which you can enable, and that will help you to enforce tagging schemas or your tagging requirements across the accounts.
Yes. When you use tag policies on the SCPs, it prevents users from changing tags that are deployed on services that are already running.
Yep,
Right.
and one example of that is that tags are case sensitive. So like let's say you have like cost center where it's like this, both C's are capital. If one has a lowercase c on a different tag, it won't group together correctly.
Yeah.
So you have to make sure that tagging is enforced case sensitive across all of the accounts.
All right, all right. Another thing that comes to my mind is enabling billing alarms. So you can go to the CloudWatch console from the shared services account, and if you see the billing metrics, you will have billing per account. So if you have like 10 accounts, 15 accounts, 50 accounts, each one of these accounts will have its own billing metrics, and you can create alarms for it. So you can create billing alarms individually per sub account.
And you would see that all from your shared services
Yes.
account.
Yes. It's a CloudWatch metric. Then you can have the billing. So that's important. And you can create billing alarms. So if inadvertently one developer forgets to turn off an instance or spins up a wrong instance type, you can have the billing alarm there. So
Exactly. So another thing that I would recommend here has to do with IAM Identity Center, and I would recommend that they enable multi-factor authentication for the single sign-on through Identity Center. So for multi-factor authentication, what we're talking about there is you normally would log in with like a username and password with your identity provider, but we would recommend that you also are going to use a secondary factor like a key that generates a string, things like that. So that way you're adding that extra security to the people that are logging in through Identity Center.
yes, that's a very good idea. Another idea that I have in mind here is we have our AWS organizations in the shared services account. We have OUs like customer A with the dev accounts, prod accounts, QA accounts, different organizational units. As the things progress, these organizational units may have different SCPs applied to them.
Right. So like, for example, like the developers are going to need different access than like accounting.
Exactly. And usually developers' accounts are a little bit more permissive because they may want to experiment new things, and production accounts are more reinforced in terms of what users can do. You would like to put an SCP right in the shared services account to prevent unauthorized users from moving child accounts from one OU to another. Someone that wants to spin up something in a prod account, they may, let me move, okay, I can't do in the prod OU, so let me move that account to the dev OU, spin up the resource, and then move it back.
Right.
So you can put an SCP here to only allow really authorized users to move accounts between OUs. Right?
That makes sense. All right, well, thank you, Raf, for helping our students understand more about multi-account strategies this week, and with the help of all of these lovely managed services that we have here. Here's CloudTrail. So how do you think that went? Went pretty well.
It was good.
Yeah. I had a good time.
Yeah. This is AWS Service Catalog.
Oh, hi there.
You feel me?
Yeah, hi. I guess we're just cleaning up here. Don't you know that you've reached the end of the course?
Yeah, that's a wrap for this one. You've finished all the content. Congratulations. Since you're still around, let's recap what you learned.
Yeah, so in week 1, we designed a serverless solution to host a web backend using services like API Gateway, Lambda, DynamoDB, SQS, and SNS. You learned about event-driven architectures and decoupling solutions on AWS.
In week 2, we helped our customer design a solution for data analytics for restaurants using services like Kinesis Data Firehose, Amazon S3, Amazon Athena, and Amazon QuickSight. This solution was all serverless and easy to use. All in all, it was a win for our customer.
Then in week 3, we had a customer that needed a hybrid deployment for containers. You learned about services like ECS Anywhere, Systems Manager, AWS Database Migration Service, and Storage Gateway. This one had a lot of different services, but it gave our customer a great starting place for running their hybrid workloads in AWS.
And finally, on week 4, we heard from a bit of an anxious customer who needed help organizing and securing their AWS accounts. We gave them a plan on account governance that included services like AWS Organizations, IAM Identity Center, AWS CloudTrail, AWS Service Catalog, and AWS Control Tower. That was a huge step forward for them, and they can go now forward and implement the plan we put in place.
So yeah, lots of content covered here. Nice work in completing this course. But that's it now. This is the end. So we will see you next time. And thank you so much from all of us here at AWS Training and Certification. Please check out our other courses and keep on learning.
All right, as we always say, work hard, have fun, and make history. Time to go. Now, I got it, everything.
Yeah, I think we have everything. Here you go. That's the last one.
All right. Alexa, turn off studio lights.